So, clean architecture mini course take 3. Hey YouTube, it's Derek from DevMentors, and yeah, here it is. Finally, we've managed to deliver something. So this is the first of 2 announced mini courses here on the YouTube. And this one, as you can already see, is about the clean architecture and CQRS. The other one will be handled by Peter himself, and it's going to be around Christmas time, hopefully. So by the end of the year, you should get both this and Peter's material. So we are thankful for all your support, and we hopefully you'll like both videos and you will find it useful in some way. And yeah, I've got the notes in here, so sorry for that I will sometimes look at them, but I don't want to skip anything. Yeah, I think that before we actually jump into the topic, I would like to just briefly discuss the history behind this clean architecture stuff, because actually this material was one of the reasons why we didn't deliver further our modular monolith series. And the reason is very simple. We've kinda finished I think 2 modules in there, and both of them were pretty much CRUD-ish. There was no that much, I would say, domain logic. It was rather simple when it comes to domain. The idea was just to give you some sort of starting point, and we wanted to wire them using the asynchronous integration. And yeah, that we delivered. However, at some point we wanted to introduce something more robust when it comes to domain, and part of that material was dedicated to clean architecture. The issue though was that we covered the clean architecture during our microservices.net course, so not the DShop one that we have here on our YouTube, but rather the one which is available on our platform. So clean architecture was one of the topics that we covered them. And yeah, we thought like, okay, we are going to discuss exactly the same thing. So for the people who are already familiar with the concept, they will need to skip this, and this will not bring any value. The other thing was that we thought that the clean architecture itself, it's not tied to modular monolith. It could be just a regular monolith. This could be a microservice, anything. So we kinda were scared about the fact that this could be lost in this modular monolith series, and maybe this could bring it could bring a value to someone. But if you haven't followed the whole series, maybe you'll basically not get into this one. So we decided that it's the best to basically extract this, put into separated video, and we could refer to this from different materials. So there will be no need for repeating in every single course the same sentences, because it makes no sense for us. It's not fun for us, and it would be just making the videos longer and longer. In that case, we'll have this material. If at any point in the future we'll need to reference or we'll need to mention the clean architecture, we'll just say, okay, this is the video, go watch it if you don't know the concept. Simple as that. So without further ado, I think that we are now ready to the theory. First, I would like to just briefly discuss first the concept that you might be already familiar with, and that was partially mentioned in the trailer. So the layered architecture, and then we'll try to compare it to, I would say, the one that you came for. So to the clean architecture. So first things first. I will use the term layered architecture quite often in this video. So I think that it's good to first think about some sort of definition, so we'll be on the same page. So what I mean by the layered architecture is this very specific setup in which you have at the very bottom data access layer. And yeah, data access layer, as the name says, is basically the layer responsible for your data access. In like 99%, this will probably be the database. But yeah, there may be a situation in which you store the data in the file system. Maybe you use some additional third-party web service like, you know, S3 or something, blob storage, whatever, or the cloud provider. So yeah, basically we'll have some sort of layer that will be responsible for encapsulating this data access. On top of it, you'll have the application layer, sometimes called services layer, which for me is like just like bizarre. I mean, calling something services is not very precise because service might be a different thing and might, you know, mean different things. So application would be more suitable for me. And basically the application layer would orchestrate the whole process. So that it will contain, in this specific case, I would say that it contains both process and domain logic. And on the very top, you have the presentation layer, which could be kind of misleading for the web developers because you already, when you think presentation layer, you probably think about the UI. So maybe there's some like, you know, Razor pages, like something else, WPF or something related to the screen. But basically you can think about this as some sort of entry point to our application. So let's say for the mobile app, this might be some sort of project related to to the mobile screen. Maybe for the Windows application, this could be something like WPF, maybe some sort of Xamarin, etc. For the web developers, especially if you're only specialized in the backend, this will be just the web API. So our entry to system will be the web API. So I will say, okay, if you want to perform certain action, this is the endpoint. This is, let's say, post method that you need to call. So I would say this is briefly when it comes to the layered architecture, and this is what I mean. I know that there are different types of layered architecture, but the one that I'm going to discuss is this specific setup, which I found pretty popular at least a few years ago. Maybe that's specific to Poland, so the country where I live, maybe, but I think probably not. Now, I don't want to get into the history on why this could be very popular, etc. I would like to focus on the stuff that I don't really like about it. Because honestly, there are not many things that I really like. It's rather simple, it's rather no-brainer, does not require a lot of knowledge. So you could think about this as some sort of advantage of this approach. But on the other hand, there are quite few more critical disadvantages that should be discussed first before we move into the clean architecture, and we could see how this actually solves those issues. So the very first thing would be the fact that this whole approach to me is rather data-centric. And to give you some sort of retrospective from my own life, how do I interpret this? Yeah, I would just like to briefly talk about my first greenfield project that I was involved in. And that was the time when I wasn't very experienced, and that was the time when I was referring to trailer of this course. If you haven't seen, then there is a card. You can watch this 10 minutes long video during which I make myself an idiot. But honestly, at the very beginning of this trailer, there was a title that said that this is kind of based on the facts. And the reason I put this title was because I used to be a Kevin. I used to be a guy who, thought that the layered architecture is like, state of the art. Of course, that was because I was not experienced. I didn't have enough knowledge, and I didn't see a lot of disadvantages of the layered architecture approach. And what is crucial to this whole story is that at that point, and I think this is pretty common when it comes to junior developers, is that I favored technicality and technical stuff over the domain and over the business value that I was hired for. And the second thing was that I would honestly say that at that point I didn't get very crucial concept, which is the model or the object that you have within your application. Let's say product. If you have the class named product, it doesn't necessarily be just one ultimate representation, which is used for data access, for the, let's say, databases, for the application, for the domain, and for the transportation. There could be different representations and you just need to map between them. But at that time, I basically thought that, okay, I've got one ultimate model, which this needs to be reusable in database and in different layers. So this actually caused a lot of issues. And yeah, let's just jump into the story and hopefully you will see what I mean by this, and you will also understand hopefully what I mean by the data-centric approach when it comes to layered architecture. So when I started this project, and yeah, we actually received, like in the trailer, we received like half-page briefing, and so you can already see that my knowledge about the domain and what we were going to do was very limited. And of course, we had like meeting scheduled during which we wanted to discuss the requirements and what we actually want to achieve by doing this application. Yet still, once it got announced, the very first thing I started doing was the thing which was for me at that time the most important when it comes to the software development, and that was the database. And yeah, the issue was, maybe not the issue, but the reason for this was very simple. I mean, for me, the application was just the facade between the database and the client, and that was it. You know, if you're clicking a button save, eventually this gets into the database. If I'm getting button get data, the data comes from database. So for me, the database was the heart of the application. And yeah, I started doing these diagrams. I think at that point I just graduated, I think, my bachelor, so I'm not quite sure, but yeah, I still remember this whole notation, and I created the diagram on the paper first. Later I used, I think, some sort of software for those diagrams, and yeah, I was very proud of it. And of course, almost none of those concepts and those relations got into the production at the end of the day. But at that point, it didn't really matter. I mean, I was really into those databases, and of course, I was using the relational database, relational model, because I didn't know any other, and I thought that this basically can solve any issue in the world. So yeah, I already knew that I'm going to use the SQL Server. I already knew that this will be relational database, and I've got my diagram on paper. And yeah, and then the natural continuation was the code base. So I started to develop the application. And that's where I would say that the layered architecture kinda helped me in a bad way to develop this whole crap. Because if you think about those layers, so data access layer, application, and the presentation, there are two possible ways of implementing it. So the first one would be going, I would say, top down. So you start with the controllers, and then you go to the application service, the application layer, and to the data access layer. However, it doesn't really work, because as soon as you will start writing your controller actions, you will realize that, okay, but this action is supposed to call the application layer, yet still I don't have the implementation. So you need to go to the application layer, write the at least abstraction, but ideally you probably would like to have some sort of implementation already. And yet still you'll realize, okay, but this application layer orchestrates and yeah, it needs the data access layer. So you need to go to the data access layer, implement it, and eventually you can finish up the application layer and the controllers. So I would say that the top-down approach doesn't really work. So at that point, for me, it was way better to go bottom-up. Not only because you don't have this issue with dependencies, but also since I already started with database first approach, the code that was closest to database in the application code was data access layer. Yeah, so I was doing this, and yeah, at that point we used like Entity Framework 4, I guess, maybe 5. So me as a junior developer, I went to MSDN and I was reading the documentation and I've seen this. And yeah, I mean, this is perfectly legit, right? You have the classes with public getters and setters, no methods. And this is how you create your entities. And as I mentioned, to me, this model, this class, was not only for database purpose, but also for the domain and for the transportation. And at that point, I also didn't realize one crucial thing. The whole purpose of this documentation is not to teach me how to create a proper architecture. I mean, this is created to show the capabilities of the ORM, and that's pretty much it. And of course, this ORM might have some sort of limitations due to underneath implementation. Maybe they use some sort of reflection or something else, and this is why everything needs to be public. And maybe you need to put the virtual, make the property virtual or something else. But at that point, I didn't realize it. To me, that was kind of natural. That what is on the MSDN is the state of the art, and I cannot change it. So yeah, I finished the data access layer, and once I've got it, I could move up to application layer. And of course, because I had no encapsulation within my entities, and I still needed to perform some sort of domain logic, there needs to be a place in which I will put it, right? Because otherwise this will also will be responsible for preventing the further leaking to the controllers. I need to place in which I will basically encapsulate all those rules. So naturally I came up with the services. So this application/domain services, which basically were doing everything. So orchestrating the process, but also keeping all the validation rules and setting the proper values into my entities. And that was it. That was the whole point of my application layer. Yeah, and on top of that, I've got, like regular ASP.NET Core controllers and actions, and they were not pretty. Contained some unnecessary logic also, which I, for some reason, didn't put into the services, but who cares, right? At that point, I really didn't, and that was pretty much it. And of course, the reason for telling you this embarrassing story is to give you this flavor. What I did from the perspective of, from today's perspective, what I really don't like about this whole layered architecture approach is that it helped me focus more on the data and the technicality rather than on the domain and the behavior itself. Because I started from the technical layer, technical concern, and further the domain and the orchestration of this domain was just an addition to what really mattered to me, which was the database. So that's the disadvantage number 1. And the second is actually more fun, because this particular setup, when it comes to layered architecture, breaks one of the holy solid principles, which is dependency inversion principle. So let me just go to the definition of the dependency inversion principle. I've got the Wikipedia page, and yeah, of course you might ask why I'm reading this instead of just saying this from my head when I don't know it. Well, the reason is very simple. I honestly don't know the exact definition. I follow the solid naturally on my daily basis, but I don't know the exact definition. I only know that before the job interview, which I don't plan to attend, at least at some closer time, unless my boss will see this video. So, dependency inversion principle says that high-level modules should not import anything from low-level modules. Both should depend on abstraction. And there's also paragraph B. Abstractions should not depend on details. Details should depend on abstractions. So, when we think about this particular thing and this principle, actually it doesn't fit into what we have in here. I mean, we have the low-level concern, which is in our case the database and the data access, and yeah, the application depends on this, so it violates it, right? I would say in this particular case, we rely on the, I would say, more like implementation detail rather than the abstraction. And of course, it's like someone could say, okay, Derek, but that's kind of bullshit, because within my data access layer, I can create nice abstractions, and let's say I will create the implementation, which will be internal, but I will only expose the capabilities of this class via the public interface. So I will have nice abstraction which you can inject, you can use it for the tests, etc. And that's true, and I totally agree. The issue that I have personally is, if you think about, let's say, data access layer, and let's just assume that you are using entity framework, so probably you will have the dependency to entity framework in your data access layer, which means that even though you have nice abstractions created and you encapsulated, let's say, DbContext, in theory, there is nothing that could stop me from using the entity framework DbContext directly in my application layer, and let's say creating my own DbContext in there and using it as some sort of shortcut for accessing the data. And that's because I have indirect reference from the application layer to entity framework core, right? Because to the entity framework in general, or to any other ORM. Application sees DAL sees, let's say, ORM, so I have indirect reference. So there could be a situation in which you as a developer, you've got a deadline or something, and you say, okay, screw it. The abstractions provided by the other guys are just too limited for me, and I need to look into a few different tables and do the quite complex projection. Screw it, I will just do raw SQL, and I will just write this into my application layer, and I will create one ultimate projection which will be returned further to the presentation layer. And there's nothing that you can do about it, because okay, you used your developer skills to hide this behind the abstraction, but from the technical point of view and the way you structure it by the concepts, you basically broke the DIP. So this means that even that you that you tried your best, I can still use EF directly without your abstractions. And that's the issue with this particular approach. All right, and I would like to summarize this section by reading the definition from Eric Evans' DDD book. So this famous blue book of the domain-driven design. If you haven't read it yet, I mean, I'm not quite sure what you're actually doing with your life. You should definitely go and read it, probably more than once, because yeah, I found that every single iteration gives you, I would say, a few details more that are hidden within this book. So great source of knowledge about understanding the domain and how we can actually model it and put into our application. So in fact, something for which we are paid, right? We are not paid, and that's, as I mentioned, to me it's kinda funny, because on the one side I really get the fact that we as a developers are really into the, you know, cutting edge technologies and frameworks, libraries, because it's kind of fascinating. But at the end of the day, unless we have very specific job, yeah, we're paid for delivering the business value. And I think that sometimes we basically forget about it. Anyway, the Eric Evans book contains, as you probably expect, the glossary for those of you who are as lazy as I am. And yeah, in this glossary you have the definition for the layered architecture. So it says layered architecture, a technique for separating the concerns of a software system. So far this actually is fine, and the layered architecture fulfills it, right? We have each of the layer has its own responsibility. So far, yeah, we have different concerns spread into the layers. However, the continuation is isolating a domain layer among the other things. And that's where clean architecture comes into play. Personally, I like to think about clean architecture as some sort of layered architecture done right. And the reason for that is very simple. Comparing to what we've discussed so far, this approach is domain-centric. It's not data-centric. So it favors domain over technicality. And you will see this immediately once we'll jump into the code. The domain will be the very first thing that we'll implement. And further, once we'll move on with the implementation, at some point, I would say that at the very end of this course, you will see more technical stuff related, let's say, to database, logging, cross-cutting concerns in general. So this is what I like, you know, today as a software engineer who's aware of the fact that, yeah, we need to care about the business, and I'm really into the domain-driven design, especially. I really like this approach. It's not perfect, it's not ideal, but we'll discuss this further, and I would definitely not use it in every single scenario, but it has quite a lot of advantages over typical layered architecture. So without further ado, let's just briefly discuss each of those layers, and yeah, we could finally jump into the code, because that's gonna be quite a long introduction. So let's start with the most important layer, which would be the core domain. And one more quite important thing is that, as in any layered architecture approach, we have the dependencies that goes inwards, which means that in this particular case, we have the presentation that sees the infrastructure sees the application refers to domain. It's not the other way around. Everything goes inwards. So the domain, as you can see, has no dependencies, and that's the beauty of this approach. This means that domain will not have any I/O operations, ideally. And if we think about it, that's gonna make our domain pure in many cases. And what I mean is that there will be quite a lot of pure functions within our domain. If you're not familiar with the functional programming, The pure function basically is the function which fulfills two conditions. First, for the same input gives the same output, and it has no side effects. So since we'll not have any, IO operations being involved, in most cases this will be basically fulfilled. Of course, assuming that there will be no randomness added, it should be pretty much pure function. And the whole purpose of this domain is to create nicely structured OOP domain models, which means that there will be no getters and setters, which are public. We'll have nice encapsulation within the objects. Each object will have its will need to keep the we'll need to take care about its internal state, about the validation of invariants within it. And it's pretty funny because, I mean, we are taught about this on a university or, some online courses when we start learning programming, but yet at some point we forget about it. And we just follow blindly with this convention that, my model will have getters and setters, no methods, and I will handle this somewhere else in the service. No, we in here in the domain will have object-oriented programming as it should be. And besides, we'll also have, this is a good place to incorporate the domain-driven design, which I will not cover deeply. I will discuss it later, but of course, if you have domain-driven design already, this will be the place in which the tactical building blocks could be put. So, aggregates, entities, value objects, repositories, factories, policies, everything could be put into our domain, because in many cases this will be just some sort of class that will orchestrate on the domain level something, or will construct the aggregate, and there is no IO needed for this. So that's pretty much it when it comes to the domain. We'll have few different things in there. We'll have the exceptions. We'll cover this, why we have exceptions on the domain and what are they used for. Once we'll actually jump into the code, it doesn't make sense to actually discuss such details now. We'll also have the repositories mentioned, but only the interfaces, so the contracts, which will tell us what I'm capable of doing with my entity, and domain events, which will be also partially covered in here. You will see how we can make the usage of them, and that will be pretty much it. The key thing that you need to understand is that in here we'll have pure C#. In our case, that will be pure C# class library with no dependencies, so we can focus on creating the objects and behaviors between them. And one more thing, actually, as an implication of having quite a lot of pure functions, is the fact that the testability of this core layer will be quite high. I mean, it should be at least very easy to test the core layer, because there will be no dependencies external. There's no need for using any test doubles like stubs, mocks. It doesn't need to be very complicated. In many cases, you will see that testing the core is just straightforward. So in terms of unit testing, that's quite a lot of advantages already. Moving up, we'll have the application, and the application is pretty much the same, has its same responsibility, just like in the layered architecture. So the idea is that we need to orchestrate our domain at some point, and this is the place in which we'll have the process logic rather than domain logic. And in here we'll also incorporate the CQRS. We'll also discuss it later, what is actually CQRS and how this may be handy for us. And this will be pretty much it when it comes to application, just an orchestration of our domain. And let me just check whether I don't miss anything. I think that's it. Of course, one thing that I need to admit, there might be a situation in which, of course, the application needs something more technical, And of course the application itself will have this ability to create, once again, some sort of abstraction like the interface, which could be implemented in the infrastructure layer and used within our application layer with any abstraction leaks. So once again, we follow this dependency inversion principle, and yeah, if application needs something more technical, it needs to define the proper abstraction, and this abstraction will be implemented by the infrastructure. It's simple as that, and this will prevent us from some sort of abstraction leaks, just like we could have in the layered architecture. Then we have the infrastructure, and infrastructure is all about the technicalities, all the technical concerns, the cross-cutting concerns. So, data access layer, some sort of, logging, monitoring, metrics, anything which is technical will be within our infrastructure layer. And yeah, because the infrastructure layer will have direct reference to application and indirect reference to domain, it can implement the repositories contract and, let's say, implement this on top of relational database or NoSQL database, and all the same goes for the application. If application defined any contract that needs to be fulfilled, yeah, the infrastructure can basically grab it and implement on its side, and there will be no abstraction link. And the very last layer is presentation layer. So in our case, since we are going to implement this on top of ASP.NET Core, this will be once again web API. And yeah, this could be actually anything else. This could be CLI, WPF, Xamarin. Actually, we could have more than one entry point to our application. We could create the REST API, just like we are going to do, but maybe for the developers' purposes, because we don't like to, run the Postman or any other REST client for our application. Maybe for us, it would be easier to create alternative entry to our system and create very simple console application, which would call, let's say, application layer or something. It's pretty much all up to us. So I know that at this point, this might seem kind of, I would say, similar, right? It's quite similar comparing to layered architecture, because it's just, okay, this is just a matter of arranging this slightly different. Yeah, but this is yet still layered architecture, but done in a way that Eric Evans actually described. So hopefully you will find it useful, and hopefully you will see the advantages. And yeah, I think that at this point there are only two things left. So we should first discuss some sort of, as my script says, prerequisites. So a few prerequisites. First, yeah, we'll have rather simple domain. And I know that at some point, it won't be the to-do list, but close. And I know that, some people down in the comments may say, okay, but, this is rather simple, and you should create something, more robust, more production ready, or something like, software for managing the rockets that are going into the moon or something. Yeah, I know that would be ideal, but I think that there are some sort of trade-offs when it comes to recording such a course, because on the one hand, I would really like to go into some sort of deep domain, but first, it might not be the case and the purpose of this video, and this whole video would take us way much time that it should. And then we'll also, because we'll have rich domain, we'll probably would like to incorporate the domain-driven design, which I really would like to, or like not to do. And the reason for that is actually number 2 on my list, which is that yeah, in general, in the whole application, there will be not much domain-driven design when it comes to tactical domain-driven design. And the reason is very simple. I want to save it for another series of videos dedicated to domain-driven itself, to the domain-driven design itself, both strategic and tactical. And that's also the reason why we don't have the rich domain. Some simplifications have been made, and that's also because, yeah, at some point I don't think it makes sense to follow the principles just to follow them for its own sake. If something could be done simpler, I wanted to go for it. Once again, not to make this whole course too long, which is ridiculous because I think that the introduction is already like 1 hour ago. 1 hour long. And the last one is that, and this is the most important stuff, don't take this whole course and the code that you're going to see as some sort of state of the art, the only valid solution. No, it's not. This is how I understand the clean architecture, how I would implement this. Probably Peter as well, because yeah, we're kind of close when it comes to the implementation. So yeah, we discussed such a thing. So Peter would probably agree with most of my arguments when it comes to particular parts of the system. But there are many developers on the world, and probably maybe you will not agree fully with what you're going to see, and that's totally fine. I mean, at the end of the day, if something works, or maybe you think that I'm over engineering something, yeah, if this will work for you, yeah, go for simpler solution. I mean, I don't see. I used to be very you know, into the principles. Now I'm more pragmatic. If you'll see something that could be simplified, you can write it down in the comments, and that's fine. Maybe this will be helpful for me personally, but also for the others. So don't hesitate to share it if you have any different opinions. And yeah, I think that's pretty much it. So the last thing, I promise, let's discuss the application that we're going to create. So I thought about it, and yeah, my very first thought was actually to-do list, because it's rather simple. But the issue with it is that there is not much domain. So I added a little twist. We're going to implement yet simple but maybe more fun application, which is going to be a packing list. So I assume that you're traveling once a while, and there's always the same issue, at least I have the same issue, is that I have my packing list that I'm doing manually. I'm packing my stuff to the back, and at some point I'm deleting the list. I don't care anymore. And once new travel comes, I need to create this from scratch. So the idea about this whole application is that it will accept some sort of input, and this input will be like the gender, location that you're traveling to, for how long, for how many days you're actually going to stay, etc. And based on that input, it will generate you the proposal, right? So your packing list, what you should actually bring with you. And yeah, there will be slightly, I would say that at the very first glance it doesn't seem very exciting, but on the domain level I wouldn't say it's that simple like you may expect. So I would say basic use case would be this packing list generation, of course simplified, because you'll see that it's not that simple, and basic management, like, you know, adding more stuff to the list, removing it, marking as checking this as already packed, etc. So this will be pretty much the scope of the project. We'll call it pack it, and that's because you know, pack it also could be pronounced as IT, which is not funny at all, but yeah, didn't have a better name. So Let me just check, but I think that we are ready to go after, yeah, I think like an hour. So I'm not quite sure whether anyone will get into this point. If you, I can actually leave a comment that you actually were going through all of those fascinating theory. And now let's jump into the code and see the clean architecture in action. All right, so as you can see, I jumped into my IDE, which in my case will be the writer, and I've already created solution with, as you can see, 6 projects. 4 of them are quite known to you already. I also added 2 called shared. So we have shared and shared abstractions. The whole idea is that, yeah, maybe we'll have some sort of piece of code that, yeah, would like to avoid putting into each of those layers, because maybe this could be like some sort of interface which will be shared all across our application, and yeah, would like to avoid the situation in which we put this into those layers. So this could go to shared. Maybe eventually this will get extracted into some sort of nugget package. Who knows? It's not required for our clean architecture, but I'll just decided to add it, and eventually we'll maybe use it at some point. So we have 4, I would say, layers which are most important for us for now. So we have the domain, and as you can see, this is just a simple class library project which is based on .NET 5, since by the time I'm recording this video, .NET 6 is not released yet. So I'll just stick to .NET 5. And as you can see, for now, it has no dependencies, just like we've discussed during the theory section. Then we have the application, and application has direct reference to our domain project. Moving further, we've got the infrastructure, which has the reference to our application, and our presentation layer, which in our case is just a web API. ASP.NET Core project actually will have the dependency to our infrastructure, and of course implicitly it has access to all those 3 layers, so application, domain, and infrastructure, because it's just indirect reference. So this is how it looks like for now, and let's just start with the domain, because as I mentioned, that's the beauty of this whole approach, that it's rather domain centric and not data centric. So we can already start focusing on bringing some sort of business value and creating the whole domain, rather than thinking about more technical concerns. So just to remind you, we would like to have this model that would allow us to, based on some sort of user input, generate our packing list. So for now, we can assume that this input will contain like 3 types of data. This will be a gender. This will be also a localization, or our destination. So let's say that I'm traveling to Warsaw, Poland. And the reason I'm asking user about this information is that based on this, I will call some sort of external service. This could be just assumption for now. Let's say some sort of weather API. And this API will return me the information about the average temperature. So I will, let's say, know that by the time I will be in Warsaw, the average temperature expected is, let's say, 10 degrees of Celsius. So it's not very, I would say, warm. So maybe you should take some sort of warm clothes with you. Based on gender, we can of course decide whether you should take, let's say, a bra or something. I mean, if you're a man, you probably don't need a bra, and probably you don't need any skirts or something. And based on the third parameter, which will be the travel days, so we can decide whether you should, how many, let's say, t-shirts you need to take, or trousers, or socks, or your underwear in general. So those 3 parameters will be our input. And yeah, based on this, we'll generate the proposal for the packing list of our user. So let's start with defining our packing list object. And yeah, I wanted to, as I mentioned, I want to avoid as much domain-driven design as I want, but already I need to create first directory and I need to call it somehow. So I will call this entities. And now entities are not the entities that you might, refer to entity framework. It will be rather the DDD entity. So I think it's fair to just give you a brief explanation what actually is an entity. So in terms of DDD, the entity is just an object with the identity. So for now, to simplify it, we can assume that basically there will be some sort of ID property or field within it. And of course, you could think about this as some sort of, technical identifier like GUID or, long or integer, whatever. But in fact, in many cases, there could be some sort of natural key, natural identity that you could find within your object. So I will give you a very simple example. If you think about, let's say, customer within your application, of course, you could generate a GUID, and this will be unique within the whole system, and you're safe to go. But if you think about the customer, maybe there's something more, I would say, human readable for you, some sort of more natural candidate, and that could be, let's say, the email address. In many cases, the system that you're building will have this assumption that, just one email can go to one customer and it needs to be unique within the whole system. So this could be some sort of natural identity for my entity, which in this case, this entity would be a customer object. And that's pretty much all you need to know for now, at least, when it comes to entities. And entities can be mutable. And of course, since I just want to remind you once again, within the domain itself, we want to do the proper OOP. So we'll not create anemic classes. We'll just try to follow the object-oriented programming and encapsulate this object nicely. So all entities within our domain will just try to validate themselves and keep their internal state just valid for the whole life cycle of their existence. So I will start with the entities, and the very first entity I will add will be the packing list. So packing list is our first and I think last entity that we are going to create. So inside I will just need few properties. So in this example, of course, I could, speaking about the identity, I could think about some sort of natural key, maybe like the name of this packing list. But on the other hand, when we think about the functionality, does this really bother us that user will create different packing lists with the same name? Probably not. So I wouldn't say it's a good candidate. And since the domain itself is very shallow, there is not much that we can do about it. So for now, even though I said that in many cases there is a natural key, let's just assume that for now we don't have any. And I will just create a public property with GUID as some sort of identifier. So we'll have the packing list with GUID ID. And of course, in this case, I would like to have rather private setter because I don't want to have it public. Otherwise, there will be no encapsulation, right? Okay, let's move further. So next we'll have, let's just think about what we actually need within our packing list. So probably our packing list will need some sort of name, right? So I will just create the public string name. So just like, so we'll have the name, and this name will be of course used for some sort of identification, but on like more human level. So I will not distinguish which list is, let's say, for Warsaw, which is for Paris, based on the GUID, because that will be tough. It's rather the name that will help me to know which list I would like to modify and interact with. And this actually already is some sort of very base entity that we could come up with. Of course, maybe on the UI we would also like to display the destination, because the name may not contain this information. So I think that the localization or the destination could be also very good, some sort of information that could be used for displaying this information. So I will add new string for now, which could be localization. So this will be get private set. All right, and I will just change it to this. And yeah, let's just reflect on what we've done so far. So we've got 3 properties on our packing list. So this will be for sure used somewhere. The identifier is our identity. The name will help us to differentiate different lists on the UI, and localization maybe could be also handy. So I will know that, let's say packing list called my awesome list actually is reflects to my trip to Warsaw and to Paris. However, we can already see one issue when it comes to object-oriented programming itself. The issue I have personally with this approach is that even though my setters in here are private, the getters are still public, right? This is the public property with just a private setter. So of course, I'm protected. So the packing list will be responsible for setting values on both name and localization and the ID itself. But on the other hand, there is once again nothing that could stop me from creating a logic built on, let's say, those 2 fields, two properties, right? So somewhere, let's say on the application level, someone could basically create some sort of nasty, weird logic that would say that, okay, if the name is X and localization is Y, then do Z. Why? I don't know why, but maybe someone would like to do such a weird thing. And I would like to keep all the domain logic within my domain, because the application is reserved for the process logic, not the domain logic. And if someone is building the weird processes on top of my properties, maybe that's the sign of not very good design. So I would rather do the following. I will leave the identifier public because I'll probably need it for, getting, let's say, from my secret place. I'm not want to say that from the database, because this doesn't necessarily need to go into the database directly, but we'll cover this lately. But I will, the identifier, since this is the entity and entity is all about the identity, I can leave it public. However, maybe the name and localization is some sort of implementation detail that I would like to hide from the outside of the world. So I would rather turn this into private fields. So instead of having this as a properties, I will rather go for the private fields. Now, keep in mind that this will actually have a huge impact on our further implementation. Why? Because once we had the public properties, we could easily, let's say, later use it for maybe ORM or some other DB driver to create the predicates, to create the filtering based on those properties. And now, since this is private, I no longer have an access to that. So creating any sort of searching on, let's say, ORM level will be significantly harder. It's not like impossible, but it's just way harder. So just keep in mind that this will have its cost. But I think that at the end of the day, since we are more favoring the domain over the technicality, it still pays off. All right, so this is the first thing the first issue that I've got with the previous design. The second thing is kinda this. I mean, we've got the name, which is the string. We've got the string that represents the localization. And I don't really like this approach because once we'll actually introduce the constructor for this, so we have the constructor, and we could actually even think about creating this as an internal constructor, because maybe I would like to only allow creating this public list via some sort of factory. I don't want anyone to call this constructor directly. So I could pass the identifier for for my constructor. I will also accept the string name, and I will also do the same for the localization. And yeah, of course I could assign this, right? So I would do ID, then name equals name, localization equals localization. So if you have ever read about, you know, some sort of code smells, you'd probably like immediately you could discover what's going on here. This one is quite well known, I would say, code smell called primitive obsession. And yeah, the primitive obsession basically occurs when you have the method, or like in this particular example, you have a constructor which accepts a lot of primitive types. Now you could say, okay, Derek, but I mean, seriously, what's wrong with that? I mean, the string name, what is wrong with this? I mean, string name, yeah, the name will be probably text. So yeah, in C# we have hello, one data type that can handle the text, which is the string, and the localization will be exactly the same case, right? Well, yeah, not exactly. I mean, of course, the data types are, the built-in data types are just perfectly fine, and I'm not saying that we should stop using them. However, data type, as the name says, is for the data and not necessarily for the behavior. So if you have any sort of validation, and once again, we want to have the object self-validated, like, you know, name cannot be empty. Of course, if the string name is null, I could create a logic somewhere in here, right? Like in the constructor, maybe I will create some sort of validation inside my packing list object, or even further, I could validate this on the application level or even on the API level. That's totally fine. However, yeah, the issue that I have with this approach is that, yeah, we're talking about self-validation and object-oriented programming, yet still this validation rule that the name cannot be empty leaks to the application or even further to the presentation layer, because we couldn't done this properly on the domain level. And yeah, we just need to make sure that every single time we're using the name, we'll do this proper validation. And of course, this validates also single responsibility principle, because if we will have a situation in which, like, I'm using the name in many places, every single time I'm using this name, I need to make sure that, yeah, that this is not empty. So I will either delegate to this logic to different object, like to packing list, to validate this, or I will do this in more, I would say, domain-oriented way, a more object-oriented programming way, in which I will create a separate object which will encapsulate this value, and it will be this object's responsibility to self-validate whether this actually is a correct value or not. And this is where another, I would say, tactical domain-driven design building block comes into play, and this is called the value object. So the value object, comparing to the entity, will not have the identity itself. So I could not compare two objects by their identities. So in our case, just IDs, and says, okay, this is the same object. The value object is compared based on its properties. Since I don't have the identity, I need to compare the two objects based on their properties. And if they are the same, I assume that this object is just the same object. And I know that this might sound kind of weird, so I will just do my best to give you some sort of maybe analogy in the real world. So let's just think about the following scenario. You're going to, let's say, some sort of store, and you would like to buy a computer, some sort of laptop. So you know already that this will be, let's say, Apple MacBook Pro with M1 Max processor and 32 gigs of RAM and 1 terabyte of storage. So this is the exact spec, and you all also know that this is gonna be the space gray color. Now, you're coming to Apple store and you're telling the spec, and the customer is telling you, okay, yeah, we've got this on stock. We've got 3 laptops on stock. would you like one? And for you, it's like, yes, I would like one. But does it really matter whether, the salesman will give you the first, second, or the third? Probably not, because each of them has the exactly same spec. And it doesn't really matter to you which one you get. It's just the matter of the spec. So for you, this MacBook is nothing more but, at this point, the value object. And for you, all those three laptops are basically equal. Now, the funny thing about domain-driven design and, entities and the value objects is that this not necessarily refers to every single context within your application. So from your perspective, in your context of you as a customer, this MacBook is just the value object. However, in different contexts, this MacBook could be now an entity. So let's think about the following. You're using your MacBook and suddenly it just breaks for some reason. So you're going to Apple service, you're calling them, you're bringing the laptop, and now you wait for the service to be finished. So for the service guy, they cannot just treat your laptop as some sort of value object and just compare the laptops based on spec. Because once I give you my MacBook, I assume that I will get my laptop with my data, my identity, Apple ID on that, and not the others. So now for the service guy, this laptop is rather an identity, which probably will be based on the serial number. So based on this, I will know that, okay, this particular laptop with this serial number belongs to this owner. So I need to make sure that once I will repair it, the same instance of laptop gets back to its owner and not to the other random guy who owns the same spec. So hopefully you will get the idea about what's the difference between the value object and the entity. So in our case, when we think about the name, which cannot be empty because let's say that this will be some sort of assumption, and localization, which could be actually more specific because for now we keep this localization as string, but maybe I would like to be more precise. So what city and what country I'm actually traveling to. Yeah, now I could create object that would encapsulate those values. And this object will be responsible for self-validation. And also I could basically, check whether two value objects are equal based on the properties, not on the some sort of weird assumptions. So I will just create one more directory called value objects. And yeah, let's start maybe with this name. So I'll create an object called packing list name. So the cool thing about now creating the value objects is that I would say that it used to be more painful in terms of the implementation, or maybe that was maybe not the painful, but it was less pretty. Because yeah, if you would like to, let's say, create a packing list name class, I would probably have some sort of value that I would encapsulate. So in this case, this could be called value or the name. I will just stick to this convention where I will just encapsulate a value, but yeah, it doesn't really matter. And one thing though, which is kind of important, is that value objects are by nature immutable. So if you need any change, yeah, you just need to create another value object. So this allows me also to to share the value object with other let's say parts of my system without fear that eventually if I will modify this by reference, you will have some sort of weird issues with data inconsistency. So this is the very simple assumption. The value object will be basically immutable. Now, if you would like, let's say past times before C#9 occurred, if you would like to create this equatability, you would like to implement iEquitable of t, when the t will be the packing list name parameter, and this will generate you based on the value string those equals and hash code methods. And now I would say it's not pretty, especially if you only want to validate whether this is not null or empty. I wouldn't say it's a good deal. Fortunately, since C#9, we have the records. So now, if I will change this packing list name to record, you could already see that this I equitable of t is now grayed out. And the reason for that is that the record by themselves, by their nature, will implicitly implement this interface. So there's no need to now explicitly implement this interface, and I can just remove it. So that's good. Now let's create a constructor for our packing list name. And inside here, I could validate whether this particular string dot is null or white space value, whether this is actually empty. If it's, then I would like to throw an exception. So I'll throw the exception, and of course I could do something like invalid operation exception or like invalid argument exception, etc. So the exceptions that are already built in my programming language, and that will be totally fine. However, I found it useful that it's rather better to create some sort of custom exception types, and that's because of a few reasons. I would say that it's way easier to test, and it's more explicit when you can create the tests on top of custom exception types, because yeah, invalid operation exception could be anything. While let's say empty packing list name exception is very specific. So I don't even, in many cases, don't need the message to know what's going on actually. It's the name which will be very explicit and will explicitly tell me that, okay, I didn't pass the proper value for my packing list name. So this is the first thing. The second one is that, the invalid operation exception and any single exception built in the language is, I would say, commonly thrown from different types of frameworks, because they are, if they don't implement its own exception type, then they probably use the one delivered by the language. So if I will got like invalid operation exception, now I wouldn't be certainly sure whether this comes from my domain or maybe from the application, or whether this comes from my infrastructure. While once I will create and introduce my own exception types, it will be rather straightforward. So this one will require another directory called exceptions. And before we actually move further, I would like to create my own base type for exceptions. And the reason is very simple. It will be, I would say it's way easier later, eventually, once we'll deal with the error handling, to filter everything that comes from, let's say, domain or from the application and was basically our custom exception type, rather than anything else. So just for this ease, I would like to create my own base type for the exceptions. So this is where our shared package comes to play. Of course, I could put it into our domain, but to me, it's like, this is some sort of concern that I would like to share all across my application. So maybe it's better to put it into the, let's say, the shared abstractions. I know that this could be for some maybe sort of overwhelming, but yeah, you can just get rid of those shared packages if you don't like them. It's all pretty much all up to you. So inside my shared abstractions, let me just create a directory called exceptions. And in here, I'll create my base type, which I'll just call packet exception. So just to know that this actually is my own custom type. And I will just mark it as abstract. So just to make sure that no one will create this type of exception. And this will be deriving from exception. And I can create the protected constructor, which will be packet exception. This will accept string message. Okay, and I will just pass it to my base type, and that will be pretty much it when it comes to packet exception itself. Of course, I could think about some sort of error codes like in here, like maybe I could add some more fields or the properties depending on my need, but yeah, I'll just stick to this particular implementation just for now. So now I can back to my domain and create my first custom exception type, which in our case will be empty packing list name exception. All right. So I've got my class and I can derive from my packet exception. And of course, this is the point in which I don't see my base type because the domain itself, as you can remember, doesn't have any references. So, okay, I was telling about the fact that this is the beauty of this clean architecture, that yeah, the domain is pure and yeah, we don't have any external dependencies. Yet still, to make it work, I need to add the reference to my shared abstractions. And that's actually the reason why I distinguish both shared and shared abstractions. To me, the abstraction itself, if this is actually an abstraction and the abstraction itself does not contain any, once again, IO, the assemblies that could bring me some sort of IO operation, then it's fine. I mean, it's just the extraction of some types to some external package. And to me, that's still clean enough. Of course, if you don't like it and you want to really have no dependencies within the domain, then yeah, naturally you need to bring it to your domain. But for me, it's just some sort of natural continuation. So now my packet exception is visible, so I can implement this. Yeah, and I will implement this in maybe a slightly different way. I'll just write that in here. Packing list name is empty. Yep. And that could be maybe cannot be empty. That'll be more precise. Okay. All right. So we have our first exception, which I can throw in here. So for now, I would say that's pretty much it. The only, I would say, improvement that we could do here is adding the implicit conversion from string to packing list name, because maybe, yeah, we'll probably not use the value objects on the transportation layer that will come to our web API. We'll rather stick to primitives, but yet we would like to have this ability to turn this into value object. So I could improve it a little bit by doing public static implicit operator string. So this will be the conversion from value object to string, and that will be the packing list name, which is name. Okay, and that will be just name.value. So this is the conversion from value object to string. And the second one would be conversion from string to our value object, and that will be just new, and we can implicitly type it as this. And now, yeah, I would say that at this point it's pretty much legit. This is something that I will be really proud of, and I can already change the implementation slightly in here. So now my entity will contain packing list value object rather than this primitive. So this looks already way better. And the same, of course, will go for the localization. So yeah, we can just create it right on. Let me just add new one. I will just call it localization. So the localization, actually, we could think about this value object. This will be, of course, once again, the record. Maybe I would like to be more precise. So not only I will just have a city, because yeah, there may be the same city name within the country or something else. So I would like to distinguish city and the country. Of course, probably there should be additional postal code and something else, because there might be a situation in which we have like multiple cities with the same name within one country. I think it's still possible, but I don't want to waste my time on creating the logic for the country and for the localization in general. Yeah, so for now, I think that this will basically do its job. Of course, we could do also the conversion from, let's say, string to value object, and we could do the assumption that, yeah, once we'll store this to string, we'll have the city and, let's say, comma separator or something else, and then country, just to store it in one string. Maybe in database we would like to store it as one string. We'll see. So yeah, let's just maybe add it. I'll create public, maybe static factory method. Very simple one that will accept those two. So let's say that I will have the value that comes, and I will have very simple assumption that, yeah, this will be split. So split localization equals value dot split. Let's say, yeah, that will split it and return new localization. This will be first, so this will be our city, and split localization last. Yeah, so this will be our conversion, let's say, from string to value object, and from value object to string, we just need to override the toString method, and this toString will be just, let's say, interpolated string, and that will be city and then country. So once again, some sort of conversion from string to value object and from value object to string. Okay. We can now get back to our entity, change the implementation once again, and it looks way better. Okay. Now, when we move further with all of that, we'll probably need some sort of items that we'll insert into our packing list. That's something that, yeah, at some point would be cool to add. And of course, this is once again assumption, whether we would like to treat our packing item as some sort of entity or value object. At first glance, I think that, yeah, having this as some sort of entity could be cool. Yeah, I could make this immutable and I will have the internal ID of this object. However, we could do this assumption that maybe I don't like to have the duplicates within my list, because if let's say list that was generated by my application gave me the proposal of, let's say, socks, and I will add this once again by mistake, I will take too much socks and I could have an issue with the luggage weight on the airport or something. So I would like to avoid the situation in which I have the duplicates. So I could create, I would have this assumption that, yeah, the packing item will be basically the value object with no identity. And yeah, once I will like to edit this, I will just, need to throw it away, create new one. And I think that this will work just fine. And this is just, I would say, matter of the implementation detail, whether I would like to, as a, let's say, domain expert, whether we would like to keep this as an entity or as a value object. For me, this will work as a value object, I think, just fine. So I'll just call it packing item. All right. So the packing item basically will contain 3 pieces of information. I'll just change this to record. Of course, I will need to keep the name. So let's say trousers or t-shirt or something else. Probably the quantity will be also appreciated. So I will know that, let's say I need to take 4 t-shirts for my journey. Oh geez, that was quite bad. Okay, quantity. And yeah, as you can see, I'll use the unsigned integer. Probably this should be unsigned short, because maybe I will not take like 1 million pairs of socks, but who knows. And I will also create a very simple flag called isPacked. So as the name says, yeah, this will be either the mark for me whether I already packed this or not. So let's create the constructor. Okay, so the constructor gets me those 3 values. And of course, maybe I would like to create some sort of validation once again. So for me, the only thing that needs to be validated, actually this actually is just, this could be just name. Of course, the quantity probably should not be, should not be 0. But yeah, let's just stick to name. I don't want to, cover every single case. Let's just once again assume that the name for the packing item cannot be empty, because it would make no sense. This would not appear on my UI properly. So I need to make sure that this actually is, it's not null. So let's just start once again with the exception. I will call this time empty packing list item name exception. I've got a typo once again. Okay, and I will derive from packet exception. Once again, I think I don't need any sort of message in here. I'll just write the information that packing item cannot, actually name cannot be empty. All right. Let's just jump back to our value object, which is this one. And let's create our logic. So is null or white space name, throw new empty packing list exception. Okay. And this does not require any addition parameters. So that will be probably it when it comes to our packing item value object. So now, once we'll get back to entity, we can create a list of those items, because I would say that's the whole purpose of this object, to have the list of those objects. So let's do a private read only, and I will just call this linked list for now. So this will be linked list because maybe I would like to, put something in the middle and just, keep the same order. So if I'm deleting something from my value object, I cannot modify it, so I need to remove it completely and replace with the completely new value object. So I would like to avoid a situation in which someone deletes, let's say, third value object, and once you add a new one, which is, let's say, correct value, it appears on the very bottom of the list because you are using just regular list. So linked list would be better in this particular approach. And this is some sort of design consequence of this decision that, the packing item will be rather an immutable value object rather than the entity. So I will have the packing item collection here called items, and I'll just initialize it in here. And I can also add this already to our constructor. So packing item now is the part of our constructor items. And I think that now, once we have the identifier, we have the name, we have the localization and the items, we're pretty much good to go. Of course, at some point, maybe there will be a need for, let's say, creating the packing list without our items or something else. But so eventually we'll maybe add something more when it comes to constructors to our entity. But for now, let's just leave it as this. Okay, so we have our internal constructor. So for now, we have no option for creating this from the from the application layer. That's fine. And it will be also good to add some sort of public methods which will allow us to add and remove those items from our collection, because that's the purpose of this list. So I will just create a couple methods which will just do this. So first one will be public void add item, and as you probably expect, this will accept the packing item as my parameter. So I'll just do public package item, and in this particular method I would like to do certain logic. So first I would like to check whether this item already exists. So let's say the item with this particular name already exists. If it is, I would like to throw an exception, because for me, as I mentioned, I want to avoid the duplicates within my list. I want to make sure that only one position is allowed and no duplicates are allowed, because maybe of some sort of, I do really care about the customer's luggage weight on the airport. So the logic will be very simple. I will just create a variable called already exists, and I will check inside my items whether there's any item which is name. So i.iname equals my item.name. Item.name. All right. So if this is true, then I'm in trouble, and I want to throw an exception. So throw new, and I need my custom exception. So I'll call this packing item already exists exception. Right? I have my exception. Let's just derive from our packing packet exception. And in here, I will accept maybe two parameters. So first will be what is the name of the list that I try to modify, and maybe what duplicate I wanted to put. So I will have like item name and list name in here. And the message will be maybe in a new line. Let's just create an interpolated string in this case. So packing list. And then in here, I will just do list name. Already defined item, and it's called item name. And of course, if you would like, we could think about some sort of assigning this to maybe some sort of property. So yeah, I could do something like this. Maybe I will use this information somewhere else in my system. For now, we can just leave it as this. So let me just jump back to my method. And let's just throw this exception. So in here, once I have it, I need to pass the name of my list, and of course the item.name. And yeah, if actually it doesn't exist within my list, I can do just items.addLast, and that's item, which comes as a parameter. Now at this point, I would like to discuss something, because this might be kind of weird too. Some of you may think, okay, but Derek, you're doing kind of weird thing, because every single time you're throwing an exception. So every single time something happens, you basically throw an exception. And why is that? Why you have the methods that are void and they don't return any result, and instead you just throw an exception? So let's just discuss what are the possible ways of validating the internal state of my object. For now, this will be an entity, which eventually will turn that into an aggregate, but yeah, I just don't want to bother you with too much definitions at the very at this, I would say, stage of this video course. So let's just assume that, yeah, for now it's just an entity, and I would like to be valid with follow the object-oriented programming and validate my internal state. So there are three possible strategies that you could apply to our object. So first one would be, of course, returning some sort of Boolean, or if you would like to, we already know the value object. So we could think about some sort of result of t, or maybe just result that could be returned from my method. And the assumption is very simple. If this happens, I will just return new object, which will have the information, that, yeah, this particular addition to my list couldn't happen because we already have this item with the same name inside. So yeah, based on this, we can construct some sort of response to our client and return, let's say, 400 bad request with the information that, sorry, but we couldn't process your request. The second option could be slightly different. So there will be no result, because maybe that's weird to us, and we'll create a dedicated validators that, yeah, we'll just remove completely every logic in here, and yeah, we'll just add it. And yeah, the validator will check whether we have the duplicates, and if this actually is a case, Then this validator will produce the response to the caller, let's say to our some sort of UI application with the information that sorry, but it's duplicate. We cannot basically process your request. And of course, in this case, that could be more tricky because we have this nice encapsulation. So we could think about either, I would say, relaxed approach in which we would have the proper, public properties with private setters, or we could think about some sort of, some sort of reflection that would go through my object and check it. But I wouldn't recommend doing this. But nevertheless, either you'll choose approach with returning the result of with this deferred validation. Both of them have, I would say, this things that bothers me is this assumption that you need to be certainly sure that someone on the higher level, let's say on the application level, will actually perform this and actually will check either result or will perform this validation using the validator object. You need to be certainly sure that this will happen every single time I'm adding, let's say, item to my list. Because what happens if it doesn't? You'll basically you'll break your business rule, you'll break your invariant. And the business rule was clear. You cannot have the duplicates within your list. And since you forget about validating the result that comes either from method or from the validator object, you broke this rule, and it just, you have the inconsistent state within your database. Something that should not happen actually happened. So I know that from the performance-wise, the exceptions are not great. I mean, they're now, I think, better than it used to be. But what I really like about the exceptions in terms of domain-driven design and self-validating of the objects is that once I throw this exception, I'm certainly sure by the nature of this particular object that the execution is immediately suspended and I will not reach this line. Of course, someone could say, but I could create let's say on the application layer, I could create a try catch and eventually maybe in some sort of way I could prevent from the application to break and still persist it. But then you're an idiot. I mean, you're doing this on purpose. And of course, I could break any single rule by doing reflection and accessing the fields that should not be accessed, let's say from another assembly. But if you're doing this on purpose, then I mean, I don't see any point of doing this. With the previous approaches, so with either returning the result or performing this deferred validation, this could occur by mistake, by the fact that I didn't realize that this needs to be performed every single time. And of course, those two previous approaches also, I would say, partially break the SRP, right? So it's like every single time I'm calling this add item, I need to, in one transaction, I need to perform the validation stage at some point. And it leaks because I didn't stop it here. It leaks further to my application or even further to my, let's say, presentation layer, which would be the API in our case. So I think that at this point, since I'm already discussing the self-validation and protecting the business rules, I think that I could already discuss also the concept of aggregate, because eventually this entity, so our packing list, will turn into an aggregate. And you can think about the aggregate in some sort of continuation of this object-oriented programming, actually. Because, what I told you so far is that, if you have some sort of business rule that needs to be validated, you are going to put this into the object, and the object will be responsible for self-validating, for checking and making sure that every single input that comes to it is correct, and eventually you can change the internal state of your object. And this applies both to entities and each of our value objects. Of course, at some point, there might be a different business rule that says, okay, you've got, let's say, two value object or even, value object and entity, and there is a rule that if object A changes, then you also need to change object B. I don't want it to specify. Let's say that once I will change the localization, I also need to change the name of my packing list name. It's completely ridiculous, but let's say that there is a certain rule. Now, the issue with this is that now this rule is outside of scope of my particular either entity or value object. And of course, once again, someone could say, okay, I will just create a application service that will make sure that once, let's say, one object changes, then the other also needs to be changed. But yeah, once again, because you didn't have any proper encapsulation on the domain, you need to do this on the application level. And of course, every single time one object changes in our application, you need to check whether the second also changed. If not, then you need to probably inform the user that this is not allowed. And of course, we could go even further. And once, let's say, new colleagues come and they are creating their own application services, they might use the same rules, right? They need to follow the same rules. So you need to make sure every single time that once they will use one object and they will change it, they also need to change the other one. So you're duplicating the logic that should be nicely encapsulated within your domain. And once again, the same principle when it comes to object-oriented programming is violated. So now you're suffering. So the aggregate is the representation of this, I would say, transaction within your I would say bounded context, but for now let's just say that within your application. So if there is some sort of invariance that needs to be atomic within the one transaction, like if A changes, then B also needs to be changed, you can basically wrap these entities and value objects into aggregate object, and this aggregate basically will be object representation of your transaction boundary, and it will be responsible for checking those invariants, and eventually if you're violating them, the aggregate basically can throw an exception informing you that sorry, but you forgot to also change the object B because you changed object A. In our case, we don't have such rules that would say that we don't have such rules like if this changes, this also needs to be changed. But in terms of domain-driven design and what we're going to introduce, which will be the repositories, we will have this assumption that packing list will be at the same time the entity and also aggregate. So this will nicely encapsulate the, let's say, rules within its internals. So we'll basically some sort of transaction guard. But we'll not necessarily use its capabilities that much. But once again, I don't want to go into domain-driven design that deeply. I will probably cover this in the completely separated series. So I think that since we already know that that we'll have some sort of aggregate, and this is just the explicit object that represents our transaction, we could think about creating maybe the representation for it, so you will already be familiar with the concept. So let's just jump to our shared, and within the abstractions, I will add a directory called domain, and I'll just create a class called aggregate root. So this will be just a representation. For the simplicity sake, let's just assume that this will represent our aggregate. So I'll have the abstract class aggregate root with the T. When the T is just basically the type of identifier. So we'll have this assumption that the aggregate itself will have few properties, and this property will be identifier, which will be just get, let's say, protected set. Okay. And for now, we can just assume that the only thing left is version. Okay. And the version will be used might be used, but not necessarily for something, let's say checking on the database level or some other level, let's say using this for optimistic concurrency or something. But for now, let's just, with no further explanation, let's just leave it with those two properties, and the only thing left will be maybe method for incrementing this version. So the assumption is very simple. Once you will modify anything within the aggregate, you need to increment this version. So this will be some sort of clear sign to me that, yeah, there was some sort of change within my aggregate, and maybe, yeah, this transaction needs to be performed to make sure that, yeah, we have new data in our database. So I will do something very simple. I'll create one more private bool version incremented field. And the reason for field is that if I will do multiple changes, I would like to bump this version only once. And so I don't want to jump, let's say, from version 1 to version 8. I would like to just increment this once and, yeah, have this very simple mechanism. Yeah, that's pretty much it. So now I can already do another, I would say, refactoring. So there will be quite a lot of refactoring, but I want to naturally introduce some sort of concept and see how this code will evolve. So I will now implement our aggregate root, and our identifier would be the parameter. Now at this point, someone could ask, okay, but you introduced these value objects for packing list name, for the localization, and yet still one of the most important stuff, which is the identity of my packing list, is still kept in the primitive. And that's actually a good point. So as a continuation, we'll move further with basically the packing list identifier. So let's just jump into value objects and create packing list ID. And you already know the concept, so I will just write it. So we'll have the GUID, which will have the value. This will be mutable. You already know it. We'll perform some sort of logic. So I want to make sure that maybe this GUID is not empty, because if it is, then I'm screwed. So let's just throw what I want to throw. Of course, you already know it. This will be my custom exception type, which will be empty packing list ID exception. All right, we have it. I'll just derive from packing packet exception, which is this one. I don't require any specific parameter. I will just pass the information that packing list ID cannot be empty. Okay, I can get back to my value object, and yeah, I think that I should be good to go. Of course, once again, if you'd like, we could maybe steal this implicit conversion. So now we'll go to GUID and do this. I think here we'll have ID, this, and this. Okay, and it says that we have packing list identifier, and that will be the GUID rather. Okay, so now we're good to go. So we can proceed with our refactoring, and now we can pass it in here. We are good to go. So now I think that once you actually know the concept of aggregate and the fact that this aggregate will now be responsible not only for, for keeping the identity, because it's also an entity itself, but it's also responsible for keeping the consistency within my transaction. So not only every single data that comes into it needs to be valid. So not only that every single fields needs to be valid, but also the business rules between those objects within my aggregate needs to be fulfilled in order to proceed further, let's say, on the application level. And this is also explanation of why you need to throw in exceptions, because the exception is the only mechanism, at least to my knowledge, which will prevent me immediately from further execution. And at some point, of course, if you think about value objects, if you can return the value from the constructor, let's say, you're a genius. Of course, you could do the overcome, like creating some sort of static factory method for this, but that will generate more boilerplate from our implementation. And if the factory returns, let's say, packing list ID, then you would need some sort of out parameters that would give you a hint that maybe this is not this didn't succeed it. So I'm not a fan of it. I'm just throwing exceptions, and I don't care if this will be, best from the performance wise or not. Now, another question that might pop into your head right now is the following. Okay, Derek, you've got the entity, which is, of course, in this case already also the aggregate. So this will be my guard of the consistency within the transaction. Cool. You've got this this public API, which allows me to interact with my aggregate. And you have these nice exceptions which are thrown. So how the heck let's say I want to create the unit test for it. So how the heck I know that this actually succeeded? Because of course, I could do this very simple assumption. If I've got the exception, then I will have this assumption that this actually succeeded. But what happens if I've got something like this? I forgot to put this. And that's not, I would say, not easy, because once we would have this as a public properties, the word will be, I would say, the whole issue would be way easier, because the only thing I need to do is check whether packing list dot, let's say, name is equals to the one that I passed into my method. While in this approach, I have no access to my private fields, so I need to some sort of explicit information that this actually succeeded. And to deal with that, with this particular model, and I mentioned that there will be few trade-offs with this approach, and the first of them is that we need to introduce another concept within our domain. So this concept will be called the domain event. And the general idea, especially if you're aware of what the event actually is, the domain event basically represents something important from the domain's perspective that already happened within our system. So this information informs us that something already happened. We cannot undo this. If something happened, we cannot undo this. And basically, the idea is very simple. Once we'll interact with our aggregate using our public API, which will be these public methods, as a result, we'll not only mutate this internal state of our aggregate, but we'll also produce this domain event and add this to internal list of domain events of our aggregate. And thanks to this, I could verify whether something already happened. So this will be my input, and my expected output of processing this particular method would be producing some sort of domain event. And that's the whole idea, kind of simplified when it comes to my domain events. So let's do the following. First, I will add in my shared abstractions one interface called iDomainEvent. So this will be nothing more but the marker interface just for the generic constraint purposes. And now I can first start with, I would say, modifying my aggregate root by adding the collection So my aggregate root will be responsible for keeping the collection of those events. So let's do the following. I will add private read-only. Okay, private read-only list with iDomain events. Okay. I will just do new. And yeah, because now I would like to also have some sort of public information about what domain events I actually produced within my aggregate. I will also expose a public IEnumerable property. Of course, this will be IEnumerable of iDomain event called events. Okay. And we'll do events. Yep. And last but not least, we'll need a method within my, which will be protected because I want to use it only within my aggregate. So this will be a method called alt event. And we'll accept, of course, iDomain event called event. And we'll perform very simple logic. So if we don't have any domain event and we haven't incremented our version yet, we'll just bump the version because this will be, let's say, this first change within our aggregate, and I will change this to version incremented. So by adding our domain event, I will also like to implicitly increment my version by 1, but only for the first time. And eventually I will do events.add and then event. Oh, sorry, I need to change this underscore to add. Okay. And I will also add one more. I missed this one. And I will also add, maybe for some reason, method for clearing events. So the whole idea is that those domain events will only live within the, I would say, one HTTP request lifetime. So yeah, once I will actually persist this aggregate to my, let's say, database, once I will restore my aggregate, the domain events are gone. I don't need them. Of course, I could persist them if I would like to, and that would be some sort of partially some sort of basement for maybe foundation for the event sourcing, which I will not discuss in this course. But for now, we'll just assume that we might need those domain events for maybe unit testing, for validating, for performing maybe some other domain business logic within our domain layer. But yeah, once we'll actually persist this aggregate, we forget about those events. We don't care anymore. So the good news is the aggregate root will will not grow anymore, hopefully. Yeah, that will be probably the final version of it. And now we can get back to our packing list, and somewhere in here, once we actually add the item to our items list, we could call our add event method. So let's just add another catalog within the domain, will be called events, and this event will, I'll just call it something like packing item added. So this class will basically, this could be actually anything that we would like. I'll just make it record because those events will be immutable. So as a shortcut, I think that it's quite handy to do the following. So I will pass the packing list. So packing list and maybe packing item as well. And of course I need to implement the iDomain event marker interface. So I can now safely use it within my add event method. Okay, I'll pass this and the item. And yeah, we've finished first method when it comes to our aggregate. So let's just quickly So let's just quickly extend this implementation. So maybe there will be a need also for adding multiple items. So there will be like add items, in which I will accept not one, but like IEnumerable of packing items. So it will be items, and the implementation is rather straightforward. That will be for each on items, and I will call item, and inside add item. So in this case, you can see that this will produce multiple packing item domain events, but the version will be bumped only once. So that was the whole purpose of this guard, and checking whether this actually was previously incremented or not. Okay. Then of course, at some point, it would be cool to mark the particular item as packed, because that's the whole point of this, let's say, packing list. I want to make sure that, yeah, I will just check it as something that I already have in my bag or my luggage. So I will call it public void pack item, and as a parameter, I will just pass the name of this item. Of course, some sort of okay. And of course, for the item name, I don't have any value object, but in this case, it's not, I would say it's not violating, it's not like it's primitive obsession, because yeah, the item name itself was the part of my value object. So the value object was responsible for checking whether this actually is null or not. This will be only for the search purposes, so it does not violate it will not lead to any inconsistent state. Even if that will be null, yeah, this will not violate the internal state of my aggregate. So this is why I can pass this safely without any fear. So first thing, of course, I need to get this item somehow. So let me just create maybe one private, this time private method. I will call this get item. Who would expect? Okay, and based on this, okay, I will return the packing item. So the item is basically items. Then I can use safely singular default, because I've got this assumption that there will be no duplicates. Of course, I need string item name. So the predicate is rather simple. I.iname equals item name. Now I can check. So if this item is null, then there's something weird that is going on. So maybe I'll throw an exception and inform you about that weird thing. So you're trying to pack item that you don't have. Of course, from the UI's perspective, this will rather be never called, but maybe someone is, messing up for API and trying to put the data that makes no sense. So yeah, this might be actually a good to have this some sort of security null check. So let's create another exception. I'll call this packing item not found exception. Okay, and once again, package exception, and I'll just accept the item name, and I can actually assign this maybe to property and interpolated string, which says packing item and item name was not found. Boom. Okay, let's just refactor this. Okay, to one-liner. All right, we are getting closer, I promise. So I can use it. Item name, and yeah, if this is actually not a case, we'll just return the item. Okay, so now I can use this method in here. So first thing will be calling our get item. So get item and item name. Okay, and now a very cool feature that comes with the records is the fact that I can create a copy of the record with changed property using with operator. So if you would see, I could do something like packed item would be my item, but with changed property, and this property is packed, and I will set it to true. So this is kind of cool, and I'm not quite sure. Property without setter, it is actually set to, needs to be set to init. So that was my bad. If you don't know this, the init basically means that this can be initialized either only from the constructor or from the object initializer. So it's like immutable, but gives you this flexibility to choose either you want to set it from the constructor or the object initializer. It's still like immutable. So now, because I've got the init, I can use my with. And yeah, that's a very cool thing, because other primitives within this value object will get basically copied, and I don't need to explicitly, do this explicitly, this assignment. So now I'll do items.find. I want to find my item, and I want to set the value to packed item. So I will not change the order of my packing items. And last but not least, very crucial for our design, we want to add the domain event. So I'll just add another class called packing item packed. I know, kind of stupid name, but yeah, this is how it is. And I think that we can also copy the payload of this message. Okay. All right, and let's just use it. Okay, here, new packing list item, and I'll pass this and item. And the very last one, which will be remove item, and this remove item will once again accept string item name, and the idea is simple. Once again, we'll call our get item internally, and items.remove item, and once again at event maybe packing item removed. So packing item removed. Okay, and this will be once again the record, and I think that once again we can use this payload just to speed it up a little bit. Okay. Oh geez, once again. Fail. Okay, this item. Believe it or not, we are almost done when it comes to our implementation of our aggregate. So we have nice private fields which are wrapped into value objects. We have only the public API of our aggregate, which allows us to modify its internal state, but this state is validated by the aggregate itself, and if some rule is violated, we basically throw an exception and we shut down the whole execution immediately without relying on any third-party component or the upper layer, which is in this case application. So we prevent this eventual validation leakage further, which I believe it's a good thing, of course. At some point you might also ask, okay, but whether something is empty or not couldn't be validated at the very first round, let's say on the API level, using, let's say, data annotation. Yeah, of course, if you have the input like this, you could distinguish what is the data validation, what's the domain validation. But once again, since this is rather simple app, I need to make some sort of trade-off. So in this particular example, I only have this checks on the strings, which need to be required, and this is why I have this. Okay, I think that this could be pretty much it. One more thing that maybe we could improve is the following, because now the only piece that we miss within our domain is, of course, the way to create this, because this is the whole purpose of this internal constructor. We don't want to have the factory that will actually construct this packing list. Yeah, but maybe we would like to avoid this as a parameter that will be called by our factory, because if we'll pass these items in here, we would probably do something like items.items, and there might be a situation in which we'll have this duplicate because we'll not directly call this method, right? This logic will not be called, so I will just assume that the input that comes to my constructor is valid, and I will just blindly assume that, yeah, okay, this is fine. In this case, which actually should be also refactored to this, in this case, it's just fine to assign this, because those objects itself will internally within their constructors validates whether the values are correct or not, while this is some sort of business rule that is responsible. It's the aggregate's responsibility. So I promise the last change to this code. I will create another constructor, which will be also internal, and this constructor will accept only 3 parameters. So this parameter will be the identifier, the name, and localization, and within this I can safely assign this one. Okay, and this we'll see, but probably should not be used. For now, I think safely remove it, because yeah, there are 2 ways to approach it. First is that this could basically call my base, and this base do the following thing. I will just pass the ID, name, and the localization. I can now remove it. Sorry, not base, but this. Okay, so I'm calling this particular constructor, and those 3 fields are getting assigned, while the items, I would rather to do something like add items and pass the items. However, keep in mind that eventually, probably this constructor, it could be called by our ORM. So once we are actually getting the data from the database, it could, but not necessarily. Yeah, we could get this object from our database, which means that every single time we'd get the object from the database, would perform this validation. And it's not something that I probably would like to have, because yeah, I assume that everything which is within my database is consistent, and if it's not, then it's already too late. So it makes no sense to validate something once I'll get the data from the database. So for now, I will just remove this completely. I will stick to those 3. So my assumption is very simple. Factory, which will be responsible for creating this packing list, will just put those 3 both properties and property and fields into my aggregate, but further adding items need to be done through this method, through this add item method. Okay, and if we'll need the items, if we want to do this items and do this in safe way, then it needs to be private, because yeah, other way we cannot be sure that these items that come externally are actually valid. So yeah, I think that maybe I will just leave it for the Just for now, we'll see whether we'll actually use it or not. Probably I will delete it at the very end of this course because I don't think we're gonna need this overload. It will be rather this one that we're going to use. And the ORM itself will use the parameterless constructor, which we'll discuss later. Okay, so let's just jump into the factory. And let's just discuss how we are going to tackle this, because according, you probably know the factory pattern, and in the domain-driven design, basically, the whole purpose of factory is just the same. So we would like to delegate, we'd like to have the place in the code which will be responsible for validating, not for validating, but for creating our aggregate. So in our case, that will be the packing list that needs to be created and constructed somehow. So we don't want to have any knowledge of how this actually gets created. We want to delegate this to the factory method that will do its job. So within our domain, I will create the directory called factories. And within these factories, let's just add first interface. So I'll call this packing list factory. Okay. And I can already create the maybe implementation. So create derived type, there will be the class. I will just move it to CS file. Okay, I've got it. So the factory method will just give me one particular method. It could be actually, we could think about this factory like in two ways. So I could either allow myself to create an empty packing list and eventually call add items, or I could create the packing list already with predefined items and generated by my domain. So we could distinguish those two scenarios. So first will give me packing list based on, I'll maybe call this create. So based on 3 parameters. So packing ID, so it will be packing list identifier, which is the ID, packing list name, which is the name, and and the localization. Okay, so that will just give me packing list with no items within it. While the second one will be more fun, because this will return me also packing list, and maybe I'll call this create with default items, something like this. So I will accept packing list identifier also. So packing list ID. I will also accept the name. Okay. And now I want to also include those additional this additional data that comes from the user input. So as I mentioned, you can either create the packing list, which is just empty, and manually add every single item, or you can give me some more data, like where are you going, for how long, and let's say what is your gender, and I will do this for you automatically. So we need to provide, let's say in here, days, gender, and this localization that we have in here. And of course, I could do something like int days, and and assume that this is fine. However, once again, since we already know the concept of value object and we don't want to get into the primitive obsession, it's probably good to have the dedicated value object for, let's say, for the days. So let's start with our travel days. I'll create the value object called travel days. I don't want to validate this within the factory because it's not the right place. The factory should focus on constructing the packing list rather than validating whether the days are correct or not. So I will do travel days, and this will be the record once again. And yeah, maybe let's just copy this from something, because in many cases that will be just the same implementation. Of course, we could think about some sort of base type, which could be handy. So I'll just keep it as a uShort, travel days, and this will be the value. And yeah, let's say that if the general business value, business rule will be that we don't support travel that is longer than 100 days, because for some reason we don't. We don't know how to construct the packing list for such a long trip. So we'll do validation like if value is 0 or greater than 100, then we'll throw an exception. So once again, we can create an exception called, let's say, invalid travel days exception. Okay. And packet exception is the one that we want to derive from. And here I will just pass uShort days. Let's create the property and the message that says value and then days. Okay, is invalid travel days. Okay, something like this. I'll just make this one-liner. Okay, and now we can throw it within our constructor like this. Value, cool. Refactoring this days. This will be also days. This will be rather this, and uShort is the one. Okay, we've got it. So that will be the first thing. So we need the travel days. So days. Then I mentioned also a gender. So let's also create a gender. For gender, I think that we can stick to enum. It makes no sense to actually wrap it into value object, but I would say it's pretty much all up to you. So I could come up with some sort of const directory, and I will do gender as an enum. Okay, and yeah, we'll have the male, we'll have the female, and okay, let's just keep going. We've got the gender. Okay, and we also need the localization. And yeah, now I'd like to also discuss one more thing, because at this point we have the localization, and I mentioned that the localization will be used to reach some sort of weather API, get the average temperature, and based on this we'll make the decision. So I would say that at first glance it looks like, yeah, we only need the localization inside our domain, but later what that means is that somewhere within my factory method, I'll just implement this, I would need to do something like var temperature equals and then some sort of service that would, based on this localization, give me the temperature. And I mentioned that the domain itself is not responsible for, some sort of IO operations, and we want to avoid this. So how do I get the temperature and prevent my domain to be relying on some sort of IO operation? Especially that, probably this call should be asynchronous. So now it turns out that the packing list factory also will be cool to have this method also asynchronous. I don't want to do crappy service.result because that sucks, and that's completely makes no sense because it's blocking. So yeah, that would mean that my factory actually constructs the packing list using a synchronous approach, and that's kind of violating what I've said about the beauty of this approach. So the answer for this question, how do we actually going to tackle this, is very simple. It's the application responsibility to first fetch this and orchestrate, and once we'll have the temperature will be basically another parameter for our packing list factory, and that's pretty much all. We don't need to delegate this extraction and this calling to weather API to our domain. It will be the application layer which is responsible for that, because this is more like process level. This is one of the steps within the process, getting the temperature, and this data, once it gets transformed into a more domain friendly object, can be used within our factory. Simple as that. So as you probably expect, this will be very last, and I promise this is very last value object, which will wrap nicely our temperature, which is called temperature. Who would guess it? This will be record, and once again, I think that I can move to, I'll be very good with this copy pasting. I will just change this to double because it's rather continuous. We'll never have like ideally like 20 degrees of Celsius. It's rather 0000 point something. And okay, so if this temperature is, let's say, lower than minus 100 or greater than 100, then this probably means that, yeah, something is not right. That you're either going to like to the moon or to this. I don't know whether we have the temperature greater than 100 on the Earth. Probably not. I think that 70 is like the limit. All right, so the exception should be created for this. Let's call it invalid temperature exception. And yeah, we can create a constructor. This constructor will accept, of course, our double value, and we'll call our base. Okay, and the message is value, and then interpolated string value is invalid temperature. Okay, and of course I need to derive from our packet exception, and maybe just to be consistent, let's just generate the property. And believe it or not, it's the last value object that we've got. Just now the matter of few improvements in here and changing this to temperature. And same goes in here. And we're done. So this, as I mentioned, will be rather the parameter to our factory along with the localization itself. So this will be used only for the for this assignment to within our aggregate. This will be used for actually deciding which particular items I would like to get. Okay. Now the question that remains is how the heck we are actually going to decide on those items. Because now I've got my factory is responsible for returning this packing list, and I need to somehow the place to decide what should I take. So we'll introduce very last concept, also known as from the domain-driven design, which is called the policy. So we could think about the policy as some sort of domain representation of a strategy pattern. So basically, I want to have the coupled way of deciding and putting particular conditions within my, let's say, if statements to the separated classes. So the idea is very simple, actually. We will create the dedicated classes, let's say the policy for packing list for, let's say, males, or for the females, or for the low temperature, or for the high temperature. And the factory will basically pass those data and will say, okay, give me all policies that we have defined within our domain. And now let's check which of them are actually applicable to our case. So we'll filter them and see, okay, only 3 of 7 defined policies are actually applicable because we need the packing items for male, for the low temperature, and let's say for more than 10 days. And we'll say, okay, so those 3 policies, please give me your predefined items. And inside each policy will have basically the list of some sort of items that should be taken to our journey. And that's the very simple, I would say, simplified approach to this issue, because if you would see, there's quite a lot of compositions in which you probably would like to exclude maybe some items, but for our case, this will work just fine. So let's start with defining the directory. You will see this. I think that you will get the idea almost immediately once we'll start the implementation. So I will create the policies directory in here, and I will create first an interface. So this interface will be this sort of contract for each of the policy with the packing items. So I'll just call it iPacking items policy. And this interface is going to have 2 methods. First, will give us an information whether this is applicable to our case or not. Now, I'll call this is applicable. And of course, the natural thing would be doing something like, okay, I will pass temperature, right? I will pass the localization, etc., etc. However, over the time, once the whole system will grow, we might, evolve and come up with some different policies depending on maybe new factors. So maybe now we add a hobbies, and we'll have that another policies for each of the hobbies. So if you're interested in sports, so let's say the tennis, you would like to take your racket or your shoes or your equipment, or maybe if you're more into, let's say, scuba diving, then you'll probably take something else. So if we would extend those policies, at some point we would end up with multiple parameters in our is applicable method, which once again is not very, I would say, pretty. And even for the reading purposes, that would be kind of pain. So in this particular case, it would be better to wrap this into some sort of policy data or whatever you call this. But basically the idea is that this will contain all the data based on which the policy will determine whether it's applicable or not to this particular context. So I will call this policy data. And this policy data, as I said, it could be just a record for now. And this will accept few things. So this will be first travel days, called days. Then we have the gender. We'll also need the temperature. I also need to call this gender, temperature, and the localization could be also used. All right, so we've got our policy data, and now we'll use it in here. So within our is applicable method, we can use it as follows. So basically data, and of course the most important, the second method, is the method that will return us the enumerable of packing item. So generate items. Okay, so policy data. Okay, we've got our contract for each of the policies. So now we can define the policy for each individual case. So let's start maybe with the gender. And I will just create one example policy, and later I'll just jump into already finished code, because it makes no sense to spend another half an hour on generating like some dummy items. So let's start maybe with male gender policy. Okay, so male gender policy will of course implement our packing items policy. I will make it internal just to prevent this from further usage. So internal class, which of course needs to implement my two methods. So first, let's start with this is applicable. It should be rather simple. This will be applicable only if data.gender is gender.male. Okay. And as a result, for now I will just hard code this. Of course, we could think about more elastic approach in which I would maybe grab this from somewhere else. But yeah, for now I'll just leave it as it is, some sort of hard coded name. This is the MVP of our application. We don't want to waste much time. So if you're male, you probably need a laptop for gaming, and the quantity is 1 because you kind of need it. And we also need what is packed. I think that we can slightly refactor this. I think that we can assume that by default I will just assume that it's not packed. I will just want to generate it, so that will be rather better, I think. And then you'll probably would like to get some beer because you're a man, and probably this will be, yeah, we can also hard code this. We don't need it. Only 10 beers, even if you're traveling for just one day. And last but not least, maybe book, because you want to be educated. You don't want to be a dumb idiot. So you have the book, and let's say that we'll be more robust in here. We'll do that. Actually, I would like to make it, I'll use math ceiling, and let's just assume that, yeah, you would like to take, let's say, we'll take the days and we'll just divide this by the 7 days. And yeah, this is, it's good to have at least one book a week. Okay, and that's how one example policy might look like. So it will be applicable only if the data.gender will be male, and yeah, this will return you those 3 items. So let me just now jump into the implementation. I will just finish it up and you'll see the rest of the policies in just a few seconds. All right, I'm back, and yeah, I've just finished the implementation. The one thing that is worth mentioning is that now I added subdirectories to our policies, so the gender and the temperature, which are also the name of our value objects, and the enum, which caused the compiler to complain about it. So we just need to be now more explicit when it comes to our policy data definition. So now it's like const.gender and value objects.temperature. So just so you know. And I can actually move it in here. So now let's just briefly go through the gender policy. We have for the female also some lipstick, powder, eyeliner. For the temperature, we have 2. So we have one for the high temperature, which is, as you can see, over 25 degrees of Celsius. So we have the hat, sunglasses, cream with UV filter. We have low temperature, which is under 10 degrees Celsius. So we have the winter hat, scarf, gloves, hoodie, worn jacket. And the third catalog is universal. So as you can see, it's always applicable for our packing list. So this is why I also use the discard in here. We don't care about the input. We always say that this is applicable. And here we have some sort of basic stuff like pants, socks, t-shirt, trousers, shampoo, blah, blah, etc. And this is calculated. So let's say that for the pants, I want to have let's say minimum between days and maximum quantity of clothes, which is 7. So my assumption is very simple. If you're traveling for more than 7 days, that you'll probably use your washer to basically clean your pants off, and you don't need more than 7 pants probably for your trip. So, very dummy logic, but does the job. So now we have our 7 policies, and it's just now the matter of using them within our factory, right? And that will be pretty much the whole implementation and the end of our domain finally after 2 hours of recording. So let's just finish it and see how this might feel. So within our packing list factory, I will create private read-only I enumerable of packing item. I will just, sorry, not packing item, but rather I packing item policy, which will be called policies. Okay. And this actually will be provided to my factory. So to construct this factory, you need to provide me the list of my policies. And now the implementation will be rather simple. So let's start with the create, since it's no brainer. We don't even need this policy actually in here. So for the create, we'll just call our constructor for the packing list, passing identifier name and localization. And we'll just return this. And if you want to add something manually, you'll just need to call method called add item, which is rather in here. And for the create with default items, this will be slightly more, let's say, advanced. So var data, first we need to construct our data. So policy data, like this, policy data, accepting days, gender, temperature, and localization. So days, gender, temperature, and localization. Cool. Now let's filter the policies. So we'll do the following: var applicable policies equals policies.var, and we'll do p goes to p dot is applicable, passing our data. And now we'll do the following items equals, and then we'll just call our applicable policies dot select many, because we want to flatten the results. So select many p dot generate items, and we'll pass our data. So this, as you can see, will return me the I enumerable of packing item. And now we can do var packing list equals, and we can call this method, so create, passing our ID, name, and localization. And let's just call this add items method, passing our items. So factory will only take care of the whole process of the constructing, but the general idea about protecting the invariants is still within our aggregate. The aggregate knows what rules needs to be fulfilled to actually add those items to it. So we just don't want to leak. This is why we prevented this leakage, just not to put it in here. And we can return the packing list. All right. And that's pretty much it when it comes to our factory. So now we have like almost everything. We have the factory, which is responsible for creating our packing list. We have the policies, which we can just, I wanted to note one thing, that it's quite easy to extend. If you would like to add more factors on which we'll generate the list, we can just add new, let's say, subcatalog, add maybe those hobbies or something, and create the policy for each individual hobby, which would give you the additional items. Of course, once you got into this domain, you'll start analyzing this, you will notice quickly that it's not that easy, and probably there might be some sort of conditions that will exclude each other, but for the very simple application, this will work just fine. And the last thing that I mentioned during the introduction is the repository, but of course only the interface, which will be just some sort of contract. So what I'm capable of doing with my aggregate. So I will just add the directory called repositories. So repositories, and in here I will add interface called packing list repository. Okay, this will be an interface. So what operation will be allowed on my packing list repository? So I will define few. First, of course, I would like to get my packing list by the identifier. So I'll just call this get async, and I will pass the packing list identifier, which will be our ID, and maybe a few more. I will just remove it. So first will be adding, then we'll have the update, and we'll also have the delete. Now, there are two things that I want to mention in this specific implementation. So I'll just do maybe packing list will be better name. Okay, so something like this. Okay. Believe it or not, that's pretty much all we have within our repositories inside the domain. So two things I wanted to point. First is that, as I mentioned, this is the contract that specifies what we're capable of doing with our domain. In our example, it will be rather looks like a CRUD, right? So I can get, add, update, delete, but maybe sometimes this won't be a case. Maybe I could create some sort of aggregate, but I cannot delete it. So this is also some sort of answer why I'm not relying on some sort of generic repository. I mean, the generic repository in general sucks in most cases if you're not aware of some sort of pitfalls that you might fall into. It's better to you can still use it if you want, but rather within the composition and not directly. So of course in here, I just want to explicitly limit my number of operations that I can perform my aggregate. And yeah, inside of the specific implementation, somewhere on the probably infrastructure layer, I could do whatever I want. I could use the generic repository. I could, inject the raw DB connection, and that's just fine. But using one repository contract for every single aggregate might be dangerous because there might be a different life cycle of each of them. So that's the first thing. Second thing, which I want to cover, is this. So I was talking about this IO operations and that the domain is pure and we don't rely on any IO operations. I also mentioned this during the factory, that the application layer will be responsible for retrieving this temperature, yet still within our contract definition, I've got the async. So it's some sort of abstraction link, right? And I totally agree. I agree that this is an abstraction link, and the only reason that I'm putting this is because there's no better way of defining my contract. Because now, assuming that I would just remove it, so I will just make it packing list and those three void. Now my implementation in the C# itself, let's say on the infrastructure layer, also needs to be synchronous, right? Because in here I define the interface as synchronous. So this is some sort of C# specific topic, which, yeah, I just cannot overcome the limitation of my language. I believe that in Java this could be slightly different because they're using, I think, the attributes for the asynchronous jobs, so they could do this in more pure way. But in this, I don't want to make a trade-off, or in this case on the performance, and making every single call to database built on top of synchronous connection and making this as a blocking operation. I want to make it asynchronous because throwing an exception comparing to getting quite a lot of data from database in synchronous way is significantly different story. So I would rather want to be a pragmatic, and yeah, this will be the only some sort of sign of IO operations within my domain that I could allow this task and this async keyword, this async suffix in my method name. And that's only because C# does not allow me to do it in any nicer way. All right, let's just briefly summarize what we've done so far within the domain itself. So we started with the entity. So just to remind you, the entity is the object with its own identity. It doesn't necessarily mean that you need to create an ID which is artificial. Sometimes you may look for more natural identity, like the example with the email address of the particular customer. In our case, the entity is also an aggregate, which is some sort of simplification, but basically, just to remind you, the aggregate is the guard of the consistency and atomicity within the single transaction. So if something needs to be atomically changed within single transaction, in our case, this should be wrapped into the aggregate, and the aggregate is just this object representation of our transaction boundaries within specific bounded context. But in here, I don't want to go into the strategic domain-driven design topics. Later, we also added the value object. So once again, we wanted to avoid this primitive obsession code smell, and also we wanted to delegate the particular validation of the data primitives into its own object. So each of these value objects is responsible for self-validation and for a nice encapsulation of those primitive values, because data types given by the C# are just the data. They do not encapsulate the behavior. They're just the containers for particular data. And yeah, the behavior is something that we really care about within our domain layer. Besides that, just keep in mind that both value objects and entity/aggregate make the validation which might cause an exception, and the reason for that is that exception will immediately stop the further execution of method or the constructor. We just don't want to rely on some sort of high level services or high level objects, let's say in the application layer, that will eventually validate whether what we've got within the boundaries of our object, whether this is actually valid or not. If something basically breaks our invariance within the boundaries of our object, we want to immediately just stop the execution, throw an exception, and return the response to the caller with the information that, sorry, but we basically cannot process your request. And we also added the domain events. Domain events basically are some sort of consequence of decision that we've done with the encapsulation. So we don't have any public properties within our aggregate. We only have the identifier, which is publicly available when it comes to getter. The other properties like the name or localization are just the implementation detail. The aggregate is not responsible for giving you this data. We don't want to allow the situation in which someone, let's say on the application layer, builds some weird logic built on top of the public properties. We assume that everything besides the identifier is just the implementation detail. We want to hide it. So as a consequence of this, because we cannot make the assertion, let's say in the unit testing, we need to make sure that once I will call some sort of method on my aggregate, let's say add item, I want to make sure that this actually behaves as expected. So as a consequence and some sort of output of my aggregate, we added the domain events, which is just the representation that some significant change has been made within our domain. So this represents something that already happened within our domain layer. And we added also a few, let's say, tactical DDD building blocks. So we've got the factory, which is responsible for creating the packing list. This could be either the list with no items or the list with pre-generated items. And if you want this second overload, underneath we'll use the policy, which will be some sort of strategy pattern, more or less strategy pattern in which each particular case will be put within, once again, separated class. So we're not afraid of the amount of classes that we have so far. I would say it's good to have a lot of small classes rather than one huge class that will do everything. And if you call this manager or the service, it's like the ultimate crap that you can probably come with. And when it comes to factory, one thing that needs to be mentioned is that this temperature thing needs to be fetched before we actually reach our factory. So we don't want to rely on any external IO call to, let's say, weather API. We want to do this on top of process logic, pass it to factory, so the factory will know, or will have no dependency on our IO, and yeah, the domain remains clean. And last but not least, the repository, which is our contract and defines what we can actually do with our aggregate. Just keep in mind that, yeah, this is the only place in code which kinda contains the, I would say, abstraction leak, because we need to define the contract with the tasks and with this, async suffix when it comes to method name, because of the conventions within the language and because of the how the language is constructed underneath. That's some sort of trade-off, but we want to be pragmatic. So in this particular case, the performance on top of database will be crucial. We don't want to make the calls synchronous. We don't want to have this blocking operations. So yeah, we need to deal with that. So in our case, yeah, we just have this asynchronous methods within the domain, but this is just an interface. And implementation, of course, will remain as an asynchronous and that will be delegated to infrastructure itself. So I think that when it comes to domain, that's pretty much it. I would say that it's rather the object-oriented programming tutorial so far, but that's the whole point. I mean, I think that it's good to have this different view on the topic. Sometimes I think that we as software developers forget about basics, and yeah, we were taught about this, and yet still at some point we might forget about good practices when it comes to object-oriented programming, and it's good that we have some sort of architecture that can support those practices. So we've finished our domain, and we now need to move one layer up, which will be the orchestration, so the application layer. So we'll see how we may orchestrate our domain, how the whole use case may look like on the application level. But to make it more granular when it comes to use cases, we'll introduce the CQRS, I would say. So first we need to, of course, know the term. So what is the CQRS? What is the natural, I would say, evolution of this, which is the CQRS? And yeah, we'll discuss the topic. And once we'll know the theory, we'll jump back to the code and yeah, just incorporate this within our clean architecture. All right, so we finished the domain. It's a good sign. I think that we covered this in quite a details, so we can move up to the next point, which will be in our case the application layer. And we kinda discussed its responsibility, so we already know that this will be nothing more but the orchestration layer for our domain, and that will probably end up with some sort of process logic within it. And by process logic, we could think about some sort of, in many cases, some sort of use cases representation. So let's say that in order to create a packing list, I need to first get the data as an input. I need to reach the weather API and then maybe check whether this packing list already exists, etc. So we'll have certain steps which will be basically handled within my application layer. Now, typically what you would do is just creating an application service for that. So we'll end up with some sort of packing list service, which once again isn't the greatest name, but yeah, that would be probably the convention. And the only issue I've got with this particular approach is that once we'll have this application service, there will be probably operations related to getting this particular packing list, maybe by identifier, maybe searching and returning many packing lists, maybe the operation related to creation of this list, maybe also for, operation for marking particular item as packed, etc. So we'll end up with the service that would grow quite significantly, and every single use case will basically impact the overall shape of this class, because every single use case needs to be put within it. So we'll end up assuming that this system would grow in the future, we'll end up with quite big class. And of course you can say, yeah, but we could do the partial classes. Yeah, but this sucks. Let's be honest. I mean, it's not the greatest design. And I'm not even talking about the dependencies of the service, because there might be situations in which for particular use cases, I will need additional components, maybe like email service, maybe some sort of weather API for the creation. So not only my methods would, add the complexity, but also the dependencies will be quite significant. So what we're going to do instead is incorporate I wouldn't say it's pattern, it's rather a principle, but yeah, you can think it about some sort of pattern, which I believe a lot of developers are actually scared of, and this is probably because of some sort of misconception or misunderstanding of what actually the CQRS is, because we are going to discuss the CQRS, and hopefully you'll find it useful, and you will see how we can move from this traditional approach in which we have one huge application service to something more granular on top of our use cases. So before we actually jump into the CQRS, it's good to start with the root concept, which is called the CQS. The CQS is one of many mnemonics that we've got within our industry, and the CQS stands for command query separation. Now, that was the concept, the principle that was originally described by, I believe that was the Brendan Mayer, who was working on I think that was the Eiffel language in like 70s or something. I don't remember the exact date. Hopefully I did not screw the name of this engineer, but basically he came up with this principle with this command query separation, saying that, once you have the system and you have the methods within those systems, it's good to have this, I would say, separation between reading the data and writing the data. So instead of mixing this within one method, I know that you probably know the methods called, let's say, get or create something, right? Or get or delete. I've even seen something like this. The problem with such a method is that without knowing the internal state of my application, I'm not quite sure which path will be executed. So whether this will be the get or the create. If I don't know what's underneath, let's say on the database level, I'm not quite sure what state is going to be executed. So not only for the unit testing, it's not very comfortable, but also, yeah, I would say that this might be a sign of some sort of bad design, that maybe we're not certain about the execution, so we decided to put it together and glue this together for some reason. And yeah, the CQRS says, okay, in most cases you either want to read the data or modify it. So we'll now divide and distinguish two groups of methods. First would be the queries. So the queries basically are the methods that will return the data, and as a result, they by definition will not mutate the internal state of our application, which in general means that they will be pretty much idempotent. So if you're not familiar with the concept of idempotency, there is a formula for this that will help you understand if you know the math. Probably you do. But in a nutshell, the whole idea is that no matter how many times we'll execute some sort of function, the result remains the same. Now, since we're not mutating the state, this pretty much, I would say implicitly, forces us to have these idempotent methods, which is great, because no matter how many times I will ask for data, I should, of course, I would say the transaction off, I would just have every single time the same result, because of course, concurrently I could get some sort of insertion which would impact my end result. But assuming that there will be no concurrent execution, yeah, every single time I call get methods or I'm asking for the data, the results should be exactly the same. On the other hand, we'll have the commands. So the command is a method which will basically mutate the state, but as some sort of, in opposite to queries, the command will not return any result. So speaking, in a more like C# matter, that would mean that we'll either return void or task, non-generic, or value task, non-generic. So just no result. You either ask for data or you want to mutate this. Simple as that. Now, of course, someone may say, okay, but this is crap. I mean, this is bullshit because I clearly know the exceptions. And let's say, stack.pop, which basically mutates the state of the stack and gives you the element back. Yeah, that's true. I'm not saying that the CQRS it's like followed by every single API that you will find. I mean, it's like sort of principle which will help you to not fall into some sort of pitfalls. And I can give you an example already. I think that was like 3-4 years ago, and I was doing one of the project for the company I worked at that time. And yeah, there was another team which basically created some sort of package, nugget package that was put on the registry. So I basically used this in my project, and one of, I would say, components that I've got in there was some sort of rich domain object that I had to reference. And once I actually go F12 on it and I wanted to see the definition, the IDE only showed me like there is a get set. So I didn't know at that time that there was actually some sort of logic implemented within the properties. So the get actually had its own implementation when it comes to the property of the object. So, without this knowledge, I basically said, okay, this is like property that I want to use. And every single time I was executing the code, I got null reference exception. Now, to me, that was completely mysterious why this actually is eventually set to null, because at some point in code, I've got the value on my property. Now, like later, when I want to access it, it's null. And that's because this code actually violated the CQRS. So get on the property actually had some sort of logic that internally mutated the state of the value that was returned. So you can expect that, yeah, I wasn't very happy once I actually found out what's going on. But yeah, that was also the issue with the IDE, that IDE didn't get the hint that there's some sort of implementation. That was just flat and simplified version when I decompiled the code. So CQRS is rather some sort of good practice that you should incorporate, rather than like every single time you need to follow it. And of course, there are some sort of examples also within, let's say, Microsoft API, which follows it. So the good example could be IEnumerable, which has like .current. So this could be treated as some sort of query, even though it's like the property. And there is a method called moveNext, which internally changes the state machine underneath. So CQRS. Once we actually cover the CQRS, we can move further to its, I would say, natural continuation, which was defined, I would say, a few decades later. I think that was like 2008, maybe. I'm not quite sure who was actually responsible for defining the principle, but for sure that was popularized by both Greg Young and Udi Dehan. And the term I'm going to discuss is, of course, the CQRS, which stands for Command Query Responsibility Segregation. Now, there are different flavors of CQRS actually, and the one that I'm going to discuss at first is the CQRS on the object level. So CQRS said, okay, just do the separation on the methods level, don't mix writes with the writes. And CQRS says, okay, you know what, maybe let's just delegate writes and reads to separated objects. So not only segregate reads and writes, let's say, on the interface, but just put this into separated objects. That will be much easier to manage. And that's pretty much the only significant change when it comes to CQRS, this basic CQRS. Now we'll have the commands, which will be objects responsible for mutating the state of our application, and they will be handled in specific place called handlers, command handlers to be exact. And we'll have another object called query, and this query will be input to our system that will give us the information that we would like to retrieve, some sort of information. And that's pretty much it. And someone may say, okay, so the command now in terms of CQRS is just the object that will contain the data, but we will know that this leads to some sort of state mutation underneath. So what's the difference between the command and, let's say, regular DTO? Well, honestly, the difference is exactly the same like between the layered architecture and the clean architecture. So DTO, as the data transportation object, basically is focused on the data. It's data centric. It's just a dummy bucket for the data that needs to be transported, let's say, from the client to server. While the command, well, command will from the protocol perspective will be exactly the same. It will be just the JSON or like, protobuf, XML, whatever that you'll put in our API. But on the application level, we'll receive the object that will be more like behavior centric. So we'll receive the command that says, let's say, create packing list, or mark particular item as packed, or promote the user to administrator. So the name will be imperative, but the name is actually some sort of convention. But the general idea about what this object represents, the will of the user, is something that makes a huge difference, because seeing this object, I already can expect some sort of behavior. So this is the input from my user, and his will to do something with my system. He wants to promote the user to administrator, and he wants to create a packing list. While once I get, let's say, user DTO, to me this might be anything. This could be like used for the update, for the insert, for something else. I don't know. This is just dummy bucket, and I need to delegate this to some sort of object that will understand what the heck is actually is all about in this particular context. While command by nature will be more behavior centric rather than domain centric. So I would say that this is the very simple, the difference between the CQS and the CQRS. And I believe that was the Greg Young who also, also one of the guys that I really appreciate when it comes to knowledge. And he also was very involved in the popularizing the term of the CQRS. But I believe that on one of the presentations he mentioned that the CQRS is not, it's for sure it's not architecture. So we need to be clear. The CQRS is not architecture. And I believe that he said that it's barely a pattern. If this is a pattern, it's one of the most stupid patterns ever created. It's rather, once again, a principle that you should follow, because you'll either have the will to create something or to retrieve the data. And you can even go further with this thought process, and you can think about, what if I actually don't need one system? Maybe I need two systems, one or rather subsystems. One will be completely delegated for reading the data, and one would be delegated for writing the data. So the CQRS on, I would say, more system level could be something like this, in which basically I have the command that comes to my system, to my, let's say, API gateway or something else, And yeah, the command will go to the right side of my application. And in here, what I've got my rich domain, I've got everything related to, let's say, domain-driven design and etc. And eventually I will store this to database, which could be optimized for writing. On the other hand, once I will receive the query could be delegated to read side of my application. And the difference between write and read side is that whilst on the right side I can actually think about, let's say, clean architecture, on the read side I'll probably want to avoid touching my domain, because domain means that I want to mutate the state. So I could even think about creating a projection or maybe completely different model that has nothing in common with the domain-driven design, like entities, aggregates. I could think about very thin layer that only responsibility would be accessing the data, let's say from the database optimized for the reading, maybe some sort of denormalized SQL database or something else, or like NoSQL database. And the whole purpose of this particular read layer will be just, you know, get the query, get the payload from this query, perform some sort of searching on my database and return the result. So I will not touch the domain, and I have clear separation between what is the domain, what is the business value, and what is just stupid writing, stupid reading from my application. Of course, I would say it's more like, sometimes I think that people call this like enterprise CQRS or something like, not only I have the separation on my system level, but also the database level, because like on this diagram, you have two separated database. So one optimized for writing and also for reading. Of course, you could still have one and maybe do the logical separation between them, or just use a different representation for writing and for the reading. It's all up to you. Of course, if you will decide to have the two separated databases, you need to think about some sort of cost of synchronizing them, because once I put something on the right database, this needs to be synchronized back to my read database, and it has its cost also. We need to think about the data consistency, etc. But this, I'm saying, is only if you really want to have this very clear separation of what actually is a command and what is the right side, what is the part of the system in which I can basically mess up. Because doing the read, which is invalid or basically doesn't work, I think isn't that dangerous. But if you will calculate the discount, the tax or whatever incorrectly on the right side, that may be an issue for the business and for your boss. So I would say, yeah, we can think about three different levels of this separation. CQS, which will be more like method separation. The basic CQRS that we are going to cover is basically the object level. And if you really want to go beyond and you want to have this clear separation and maybe two subsystems, you can have the part of your system dedicated to writes and the other one dedicated to reads. I know that when we speak about the CQRS, quite often this is combined with the event sourcing. And I think that this might be one of the reasons why people are actually scared of the CQRS, because they think that once they will introduce the CQRS, they also need to introduce the event sourcing, which is basically not true. So if you don't know the concept, in a nutshell, the event sourcing is, I would say, some sort of technique which slightly changes the data representation about some domain concepts that you have within your system. So I know that it's not the greatest example, but let's just stick to it. Let's think about your bank account. So you have probably some sort of bank account, and you could think about your bank account in more like relational model approach, in which you have the relation called accounts. There's probably the row that represents your personal account, so you will have some sort of, you know, ID number, your full name, some other stuff, and probably the balance of your account. Now, this model works just fine, and we are taught about this during whole our career. The only issue is that this actually represents the current state of your account. And there might be a case that business comes and asks for a very simple thing. Could you tell me what was your balance like 3 weeks ago or 2 years ago? With this model, you don't know, because this actually represents your current state of bank account. You have no information about anything that happened within the past. And of course, you can think about some sort of audit that you could maintain along with your, let's say, business data, but not everybody actually does that. Now, event sourcing flips this concept in slightly different way. So instead of having just one row within my database, how about relying on concept that we partially covered, which were domain events, or basically the events. So event represents some sort of action that happened, significant action that happened within our system. So instead of having just one row with information that, yeah, this is my account and this is my balance, I could create a series of events which would represent different events within my system. So there will be very initial event, like I've created a bank account, so I, go to the bank and wanted to open it, and then I, withdraw the money, maybe I got the salary to my account, and I would got a lot of those events, which would represent different transactions that operate on my bank account. Now, if I would like to ask what is my balance, like my current state, I would basically take the very initial event, apply it, and then every single event that happened and was stored inside my database would basically change my, let's say, domain object. And eventually, after applying the last event as a scalar, I would know that, let's say, I've got $100 on my bank account. So I'll basically get the whole sequence of this and the whole stream, and as some sort of projection, I would know that, yeah, this is your current state. But the beauty about this approach is that now, if you think about it, I've got very detailed history, what actually happened with my account over the time. And you can even think about some sort of time traveling. So if the business comes and asks the same question, what was your account, what was your balance like 3 weeks ago or 2 years ago? The only thing I need to do is to apply a filter. So I want to do this projection of my events, but only to a certain point of time. Like I'm literally writing like where, and let's say date time equals X. And I'm applying this every single event till this point, and I will know that, let's say, I've got $1,000 on my account. Now, of course, someone may see and spot one issue. So in a previous approach, I've got only one row that I just had to retrieve to my, let's say, application. While now, especially when it comes to bank account, and assuming that I'm very active user of this platform, I may produce like thousands of events. So not only I need to retrieve them and process within memory to get the final result, what is my current balance, but yeah, I'm suffering performance-wise because I need to get this data from database and perform them and process them within my memory, and that's true. So of course the event sourcing will come with some sort of optimizations, like some snapshotting. So every, let's say, 100 events, I will do the snapshot, and I will not, once I would like to know the current state of my domain model, I will not start from the very bottom, but from the last snapshot, etc. But at some point, even if you're performing this optimization, business may come to you and ask for, I would say, one of the most common requirements. Could you create a very simple statistics? We would like to know how many millionaires do we have in our bank. So in the current state approach, you would do something like, find all the accounts within my one table, which have basically the balance column value greater than 1 million, and that would be simple count, right? You basically do the count on the predicate, you got the result, boom. Now, when we think about the event sourcing, this is more tricky, because even if you are applying those snapshot and optimizations, it's not that easy when we try to implement this ourselves. So now to find out how many millionaires do I have, I will need to basically retrieve every single user, apply this user into my domain model in memory, and once I will do this, I need to apply this predicate, because I cannot filter this 1 million balance on the database, because the only thing I've got is the sequence of the events. So based on one event, I do not know whether this actually will whether this particular user actually have $1 million on his account. So I need to get the sequence for every single user, apply this, got the current state of it, so this scalar, and once I've got this list of my all users, I need to apply the predicate, which is just insane. I mean, this is literally insane. So the event sourcing itself is great technique, and especially if you think about systems that will require some sort of undo operation. So let's say that our packing list will have this feature of undoing your changes at any point of time. This is great, because I've got I've got a whole sequence of events, what you've done so far with this particular packing list, and that's great. However, if you don't need such a, let's say, functionality or something more specific that would require this approach, I would say it's just, when it comes to reading, it's just a killer. And now this is where we get back to the CQRS, because event sourcing itself is not optimized for reading, for efficient reading, especially when we think about big volume of data. Its purpose is completely different. So if you want to have the system that is efficient not only for doing this projection for one single data model, but also for, let's say, some sort of statistics for the business and etc., and basically interacting with multiple domain objects, you need CQRS, because CQRS gives you this differentiating the write and read side. So on the right side, I could apply my event sourcing, and I would eventually do the projection only for, let's say, one aggregate, while these changes will get propagated to read side and maybe database optimized for the reading, which could be, let's say, just regular SQL database, which will keep this data in current state model. So I will have two databases, one optimized for event sourcing purposes and the second one basically for reading, because I don't want to read from the event store, which is the name for the database of those events. So if you have the event sourcing, you'll probably need the CQRS, because otherwise any more advanced query will basically kill you. While on the other hand, once you have the CQRS, you don't need necessarily event sourcing. I mean, if you don't have to, yeah, you can just incorporate the CQRS and the separation object on the either object or the system level, but the projections, the events are not necessarily needed. So I think that this is crucial to understand the concept, and people also frequently ask about this. Okay, so what about the CQRS? I think that's kind of overhead for my case. No, I mean, you will see that this literally is just few interfaces and just like one class, which will make your system more granular on the use cases level rather than having one huge application service. And it has nothing in common with the event sourcing. So let me just check whether do I have anything else, but I think that's pretty much it. I just wanted to point this, and I believe that there was a question on YouTube whether we'll do something on the event sourcing. Probably yes, and probably not by ourselves only, because there are quite few people that we know that are mastering the event sourcing, and maybe we'll think about some sort of cooperation, and someone will be more qualified will explain this whole concept in detail. I'll just give you the helicopter view of what is this concept and why there are a few challenges with it. But it's not like the CQRS requires event sourcing. Event sourcing by its nature will require CQRS. So I think that's it when it comes to theory. We can jump back to the code and let's just implement our application layer. All right, so let's implement our application layer. And I think that when it comes to CQRS, we'll start first with the command, so with the right side. And before implementing any specific use case within our application layer, I think it's good to start with some sort of abstractions first, which will represent both the command, so our behavior-centric object input from the end user, and the handler, which basically is the class responsible for processing this particular command. So I will jump to our shared abstractions and add another directory called commands. And let me just add a few interfaces. So first will be our I command. So once again, this will be nothing more but a marker interface for the generic constraint purposes. And another one will be called I command handler of T. So I command handler is the name of the command, and we'll add this constraint, so where the command needs to be both reference type and needs to implement I command. And inside I'll just add one definition for our method, which will be just method that returns task, and I will call this handle async. So I would say that in this particular case we will be quite orthodox when it comes to this principle. So yes, we will accept the command and will mutate the state, but will not return any data from our handler. Of course, this will have its, I would say, consequences, which we'll describe later, but for now let's just leave it as it is. So we've got our both command and command handlers, and one thing that would be cool to add is some sort of, I would say, mediator between the caller of this handler and the handler itself. Because if we think about, let's say, API, and let's say in here we have the controllers, we'll probably have some sort of packing list controller, which would need to execute our application logic. So typically what you would do is basically creating some sort of private read-only I command handler of T, and let's say some sort of command type, and this will be executed in one action, and the other one of another T would be also needs to be injected and used in the another action. So eventually I might end up with a lot of command handlers being injected into my controller, because every single one will be dedicated to the separated action within my controller. Now, this is something that I would like to avoid, because I would rather keep the responsibility of finding the proper handlers to some dedicated components. So in addition to what we've got in here, I will declare one more very simple class called I command dispatcher. So as the name says, its responsibility will be basically to dispatch the command take the command, look for the handler that is registered within our application, resolving it, and executing our handle async method. And that's pretty much it when it comes to the dispatcher. So the dispatcher itself won't be generic because this would make no sense, but the method, which will return the task, so dispatch async, will be actually generic. So in here we'll have the generic parameter tCommand, and this tCommand of course will be our input, and once again we'll pass this constraint that the command needs to be a reference type and implement iCommand. Just keep in mind that this iCommand needs to refer to actual iCommand marker interface, because there's also Windows input, and you will see this later that there's also iCommand defined within the Windows namespace. So if you are worried about this, you can think about slightly different name, but for me iCommand works just fine. And of course this dispatcher will need to have its implementation, and of course quite typical when you will see like blog posts or maybe other video courses, you will see that the CQRS is built on top of Mediator library, and that's perfectly fine. I will just leave it to you. I will not do this because to me it's rather simple, and of course I would need to define the request handlers, and my interfaces would need to implement them. So I would rather want to keep it simple, and I will build this dispatcher on top of regular iService provider, which is nothing more but the container for my dependencies within ASP.NET Core application. But of course, if you have a will or maybe some specific task, and you need some sort of more flavor to your CQRS, I think that Mediator is one of the best choices that you have available, at least in our .NET world. So I want to create the implementation for my dispatcher, but this will no longer be an abstraction, but rather the implementation. So this of course needs to be put into our shared class library. So in here I will create the corresponding commands directory, and in here I can create the actual implementation. I can call it like in-memory command dispatcher, because of course we could think about like sort of, remote execution of this command. Maybe I would like to call like external servers or something, but in our case that will be everything will happen within the memory. So in-memory command dispatcher, and as I mentioned, this will of course implement our iCommand dispatcher. Now one thing though is that I need the reference to our abstractions from the shared package, just like this. Now it's visible. I can implement this. I will make this also an internal, because I don't want this to be public to anyone. And let's just create a private read-only iService provider. Okay, so this is the service provider. Can inject this, make it more like one-liner, and the implementation will be rather straightforward. I will mark this as an asynchronous, and let's just create the scope first. So service provider dot create scope. Okay. And this scope will, as you can see, this requires the Microsoft Extensions Dependency Injection Abstractions. So we'll just reference that particular project. Probably I will need to, there's always some sort of issue. So let's just explicitly add this dependency injection abstraction, which is in here. Maybe the issue is that we've got already a 6.0 RC version, so let's just reference to 5.0. Let's just add it. And now create scope is available for us. So once we've got the scope, I need to resolve the handler. Of course, I will assume that there's only one handler for one method. There's no need to have more than one command handler for specific command type. It makes no sense. We'll have like we'll delegate this to one specific handler. So service provider dot get required service, and in here I will have I command handler of T, where T is of course T command. And once we have the handler, we can call await handler handle async and pass the command. Of course, if you'd like to be more, I would say, follow the standards when it comes to the asynchronous jobs, you probably would like to pass also the cancellation token and put this into the signature of this method, but I'll just leave it simple, just not to produce too much code. Now, of course, we need to also register our in-memory dispatcher within the IOC container. So I will create extensions class. So this will be public static class, which will contain the registration logic. So this will be called during the configure services within this configure services method. So I will just reference to I service collection. So this will be returned, and I will just call this add commands. And I will say that this will be extension method on my iService collection services. I can return the services already, but I will add the registration. This could be either singleton in this case, so like add singleton, I command dispatcher, and then in memory command dispatcher. Another thing which could be quite handy is adding some sort of automatic registration for all the handlers within the application. So instead of doing this explicitly every single time that I will add the handler to my application layer, I would like to avoid the situation in which I need to remember about the registration, because it's rather straightforward and each of them will be probably implemented as some with the scope lifetime. So it would be cool to have some sort of automation code for the registration process. And sadly, the ASP.NET Core container does not provide such a capability of some sort of automation, the scanning of my assemblies and automatic registration. However, there is very cool library that we mentioned a few times on our YouTube channel called Scrator. So Scrator basically gives you two great capabilities added to default dependency injection container, which is basically assembly scanning and automatic registration. And the second capability is decorator pattern integrated with the whole IOC. So I will just reference to the Scrator within our packet shared. So let's just do Scrator and use the 3.3.0. Yeah, I'll just install it. And I will do the following, so services, and now I should see the method called scan. And I want to say that once I would like to scan the assemblies, so from assemblies, and now I need to pass, as you can see, the params of assemblies, and I will do the following. The assembly that I will scan will be the assembly that actually calls this particular add commands. So that will be the assembly.get calling assembly. Okay. All right, so we'll have this add commands, and once we actually have it, I will do add classes, and this class needs to be assignable to. Actually, I need to use this non-generic version. So type of I command handler of T, and once I have it, I can say that I want to implement this as implemented interfaces. I'll probably need to do this in here, okay, as implemented interfaces. So every class that will implement iCommand handler will be registered as iCommand handler of specific T command, and with mentioned scope lifetime. And that's pretty much it. I can now safely use it in my application. So maybe I will just do this right on, just not to forget about it. So that will be the very first thing that we'll do within our application layer. So somewhere in here, I will add, once again, we'll have this convention that every layer besides the domain, because we don't want to have this iService provider within the domain layer. So every single layer besides the domain will have these extensions. And once again, this will be static. Okay. And here I'll do the following. So public static iService collection of T, sorry, not of T, but either iService collection. So I'll just call this add application. Okay, that'll be this iService collection services. Okay, now what I miss is this dependency injection abstraction. However, I don't need to reference this directly from my application, because the only thing I need to do is just reference to my shared. So this is what I do. I've got shared, so now I should have an access to my service collection interface, and I will do return services. And now in here I could call services.add commands. So that basically solves the issue with further explicit registration for every single command handler within our application layer. Now, one thing though, which we also need to be aware of, is the fact that in here, within our domain, we've got few types which also needs to be registered. So we've got our factory for packing list. And the second thing are the policies, which we also defined within our domain. And this also needs to be registered because, for instance, our packing list factory accepts this. And yeah, we need to get this enumerable of picking items policy somehow. And of course, this will happen thanks to our container. So because I want to avoid the situation in which domain will register this explicitly within the domain, I want to keep it very clean. The application extension will also handle this type of registration. So besides our add commands, I will add also registration for the factory first. So I will just leave it as a singleton. It makes no sense to choose any other lifetime. So packing list factory will be implemented as packing list factory. And yeah, at this point, of course, we could see clearly that I decided to make it internal. So there are few ways of dealing with that. You can either mark like within the domain that the internals are visible to the application, or you can basically just screw it and make this like public sealed and make it public, because maybe you would like to be pragmatic and don't produce the code that would be crap. So for me, okay, I will just make it public, but it's your choice. I don't want to I don't want to say that this is like the best approach, but the one that will produce the least code. And the very last thing when it comes to our add application is also something that we've done within our command handlers. So I would like also to automatically register every single policy that will eventually add to our domain. So if any other developer comes up with some sort of policy for our packing items, I would like to automatically register it. And I don't want to bother him with this responsibility of declaring this and adding this registration to our dependency injection container. So I will do the following: services.scan, so something that you already know, and let's just do b dot goes to b from assemblies once again, and I would like this time to refer to a very specific assembly. So in this case, that will be the domain. So I could do something like type of ipacking items policy dot assembly. So this will give me the reference to particular assembly, which in our case is domain. And once again, add classes. C goes to C assignable to, and this will be ipacking items policy. Once again, as implemented interfaces, but this time I will just register this with the singleton lifetime, because yeah, we have all those policies are actually, you know, kind of hard coded. So in our case, that would just work. So yeah, I would say that this is it when it comes to our registration process within both domain and application. And of course, this code needs to be called somewhere. So of course, our entry point to whole system will be presentation layer, which in our case is packet.api. And within our startup, maybe I'll just clean this up a little bit. Somewhere in here, I will just call services.addApplication. So as you can see, add application, of course, just to remind you, the API will see the infrastructure, but indirectly will also see the application layer, because the infrastructure can see the application. So this is why we can reference this with no issue to our configure services. And now this method will be responsible for not only adding our in-memory command dispatcher, but also for registering the factory and all the policies within the domain layer. So I think it's a good time to actually jump into our application layer, add first command, and eventually we'll also add the command handler, which will execute the whole process logic of our application. So within our packet application, I will just add new directory, and I will just call it commands. And in here, I'll put the definition for our commands. So as by the convention, the convention I would recommend when it comes to our commands would be give the name, which will be imperative. And thanks to this, you will have an ability to completely omit the command suffix. So in this particular case, I would like to create the command which processing will end up with creating the packing list with pre-generated items for our travel. So I will call my particular command create packing list with items. So kind of longish name, but I think that it's still fine. So create packing list with items. And yeah, by just looking at the name, I will immediately see that this indeed is the command. So of course I need a few things in here, and first and foremost I will just put the iCommand interface, because I want to explicitly say that yeah, this indeed is our command. And now I will need few details within my command that will be used for the whole processing. So I will just make this a record, and the parameters I would expect from my user would be the following. So first, I would like to have the identifier for my packing list, then string name. And just keep in mind that on this level, on the application level, I don't actually use the value objects. To me, the command itself is, of course, it's like the object which is behavior centric, but it comes from the client. It's more on the transportation level, I would say. So in here, I don't really mind to have the primitives. It just doesn't bother me, because eventually this will turn into the into value objects that we defined within the domain. So we expect the identifier, the name, and now the parameters that will be used for this items generation. So first I will just pass the ushort, which will be days. So days of the length of our travel. Then the gender. So in here I could either try to pass the number, or I'll just leave it as it is. So that will be just much simpler. So gender. And then we need to pass also the localization. Now, as we already know, the localization consists of 2 strings actually. So this is like the city and the country. And of course, there are a few different approaches how you can actually tackle this. So you could either pass like 1 string and maybe split this on the UI with like comma or something else, and now try to make this some sort of composition and extracting this piece of data from the string, or you can basically wrap it into some nice model and put into our command. So I'll just do this as an example, and I usually like to call those models which are, let's say, more complex objects within my command, I like to call them write models. So just like you have typically like read models on the read side, and here I will just have the write model. So write model is the part of my command, but not the command itself, and it's, as the name says, only used for the writing purposes. So I will just also create this as a record, and I will call this localization write model. And in here I will put both city and the country. Just like that. So now I can use it. And I have my command definition. Now, the next part is, of course, having the handler. So usually what I do when it comes to the file structure is the following. Within my commands directory, I will just create the subdirectory. So right click, directory, and I will just call this handlers. And in here, the convention will be the following. Just name of our command. So maybe I'll just copy this to avoid any sort of typos. And handler suffix. So create packing list with items handler. And once again, I don't want to have the explicit command word in here. To me, this actually, by the name convention, gives me enough information that, yeah, this indeed is the command. And I will just mark this as I command handler of T, where T is our T command. And this is why we had to mark create packing list with items as I command. So just like this. And we have now our handler being defined. Now, what I would like to do in here is, of course, few things. So if we would jump back into our factory within the domain, we can jump into our interface. So this is the method that I would like to eventually call, right? So we already have our ID, name, days, gender, and localization itself. However, we need the temperature as well, because we already discussed that, yeah, getting the temperature information is rather part of the process logic rather than the domain logic, because the domain just expects that we have this domain, that we have this temperature information. So this is something that we need to get on the process level. So for sure, that will be one of the steps that our handlers should perform. And of course, eventually we should call our factory to create the packing list. And at the end of the day, we should also use our repository, which is defined in here, to call our addAsync method and put this somewhere. Eventually, probably that would be the database, but from the domain's perspective, we don't care where this aggregate actually gets persisted. So in here, we already know that what we should do. And just before I will execute both these methods responsible for getting the temperature and calling our factory, I would like to make this command handler more idempotent. So we covered the idempotency during CQRS discussion. So once again, this idempotency is basically this ability to execute this particular method multiple times, and the results should remain the same. So in this particular case, I would like to make sure that even though I will, for some bizarre reason, I will call this handler like 100 times, I will only create my packing list once. And of course, implicitly, this method will be idempotent, and this is because we use the same identifier. So assuming that we'll also always have the same identifier, we'll probably get nasty exception from the EF that would say that, yeah, you try to put the element with the same primary key, so this is basically not allowed. But maybe I would like to avoid such situation in which ORM gives me more this, bad looking exception, and maybe it would be also a good idea to think about my custom exception, which would be more, let's say, human friendly. So at first glance, I would like to check whether the packing list already exists within my database. And for this purpose, let's say that I would like to check the existence using not the ID, but by the name. So the assumption is very simple. I can only create the packing list with the name once, and no duplicate is allowed. Of course, that's slightly different from the assumption that we had on the domain, but let's say that we changed our minds, or the business comes and says, okay, we need to check the existence of this packing list by using our name. Now, this is slightly interesting because now it turns out that the packing list actually has now the natural key, and this natural key is name indeed, because if we need to check the existence of this packing list using our name, this means that this needs to be unique within the whole system. Of course, our model is simplified quite significantly because we don't have the user definition, and probably once we would introduce the users, the natural key would be some sort of composition of both user ID and the name. And based off those two, we could create some sort of natural key composed, which could be used even on the database layer. Like performance aside, this could be used for searching the unique resource within our database, and this actually would not be required any longer. Of course, for the database, we would need to provide like some sort of primary key, but yeah, we without knowing it, we could ask for a particular, let's say, packing list or any other resource in case. So I would like to check the existence of my packing list based on the name. Now the question that arises is, okay, so where do I put the method responsible for checking my existence? And of course, the obvious candidate would be, yeah, I've got the repository, I've got like get async. So I'll just create like task that returns the Boolean, because who cares? We could do Boolean. Of course, we could do something more robust, like some sort of response of T or something, but we don't care. Let's say that we just do task.bool and exists async. And in here, we can pass the name. So packing list name. And that's pretty much it, right? Now I can inject my repository, and this repository will be used within my handler. And here I will just call it. And yeah, if the result is true, then I will just throw an exception that sorry, but this already exists. And if it's false, then we'll first gather the temperature and then eventually call our factory and save this using the repository once again. Now, the issue with this approach is, there are actually few issues with this approach. First is that by doing this, we kinda, I would say, we kind of broke the whole idea about the repository, because the repository, as I mentioned during the implementation of our domain layer, the repository itself is rather the contract built on top of our aggregate. And let's just not even now skip the aggregate term, but more like domain model. Now in here, neither our domain model is neither used for the input nor for the output, right? So we just get the value object and we have this bool being returned from the method, and that's pretty much it. There's no domain model being involved in this process. So yeah, okay, we could think about this like, oh, yeah, let's just be pragmatic and just don't complicate our life even more, right? We already have quite complex structure within our projects comparing to, let's say, clean architecture, layered architecture. But then there are a few different scenarios. So let's say that now at some point in other command handler, I would like to perform something else. Maybe I would like to check whether, some other conditions are fulfilled. And for this case, I would like to, using, let's say, different parameters, maybe temperature or something else, I would like to check whether there is a packing list already for the same localization, because maybe I would like to modify this instead of adding new one, or any other stupid requirement that may come. So this would mean that every single method would require adding new method for searching particular either, subset of our aggregates or something else, and would end up with multiple weird stuff that actually, I wouldn't say it actually fits quite well into the repository concept, because this used to be, or it's supposed to be, just a contract built on top of our aggregate and our domain model. And now we more treat this as like sort of universal interface to which we put everything related also with gathering the data. And that's something that I would like to avoid, especially once we'll move to our query side, because now we are only about the writing to our application. But what happens if we would like to implement the query and the query handler? So let's say more robust searching. I would like to search using my name and maybe using my location or something else. And eventually I would like to return also the result, which will be probably paged. So in this case, should I also put this into repository? Because if so, this means that in the domain layer, I need to have the concept of paged result. And now this is kind of weird, because in the domain, let's say, discussion, there was no page itself. There was like, the core domain is like packing list functionality, right? And this is the concept that we know. And yet now in the domain, I need to know, let's say, something related to pagination. That's something weird. And we'll end up once again with multiple different methods that will be responsible for different types of searching. So this is what I would like to really, I would like to focus. The concept of repository is built especially for defining the strict contract on our domain model. And if you need at some point on the process logic, you need to check the existence, you need to have some sort of search, or eventually once you will shift to query side, you will need also some more robust like functions for retrieving subset of our packing lists. Then repository is, you could do this in here, but you would end up with the repository itself growing way too much. And this is something that I would like to avoid. So instead of doing this, like with this method in here, I would rather do the following. My application now, so my application layer needs something. So why don't we just define the contract on the application level, not on the domain level? And this eventually gets implemented by the infrastructure probably. So in here, I would just say that maybe I'll create something like services. And in here, I will just create a very simple interface. And let me just call it packing list service. Maybe read service, because that will be more restrict. So packing list service is of course the interface. And in here, I will just put the method that we wanted to use. So task that will return the bool. In here, we don't even use any specific value objects. I mean, we can, but this is more like process logic. So yeah, it's not that restricted anyway. So I will just put the method called exists by name async. And here I'll just put string name. Now, what it gives me is now that I have complete separation between what is the domain and what operates on my domain model, and what is eventually used for processing on the application layer. So I don't care about the implementation yet, of course, and I can just jump into my handler and inject things that will be probably needed in here. So first is, of course, I will use my packing list repository, because repository will be eventually used for persisting my aggregate. I will also use my factory for creating packing list. And now I can inject my packing list read service. Just like that. And let me just initialize this from constructor. Okay. And we can start implementing our process logic. So I will just mark the method as async, and I can do the following. So await, then our read service dot exists by name async, then command, and if we have our command, I can do command.name. And now what happens? If this returns me true, this means that I already have the packing list with the same name. So in this case, as I mentioned, I would like to throw my custom exception, just like we've defined the custom exceptions on the domain layer. I would like to do exactly the same thing on my application level. So within our application, let's just add directory called exceptions. Okay, and here I will create the class that will be called packing list already exists exception. Okay, and I forgot about the X. Okay, and this will derive from pack it exception. Okay, so we will accept the name, and the information goes here, says packing list with name, and then the interpolation already exists. Cool. And of course we can also assign this to some sort of property. Okay, now it's just a matter of throwing this in here. So throw new, and in here I will do the following. So command.name. Now at this point I would like to do one more thing, which I believe would make more sense. And I would like to use one of the capabilities of our record. So just to remind you, we have this command implemented as a record. So records implicitly gives you the object decomposition. So they implement this deconstruction, sorry, not the decomposition. So they basically implicitly implement the deconstruct method, which allows you to do the following. I could do var, and then inside I will just put every single thing that I have. So ID, name, what do we have next? Maybe I'll just see days, gender, localization. Okay, so name, days, gender, localization. Okay, and I'll just do command. Now, as you can see, I have multiple variables which basically are assigned from the command internals itself. So I've got my ID, which is a GUID, name, days, ushort, gender, and localization. And now I can just use them as local variables. So this command dot is not required anymore. So I think it's already looks way, way better. And okay, that was the step number 1. So this gives me this sort of idempotency, and no matter how many times we'll call our method, I'm ensured by this check that the particular packing list with the name, which became our natural key, will be created only once. Now, we need to gather the information about the temperature. And this will be yet another service actually that we can define within our application, because our application don't care which resource we'll actually use to get this information. On the application level, we don't care. So this could be either my local file, this could be some sort of web service, or I could create a request to the moon and back, and maybe there is some sort of station that will give me such an information. I don't really care how you will actually implement this. I will just define a contract, and this contract should basically be implemented somewhere, probably once again on the infrastructure level, and should provide me the information based on the input I will give you. So in here, I will just create an interface, and I will call this iWeather API service. This could be something like this, or maybe something more, maybe service without API, because API already suggests that there will be some sort of API underneath. So I will create iWeather service, and I can jump back. Maybe first let's implement this. That will be also cool. And this will give me some sort of response. Maybe for now, we'll just don't define it. And I will just call this get weather async. And as the input, I will use our localization value object that we have. So let's just now focus on the response. So response will be probably some sort of, once again, read model or the DTO that comes from somewhere, but this could be either API or some other source of this information. So I will just stick to name DTO, but you can do whatever you want actually. So in the application, I will create a directory called DTO, and I will put another one called external, and that's the convention that you can adapt or not. Basically, external means that we are the consumers of this DTO. If something is in the DTO directory directly, this means that we are producing this DTO. And the external just says that, yeah, this is something that comes to our system rather that our system produces. So external, so clearly to distinguish those two concepts, and I will call this weather DTO. And this, I could actually make this also as a record. So weather DTO. I will not change the payload itself. This could remain the immutable, so I don't care in this particular case. So let's say that this will be double, because this probably should be double. I mean, the temperature isn't always, let's say, exactly 36 degrees of Celsius. It's rather the continuous value. So in here, I will just put the double temperature. Okay. And now I can use it as the expected result of my DTO, of my weather service action, which in this case is called get weather async. And once again, the beauty about this approach is that at this point, I don't even know how am I actually going to gather this information. And yeah, the reason I'm doing this because I don't really care. This is not that I should be bothered about at that point. I just assume that I will get this eventually, and how I'm gonna to do this is just the implementation detail. So I would like to call my weather service to get this information. So first I need to construct the localization. I partially have the localization in here. However, this for now is implemented as a write model, so localization write model. So I will just maybe change the name slightly to localization write model, because localization is the value object that I would like to create. So localization equals, and in here I could do new localization, and that will be write model dot city, and localization.country. Okay. Now having the localization, I can safely call my weather service. So weather equals await, then weather service.getWeatherAsync, passing our localization. And now I can perform maybe some sort of check. So if this weather is null for some reason, maybe I got the typo in my either country or the city, and yeah, basically this resource couldn't give me this information. Yeah, once again, this is the business decision. So what I'm supposed to do in this case? So do we even care about the fact that we don't have it? Okay, maybe the packing list won't be as precise as we would like to, because the temperature is basically not fetched from the service. But maybe for our application, this weather information is critical, and we would just want to avoid the situation in which this happens. So we can have this assumption that if weather is null, we want to throw an exception once again, and basically abort the whole creation process of this packing list. And one more thing that I would like also to discuss is this difference between the exceptions and on the application level and the domain level, because someone could say, okay, but why these exceptions are defined both on the application level and on the domain level? Why just don't get this thing into our domain and just completely get rid of the exceptions on the application level? Well, to me, it's like this exceptions on the application level basically belong to process itself. So packing list already exists. So if we think about this, do we, from the domain perspective, know that something already exists or not? I mean, the scope of the domain is quite narrow, and it's probably the scope of one instance of, let's say, our aggregate, which is packing list. So packing list, from the packing list perspective itself, it's like it's always present. It always exists. While eventually on the application level, we may have this information that, okay, but we wanted to check whether this exists, and this actually is. So we want to inform the user about this situation. But it's slightly different level. The application, you need to remember that the application orchestrates the domain. So during this process, we discovered that we have a conflict on the name, and we want to inform the user, while once we'll actually start performing our domain logic, we on that level within our particular aggregate, we might have a different issues like in here. So this is something that we need to distinguish. What should be defined within the scope of our aggregate is basically, or the value objects that we have within, or what actually should be thrown as some sort of part of our process logic. So in this case, because the weather comes naturally as some sort of result from our process logic, I would like to put this into rather application level, because domain expects that, we'll basically give you the temperature, right? Sorry, not in here, but in here. The temperature is always present. It's not nullable. So it makes no sense to say like temperature is null or is empty, because the domain definition doesn't get the concept that this might be null or not. It always needs to be present to call this method. So let's just jump into the exceptions and create the one. So maybe missing localization weather exception. Okay. And once again, that will derive from packet exception. Okay. And I can pass the localization as a whole. Okay. And the message. So couldn't fetch weather. data for localization. And here I can do localization.country, maybe slash localization.city. Let's just assign this to property and we can now use it. So somewhere in here, throw new. Okay, throw new, and we'll pass the localization. Okay, and now the last part, which is actually the most important. So creating our packing list. So packing list equals, and now we can make the usage of our factory. So factory.create with default items, and we can pass our identifier, name, days, gender. Now weather.temperature and localization. So it's good. And at the very end, await.repository at async and packing list. So that will be whole process logic that we have within our handler. First, provide some sort of idempotency by checking the existence of the name, and for this purpose we created this very simple abstraction that will gives us this information. We don't want to put such weird, I would say, methods into the repository because the purpose of this repository is slightly different. It's not like just dummy container for every single operation that is connected to our database. It's rather basically the contract for our aggregate. Now we have the localization, and we ask some sort of resource for this piece of information. For now, once again, from the application level, we don't care how we'll actually provide this information, whether this will be some sort of external API or anything else. We check whether we have it. This is this assumption that we just need the weather for the further processing, and eventually we call our factory, which underneath will use the policies for creating this default items, and the returned packing list is just persisted once again somewhere because we didn't have the implementation yet. And that's pretty much it. That's the whole definition of our process. And it's what I really like about this is, like, in this particular case, and this is something that I partially covered in the CQRS introduction, is like if you would have one huge application service for everything related to packing list, that would be kind of weird in terms of dependencies that we've got passed into our constructor, because for this creation process, we not only had to fetch inject the weather service, but also the factory. And for any other, like the updates or for the deletes, we'll probably not gonna need it. And probably also the read service won't be even used. So let's say for the update and for the delete, the only needed dependency would be repository. Yet still, we would have to, every single time we'll have to inject those three as well. And of course, if we'll have different types of actions within our application, then yeah, eventually we might end up with one service which would accept like 10 dependencies, because each of the action would require different components. So in this approach, it's more granular and it's more like on the use case level, and every use case might have different dependencies, and we just provide them individually rather than having one global container for the whole process logic. And that's really really cool. So because I don't want to bother you with all the possible use cases that we might have, because I would like also to have within our application something responsible for adding the new packing item, maybe marking this as a packed, maybe removing the whole list. Yeah, there will be quite a few scenarios that we could implement. So let's just use the magic of movie editing. I will just do the cut in here, implement this, and you'll eventually see how the other handlers will look like, and we'll jump into the query, so the read side of our application. Okay, as you can see, there are a few more commands that we have now within our Packet application. So let's just go through them, and eventually we'll also see the handlers that will process each of them. So the create packing list with items was the first command that we have, and now of course once you have the list, you can add or remove some sort of items. So let's say that we have like add packing item. This is the another command that we have, and this accepts three things. So packing list identifier, name of our item, and the quantity. Same goes for removing. Of course, we have also the ability to remove the packing item, and this accepts the packing list identifier and the name of the particular item. We also have the management for the list itself. So we can remove this packing list completely. And do we have anything more? I think that that's pretty much it. Oh, and we have the pack item, sorry. So we can basically mark particular item as packed. So maybe some sort of flag will appear, some sort of icon that, yeah, we already have it within our luggage. So let's maybe start with the delete packing list. That will be quite easy. So for deletion, we basically use our repository to fetch the packing list. This actually has a typo, so we'll do this like this. So packing list, we're checking whether this is null. If this is null, then we want to throw an exception that you want to remove something that does not exist within our database. And if this is not the case, we basically call repository.delete async passing our packing list, and that's it. For adding the items, so let's say this one, once again, we are getting the information about packing list, and if this is null, we are throwing an exception. Then we are constructing the packing item, and we're adding this to our packing list, and then we call update async. Same goes for the removal stuff. So in here, I'm checking the packing list, then I'm removing the item by calling this remove item method, and I'm calling update async. And as you probably expect, same goes for the packing, for the pack item. So I'm getting the packing list and calling basically the method on my aggregate. So it's rather straightforward. Once you actually get the idea, it's like no-brainer. You basically try to orchestrate in a very simple manner the whole process, which accept the command and eventually probably call our repository, because at the end of the day, this command needs to mutate the state somehow. Of course, there might be situations in which this will be slightly off the domain, maybe more infrastructural concept. So I'm not saying that in like 100% you should always call the repository at the end of the handler itself. But in most cases, like 95% would probably end up with some sort of repository call. Of course, once again, just a matter of the style, because as you can see, the packing list and checking this null existence is quite repeated in this. Of course, you could think about some sort of maybe extension method that would be added like somewhere in here, like throw if not found or something. It's the matter of whether this actually bothers you or not. To me, if this does its job and I'm focused only on particular use case, it's not something that I would it's not something that basically bothers me, but it's all pretty much up to you. So this is how we are going to tackle the writes to our application, right? We are just talking about the writes, the mutating the state, and yeah, that will be pretty much it. And of course, at some point we would also have to implement the reads from our application. And the reads, as we already know, are basically built on top of the queries. So queries will return us some sort of result, but they will not mutate the state of the application. So what it means is that ideally queries should be completely off the domain, should not touch the domain itself, because it doesn't actually make much sense. If my only purpose is to retrieve some data, do I really need to construct the whole aggregate and, you know, use it for the reading? I mean, for us, it's even more, I would say, makes less sense, because everything is basically hidden, besides, you know, maybe besides the identifier itself. But we cannot easily access and create the predicates, even complicated predicates, on top of our private fields. And we'll see this once we'll actually implement the whole repository and the query handlers on the infrastructure level, that it's rather gonna be quite complicated. And this is, once I would say, pros and cons of this approach. I mean, it's really hard to implement this efficiently, but on the other hand, maybe this will convince you not to use your aggregate also for the reading. So we'll get to this point later, and we'll discuss the whole issue. But at some point, this is something that we'll also need to cover. But of course, we cannot jump into the queries already, and that's of course because we don't have the definition for the query and for the query handler and probably for the query dispatcher. So just like we've done with the commands in here and in here, we need to provide both abstractions and the implementation for the query handling, and eventually we'll jump back to our application layer and continue the whole implementation process. So let's start with the abstractions first. I'll create a directory called queries. And first thing would be, of course, adding the query definition. So iQuery. Actually, that will be an interface. So interface iQuery. So I will just create two versions. First will be this for the generic purposes once again, and the second one would be iQuery of T, or maybe T-result will be even better. So T-result, which will implement this iQuery. Okay. And now the interface iQuery handler. So iQuery handler of. And this will be slightly different because I will accept two parameters. First will be tQuery, and tResult will be the second one. And now I can put the basically I can put the generic constraint, which would set that the tQuery needs to be a class, and sorry, not the class, but needs to be the reference type, and this also needs to implement iQuery of tResult. And in here I will create the definition for tResult. Handle async, I will just stick to this convention, this naming convention, and the tQuery will be accepted as a parameter. So I will accept the query, and I will return just the result. Of course, in here I can make this now in. Okay, and we already know that we'll probably need some sort of dispatcher. So let's just define this within our abstractions. So iQuery dispatcher. Okay, and the dispatcher basically once again will accept some sort of query and will return us the result. So tResult is the one that we expect. I will this time I will call this query async, but this could be like dispatch async, whatever. tResult, and as a parameter I will expect iQuery of tResult. Okay, so let's just jump to shared next. Once again, we need to create a directory, queries. Okay, and in here let's just create in memory query dispatcher. Okay, this dispatcher I would say is gonna be slightly more complicated, and that's because now we have to construct the generic type within it. So I will do iQuery dispatcher. So just like this. I can make this internal sealed class. So what I need inside is of course my service provider. So private read-only I service provider. Okay. Let's just make this prettier. And in here, I need to first create the scope. So using var scope equals, and then service provider that creates scope. Then I need to resolve particular I query handler of T result T query. So to make it happen, I will just use the reflection. So handler type would be type of, and then I query handler of T query to result, and then make generic type, and inside I will put both query.getType and type of T result. So what I'm doing is basically I'm getting the types of both query and the result, and I'm putting this into those two as a generic arguments. And now I can use this type, because this of course gives me this handler type is of type type, and I can use it for my service provider to give me particular handler. So that will be just the matter of var handler equals, and then scope dot service provider, then get required service, and here I can pass my handler type. The issue is that, as you can see, the handler now is returned as the object because I've just provided you the type. So naturally the returned this handler is of type object. So to make it work, I will do the following. I will just already return this, because this will of course return me the result. And I will do await, then handler type, and then once again I will use the reflection, so get method. I could either hard code this, but I would recommend using the name of operator from the C#. I don't remember which one, it's probably 7 or 6. I query handler of, let's say I query of result and to result. This is just to give me the query. Sorry, this. Okay. So basically, this will just return me the string which says handle async. But if you would like, you could just remove it and put into regular string. If you are ensured that this method will, like this. If you are just ensured that the method of our handler will always remain like handle async, you can do this. But I will just stick to this name of, and this will return me the method. So this could be potentially nullable, but I will just make this assumption that it's not. And I will just call the invoke. And now on the invoke, you need to pass the object on which I will call my handle async method, and this object will be returned handler. And I will need to pass the parameters to my handle async method, and my method accepts only one parameter, which is the query. So the way to do this is, even though I have the only one parameter, I need to create an array and pass the query. And the reason this is actually still red is because invoke also returns the object, and object by definition is not nullable. So I need to explicitly say that, indeed this will be the task of the result. So to sum up, what actually happens in here is that the issue that we had is that we couldn't ask for I query handler of I query of T result, because that would basically return as a null. So to prevent this situation, we basically constructed the generic type. So we just said that this is the template, and in those two generic arguments, we need to put the particular type. So we are getting the type from the query, we are getting the type of our result, we are putting this in here using the reflection. And now this will be the proper query handler that will be eventually implemented somewhere within our application. So the handler object should be returned. However, now we have the issue because this is of type object. We cannot call the handle async. So we are using the reflection once again to call the method called handle async. And we want to call this on our handler object. And the passing parameter will be just the query because the handle async only accepts one parameter. And we are saying that, yeah, this invoke will actually result with task of the result, so we can safely await this, and that's pretty much it. So now it's just a matter of, once again, doing the automatic registration and already registering our in-memory query dispatcher. So I will create extensions, so public static class. And, I think that I'll just use the copy paste pattern for this. So let's just move in this add commands. I will just move it in here. Okay, to make this more granular, and do the following. So just copy this. Okay, resolve add commands. Now it becomes add queries. And in here, first I need to register the in-memory query dispatcher. Okay. And now I just want to automatically implement everything that implements iQuery handler. Okay, and yeah, that's pretty much it. Now it's just a matter of calling our add queries, and we should be ready to go. Now I want to discuss actually this method and where should we call it, because obviously once we'll get back, I think that I can now collapse. Okay, once we actually have the both commands and queries definition, the obvious choice would be to put the queries and query handlers on the application layer, right? Because yeah, this is quite natural. I mean, the command which were responsible for writes are within the application, and I was saying a lot about the process logic, etc. So naturally, since the CQRS is the concept of the query and the command is, in terms of CQRS, is tightly coupled. This means that both commands and queries should live in the same layer, right? So in this case, the application layer. Well, I would say yes and no, and of course this is once again just a matter of your opinion. But to make it more clear, let's just add one simple query as an example. So within our application, I will just add queries directory, and once again, I will have this naming convention that if something is like get or search, I will just know that this is rather the query, so I will just omit it completely, the query suffix. So let's just start with something simple like get packing list. Okay, so get packing list is our query, and I can mark this as I query of. And now at this point, it would be probably a good idea to come up with some sort of either once again read model, or I will just stick to this DTO convention that I'm expecting like some sort of packing list DTO as a result. So let's just maybe add this first, and we'll eventually get back to the discussion about the queries. So let's start maybe with more granular stuff like localization. So localization DTO. So localization DTO will have like two things. First is the city, and then we have country. Okay, so we have city and country. In this case, I'm leaving this with the public getters and setters because I'm the producer of my DTO. It's not like in this case, like with the weather DTO, which was the result of calling some sort of probably external system. But in this case, I'm creating this, and I don't care on the read side. I don't really care about the hermetization because it's not all about this. If I want to automatically or dynamically during the execution of this query add or fill these properties, I want to have the ability to do this. So since I've got the creel separation on the domain and the reads, in this case, I don't care about the, this class being like hermetic or something. Now I can add the packing item. So packing item DTO. And once again, prop string, and that will be rather name. Okay. And we also had quantity. So the quantity and bool, which says whether this is packed or not. Okay. And last but not least is of course our packing list DTO. So the packing list DTO will have identifier. Then we will have string name. Then we had localization, I believe. Okay. And the list of our items. So packing item DTO items. Okay. Now I can use it as my T result. And of course, for the query, I can have, the payload that will be used for constructing this particular result. So of course, for this case, it's rather straightforward because I will just accept like the identifier, and based on this identifier, I will find particular packing list name. Of course, since we have this assumption that the name is like sort of natural key, I could also use the string name for this purpose, but we can stick to the identifier itself. Now, let's just try to implement this. Okay. So handlers, we already know it. So this convention will be also the same. So get packing list handler, and let's just implement this like get packing list, and the expected result will be packing item DTO. Packing list DTO. Okay. Implement, and we are ready to go. So our job in here is to return the packing list DTO based on the identifier provided within our query. So in here, it's rather straightforward, right? Because we have our repository. So packing list repository, I will just inject this in the constructor. So now it's just the matter of doing packing list equals, and then I need to make this async. So repository dot get async, and here I can pass query.id, and in here I will do like return packing list, and assuming that this is null, I will return the null, and if it's not, I will probably have some sort of extension method that will make this DTO. It's rather straightforward, right? Like no brainer. So to me, this looks good, right? I mean, we use the repository and the method that was given to us by retrieving the packing list by identifier. The only thing that bothers me is the fact that we actually touch the domain. I mean, the repository by definition needs to return the domain object. So theoretically, there is once again nothing that could stop me from doing, like, you know, calling some sort of packing list dot add item and eventually calling my repository once again to modify the state while reading. So I could do something like this. I mean, it's completely stupid, I know, but once again, I didn't provide the environment that would allow me to do sort of thing. But yeah, this is just the matter of, I would say, theoretical assumption that someone would like to mess up with my query side. However, completely skipping this particular topic, let's just jump into another example of my query and discuss it. So I will just add something that will be probably required at some point. So query that will return me not the one packing list, but maybe few different, based on some sort of maybe search phrase. So typical search in which you type some phrase and you get the filtered result. So in here, I'll create a query called search packing lists. And this will return me iQuery. For now, I'll just stick with the IEnumerable, but eventually probably I should change this to some sort of paged of T, where T is packing list DTO. So packing list DTO. And as I mentioned, I will just pass one parameter called search phrase. Okay, we have our query. So now it's once again the matter of implementing this. So iQuery handler search packing list, and this will return me IEnumerable of packing list DTO. Okay, so the handler is in here, and now let's just discuss how we are going to implement this, because this situation within this particular let's say reading scenario is completely different from this one, because in here I had the method that was giving me one packing list. However, I don't see anything that would accept the string or anything that would be even close to string and would return me multiple packing list aggregates. So once again, I wanted to jump back to this topic and discuss what should we do. Of course, I could do like something like task return that returns like IEnumerable of my packing list, right? And in the query, in the command side, I said that, yeah, this exist async was slightly dumb because either bool or name was not the domain model, while in here it clearly is the part of the response, right? So something like search async should be just fine. So string, and that was like search phrase. Now the issue that I have with this particular thing is that once again my domain got dirty with some sort of search-ish stuff. I mean, the search was not part of my domain language. So during discussion of the domain, there was never something about the searching, right? The core domain was the packing list and the capabilities of managing this and generating. Yet still, at some point, I wanted to add to my contract, to my aggregate contract, the methods responsible for searching. But what would happen if I would expect the query to return the paged result? So does it mean that now paged is should be present also within my repository? So should this become the part of my domain? Probably not. And just like we've done with the read service for our packing list, the reason that we've done this is to completely prevent the situation in which our repository gets bigger and bigger and gets and quite a lot of unnecessary terms are passed into our methods. So why should my domain and from my aggregate perspective, I should really care about something related to searching? So even on the exception level, we've got this distinction that if something is not found or already exists, this should be put into application level because it's more related to the process logic. While in here, while my repository should be responsible for searching, this is something that I would like to separate this. So we know that repository itself is, I would say, it's not good place to put such things. And of course, another thing which would probably kill us at some point is that we might have different searching. I mean, our application is just plain simple, but what if we have different types of searching, like searching by name, searching by localization, searching by combination of those two? Should every single search should have this separated method with complicated name, like search by localization and temperature async? And you know what I'm going with this. Like every single scenario should be wrapped into method and should have its unique name. And at some point, this search might be so complicated that you would end up with the name which is completely bizarre. I mean, would be ridiculous, ridiculously long. Or you would end up with something that is maybe not precise enough, like search async. But there might be different criteria for this searching. So I've used to do such things, and and we are basically ending up with the methods which were like 10 words long, and it was just completely stupid while reading the code. So first is like, I don't want to put this into repository. Now, knowing this, that my domain should remain clean, and knowing this, that I probably would like to avoid the situation in which I'm getting at this point my aggregate completely, because I don't want to execute any domain logic. Now there are a few different things that I could do about it. So first thing is, okay, I will create the method in my packing list read service, like in here, and I will now be smart enough to do the following: packing list DTO. So now it's better because I'm not touching my domain. It's just the already prepared result which gives me the DTOs, and I'm using the abstraction that will inject into my query handler. And that's already better than, playing with the repository. However, we still remain with the issue of naming our methods. I mean, in this it's plain simple, but once we will introduce more robust searching with different criteria, these methods will just be completely ridiculous when it comes to name. So another thing is, okay, maybe let's just, that's a good point. Let's just don't do it. And the easiest way would be to basically operate on the SQL connection and return this. And there will be no necessary, no such thing like wrapping this into some sort of methods would be necessary, right? And that's true. So why don't we just put the EF core package into our application, and in here I would just do private read only and some sort of packing list, or maybe packet DbContext, right? That I will create within my application layer. And in here I will just use this DbContext to call my SQL and gather the information and make the projection directly on the DTO. So I'm not having additional methods with stupid names. I'm not touching my domain. And I'm just returning the raw result directly from my query handler. And that's almost ideal, except the fact that by doing this, we actually kinda destroy the whole point of our application, because the point of application was to focus on the domain orchestration and basically on the use cases, while being completely off the implementation. We're not aware about the implementation. While in here, of course, I could make this assumption like, okay, I will just use this EF core only on the read side. But once again, there is nothing that basically stops me from injecting this DbContext into my commands now, because I don't have the separation when it comes to the layers. So you might end up with the same issue that we've discussed with the layered architecture. So we are not relying on the abstractions anymore. I mean, I could create as many abstractions as I would like to, but somewhere internally I'm depending on the implementation detail, which in this case is the ORM, and this kinda destroys my whole concept of this architecture being, let's say, clean. So I would say that the only two possible scenarios that are acceptable for me are, first is like separating the commands from the queries completely. So you would create like application.writes and application.reads, and there will be just this assumption that application.reads can have this I would say, I wouldn't call this abstraction leak, but yeah, you basically can have this direct dependencies to your infrastructure, because you don't care in there, right? The domain is on the write side, not on the read side. Or if you don't want to have even more projects, the easiest way would be to keep the queries definition on the application layer, but the handlers will be defined within the infrastructure layer. And within the infrastructure, since this is all about the cross-cutting concerns and all about the everything which is technical, yeah, in there we can inject safely DbContext and or any other connection to our database, because yeah, we will be within the infrastructure and we don't care anymore about the abstraction leaks. We are on the technical side of our project. And now this implementation of each particular command handler will be rather technical concern. So this is what I'm exactly going to do, and that's because I don't want to mess up with the structure, and I would also like to avoid this unnecessary abstractions on top of DbContext, which would be just weird. And actually, it makes no sense to create the abstraction on top of such thing like the query. And specific query, because you would end up with this naming hell. So that would be pretty much it when it comes to the application layer. So application in our case would be responsible pretty much for the write side. And in here we have this nice structure when we have the commands and the handlers, while yeah, the queries definition could live within the application layer as well. But the handlers will be basically extracted to prevent this abstraction link, and will basically implement them on the infrastructure level. All right, so now it's the time to finally implement our infrastructure and everything related to our infrastructure. Of course, we'll start with the most important stuff. So the whole ORM configuration, because we'll need this to finish our query side, but eventually we need also to implement the read service and the repository that will be built on top of our SQL connection. Of course, within our infrastructure layer, we also need to provide the implementation for our weather service. And at the very, very end, we'll also tackle, I would say, more cross-cutting concepts like error handling, because so far we are throwing our custom exceptions, but we don't actually handle them quite nicely. So this will be also the infrastructure responsibility, along with maybe some sort of additional logging. I would also like to show you how you can add more, I would say, cross-cutting concern flavor to our handlers without actually changing the implementation of them on the application level. So, but yeah, first things first, let's start with the infrastructure and the ORM configuration. So within the infrastructure, we need two packages. So first will be, of course, our EF core. So I will add this with version 5.0.11. So install, okay. And the second one would be the efcore.postgres SQL, but that will be right either the entity framework core. Okay, so this one. So 5010. All right. So once we have it, I will add the new directory called queries just to move it already. So this goes from application to our handlers. I can, of course, now change the namespace to packet infrastructure. So as I mentioned, queries on the application will be just the definition for the contract, and the implementation of the handler will remain within the infrastructure layer. So that would be it. Now I would like to already define the extensions, just like we've done on the application level. So let's just make this static and just copy paste the code to avoid any issues. So within our infrastructure, instead of calling add commands, we already know that we'll call actually add queries, because eventually underneath we are getting this calling assembly for the scanning purposes. So this is crucial for the implementation. And now I can call this add infrastructure from our entry point, which of course is here. So maybe in here I will do services dot add infrastructure. Okay. So this is already wired up, and we can start focusing on our ORM. So for this purpose, I will create a directory called EF, so entity framework, but you can call it whatever you want. So now a few things needs to be created before we actually implement our query handlers. Of course, at this point, we need DbContexts that comes from entity framework core. But as I mentioned earlier, it would be cool to have the clear separation between the reads and the writes. And it doesn't mean that I only want to have this separation on the handler level. So in here, like I have the everything related to my writes, and in here I will have everything related to my reads. The issue with, let's say, one generic DbContext that will be used for both writes and reads. The issue is that if for the database representation we would use this model, so the packing list, I mean, for the EF core, it's no big deal. We just need to provide a parameterless constructor, which could be implemented as a private. So I could, I think, already do this. So private packing list. This is parameterless, and yeah, that would be the only thing required for the EF core to actually use this representation also for the database. But the more, I would say, serious issue is once we would tackle the searching, because if I want to make the search based on this phrase in here, at some point I would like to create the predicate, and now the predicate cannot be defined as an expression func within my EF core, because everything in here is hermetic and hidden behind the private fields. So EF core provides you this capability of shadow properties, and you basically can create still the query for your SQL based on the strings. So let's say that I would like to search the packing list by name, so I could basically put this name into the string, and yeah, at some point the driver for my SQL would construct the proper handler that would return me the proper result. But writing the query on top of the strings when the EF has quite good capabilities of this compile time validation on the expression level, is something that, yeah, I would like to use actually. I don't want to rely on the strings. Not only because it's not as pretty as the expression, but it's more like error prone, I think. So the idea is very simple. We underneath on the database level, we will have just one relation that would get this information about each individual packing list. Of course, we'll have another relation that would represent the packing items, etc. But we'll build two different DbContexts on top of that. So first, we'll basically treat packing list as our database model, and this will be used only for the write purposes, since the only public the only public property, which is the identifier, is sufficient for our repository, right? So the repository only requires ID for the searching, while everything related to read will have its own representation on the EF level, which basically be pointing to the same table, but the representation will be completely anemic. So there will be public getters, public setters, no methods, no behavior, because it's more related to the database. And thanks to this, we, within our queries, actually query handlers, we will have this freedom of creating any predicate that we would like to. All right, so just to make this clear, one database underneath, one table, but two different DbContexts pointing to the same table. And that should be just fine. So to make it happen, I think that we can start with the with this read models. This is how I want to call them. And we'll proceed further with the definition for our contexts. And of course, at some point, we also need to provide the configuration. So first, directory called models, and these models will contain definition for 3 different read models. So just like we've done with the, maybe actually, I think that I can just copy paste this, because this is pretty much, most of the stuff will be quite similar. So instead of doing calling this DTO, I will call this read model. Okay, and I can already, I think, change it to the proper namespace. Okay, so for the localization, that will be something like this. For the packing item, I will just change the name, packing item read model. Now, here is something that I need to point out. For the packing item, the packing item itself is relation one-to-many, right? So packing list contains multiple packing items. So this is relation one-to-many. And this means that each of them will have its own table underneath. The implication of this is that we need some sort of primary key that will be used for our packing items, because we had this assumption that the packing name itself only contains name, quantity, and this simple flag that will inform whether we've packed already something or not. But we need some sort of primary key, just like with the packing list. So for this purpose, I will just add the ID. And this is also another, I would say, good implication of this separation, because I'm not forced to put artificial identifier to something, to my domain, if I don't need it, right? On the domain, I still have just 3 properties, while in here for the reading purposes, this is some sort of limitation of my mental model of this representation, that I'm using relational data model. So by the convention, I will just need this. But since this is the read side, I can do whatever I want, and this does not impact directly my domain. And also, because I'm using EF core, I can add some sort of navigation property. So maybe I will just point that this item belongs to packing list read model, which I need to first name properly. So read model. And now I can use it in here. Just like that. Okay. So now this is the representation for my read side. Within the list, I don't think I need any further changes rather than putting this as a I collection. So I collection of T. I can also could think about some, maybe adding some sort of versioning if I would like to. So version, because my representation for the aggregate contains this. Just to remind you, so aggregate root contains this version property, and of course version is was something that I didn't put into the DTO on the transportation layer, but for the persistence is something that I would probably appreciate, because I could create a concurrency token on top of this property. So identifier version name localization, of course, now needs to be changed to localization read model, and list of our items should be just fine. And that's first step. Now, second step, we could focus on defining our DbContexts. So another directory, contexts. Okay, let's start maybe with the read. So read DbContexts. Okay. So in here, I will make this internal. Actually, you know, I think that we could also make everything in here also internal, just to ensure that this will stays within this particular layer. So a ReadDbContext will derive from the original DbContexts provided by Microsoft Entity Framework Core package. And in here, I will define only one DB set. So the DB set in here will point to our read model representation. So packing list, read model representation, packing lists would be the name and get set for our property. Now the constructor, which actually should look slightly different because that's rather DbContext options of T, where T is our ReadDbContext. Okay, so options, and we want to call base options. This is not needed, and I will already create protected override on model creating. So once I will add the configuration for my DbContext, this needs to be called right in here, but I can already do one thing. So model builder dot has default schema, and this schema will be called, let's say, packing. Okay, now let's do the same for the write. So write DbContexts. Actually, I think I can pretty much copy this. So this also needs to be internal, sealed. Okay, and in here the DB set will be of type packing list. So as I mentioned, the EF core, as long as you provide him a clear instruction of how each type should be represented on the database level, it doesn't care whether your model is anemic or whether it's kinda it encapsulates the properties. I mean, in this case, it's the only thing that needs to be provided is the parameterless constructor. So this is why I had to explicitly define this within my aggregate. In here, since I don't have any explicit constructor, I have this default parameterless constructor provided. So no need for explicit declaration. Okay, we have the both read and write contexts. Of course, just keep in mind that the schema will be exactly the same. There's no need to make this logical separation because underneath I just want one table and one representation for my reads and writes contexts. So now quite important stuff, which would be configuring, because while in many cases like this, we are using the primitive types, it's like no-brainer for the EF core to make the assumption that, okay, this will be like the number, this will be n var chars of some sort of capacity, etc. However, once we go to our right side, yeah, in here everything is put into nice, from the domain perspective, nice value objects, but EF core would have an issue with defining, okay, so to what type I should actually cast this and store within our database. So we need to provide this sort of explicit configuration, which will help proceed this conversion through one type to another. So from our domain to persistence, and from the persistence to the domain once we will get the data from the database. So to do this, I will add another directory called config. So config, and as you probably expect, we'll have two different configs for two different DbContexts. So I think that we can start with the read, because this will be way simpler. So read configuration. And this configuration will be basically, once again, internal sealed class. So internal sealed class read configuration, which will implement entity type configuration of T, and this T will be packing list read model. So this is first, and I will put this into same class, so packing item read model. Okay, so I should end up with two different configure methods. First is for our packing list, second one is for the packing item. So let's start with the packing list read model. First, I want to say that I would like to create a table with the specific name for my packing lists, and this will be called basically packing lists. Of course, if I don't put this in here, the EF will come up with some sort of default naming convention, but if you want to override this, you can just use this particular method. And I would like to explicitly say that my packing list has key, and this key is ID. Okay, now another issue is this localization read model. So maybe within my table, I don't want to create another relation that would be containing our localizations. I would rather want to store this localization in one field, in one column in my table as a just string. So I will create very simple conversion from the localization read model to the string and vice versa. So for this purpose, I will just type builder.property, and I want to point specific property in my read model, which in this case will be localization. And then I will just call method has conversion. And in here you need to provide the conversion. So first is, as you can see, convert, that would be which one? Convert to provider, there should be something like this probably. Yeah, in here. So convert to provider expression, which basically means that how would you like to store your data on the SQL level. So for us, I would like to just store localization as, let's say, country and then city, separated with some character. So for this purpose, I would probably need to add in our localization read model some sort of simple, maybe toString method overload that would gives me this information. So I could basically do public override toString, and let's just come with some sort of representation. I'll just return maybe city and country, something like this. And we can already think about conversion from the string to localization read model. So I will just add public static localization read model create. So create, and this will accept the string as the value. And yeah, first we need to split this. So split localization equals value.split, and we'll use specific character. Oh, sorry, need to put this into as a char, and I would do return new, and then localization read model with city being split first and country being split localization dot last. So something like this, very simple conversion from string to localization read model. Now I can just use it within my conversion setup. So in here I'm setting that L on the database should be basically stored as a string, and once I will have the fetch process, then string should be created using this create method. Okay? And at the very last step, I would like to explicitly define the relation between our packing list and packing item. So I want to say that has many. So our packing list has many PL goes to PL items. I will have many items with one, and then packing item goes to packing item goes to this. And that's pretty much it when it comes to this configure method. And in the second one, since there is no conversion needed, the only thing I need to provide is builder dot to table, and I will call this packing items. Okay, cool. Now, just not to maybe forget, we can already wire this to our model creation. So I will do the following: var configuration equals new read configuration. Okay, and then model builder dot apply configuration for packing list read model. That will be the configuration, and the same goes for the packing item. Okay, so packing item read model, and that's pretty much it. I can omit this code in here. Okay, so now let's jump into configuration once again and create the one for the write. So write configuration, yeah, this will be slightly more, I would say, advanced, because we basically have quite a lot of value objects which needs to be represented on the database level somehow. So internal sealed, and our write configuration is once again identity type configuration of T, where T is in this case packing list, and the same goes for packing item. Okay, this one, let's just once again implement two configure methods, and let's start with the first one. So once again I will say that builder dot has key, so PL dot identifier. Okay, this is my primary key. Now I need to create the conversion for actually for two things. For if you jump back to our domain, I need to conversion for this, so packing list name, and also for the localization, because these are two properties that I've got on my aggregate. So for this purpose, we need to create the conversion. So in this case, I will create separate converter. So let's start with the localization first. So localization converter equals, and now we have this class that comes from the EF core. So this is not something that I've created. So value converter. So converter of tmodel tprovider. So in our case, tmodel is basically localization, and we want to represent this once again as a string. And of course, we just need to keep in mind that both conversions, when it comes to localization, needs to match, because both contexts will point to the same table. So this is why in the value objects, localization is represented as city and then country, and not the other way around. And the same needs to be applied also for our localization read model. It just needs to match, because otherwise we would have some sort of weird anomaly once we will try to read the data either from this context or from this context. So in this case, I want to create the conversion. So once again, once I will try to convert the localization to string, I will just call overloaded to string. And once I would like to do the other way around, I will call localization.create passing the value. Second one would be packing list name. So packing list name converter equals new value converter. And in this case, we'll have packing list name, which will be represented, of course, as a string in our database. So pln goes to pln.value, that's the representation in the database, and pln.new, and here will be new and pln. Okay, so packing list name does not have any sort of static factory or something. We just have the constructor and this value. So this is how we want to make this conversion from one type to another on the EF level. Okay, now let's add the conversion for each of the properties that we have. So let's start maybe with builder dot property pl.id. Of course, our identifier is also wrapped into value object. Thus, we need to provide the conversion for this. So in this case, once again, id dot value, and id goes to new packing list identifier passing id. Okay, that's first one. Second conversion. This conversion is slightly different. So builder dot, and of course I can do something like property, and property, let's say localization, and that's because I don't have the access to my localization, right? This is rather private field. So in here I need to do slightly different thing. So I need to specify the type of my property and its name. So the type of my localization is type of localization, and the name is underscore name. Localization. Okay. Now I need to provide conversion. So has conversion, and yeah, and this accepts the value converter, and this is why those two needs to be extracted, because this overload does not allows me to do this directly as some sort of expressions for this has conversion method. So localization is passed in here, and I will just tell explicitly that this actually has column name called name. Okay, I'm not quite sure why I keep saying name, because name is the second one. I'm always looking at the okay. So localization with the capital L and no underscore. I don't want to have this. And of course, this is just I need to force my ORM to have the same column names for both writes and the read DbContext. Of course, for the read, I didn't have to put this has column name method, because my because my packing list read model defines this in a perfectly fine way. Okay, let's just jump back to our configuration and do exactly the same thing for our name. So in this case, property type of and packing list name. Of course, you already know that we need to put the name, then has conversion. We are passing our packing list name converter, and has column name. In this case, it's gonna be name. Okay. And at the very end, I would like to explicitly say that our packing list has many, and has many what? Has many packing items. But once again, this is hidden behind the private fields. So I would like to do the following: packing item, and the name of my collection is just items. And this should go to table called packing list. Okay. Of course, you could think about extracting this to some sort of constant strings just to make sure that both this and this is exactly the same. It would make much more sense than my implementation, but yeah, let's just speed it up a little bit and see the actual result rather than refactoring this already. For the packing item, this will be rather straightforward because we need to provide the information for our packing item that this actually contains an identifier. So as I mentioned, for the reading, it's straightforward. We just added this representation because we'll use it internally within the infrastructure. But for our domain, we don't want to add this identifier. So we are using the shadow properties capability of EF, which allows us to add the properties on the ORM level without changing the implementation of the model. So in this case, I just want to say that I will add this shadow property of type GUID, and this will be called ID, so our identifier. And I will also do the following. So builder dot property pi goes to pi dot name. And I will also point the rest, so quantity and is packed. In this case, of course, I've got the access to my properties because it's value object. And at the very end, I'll do builder to table. And once again, this needs to be exactly the same because we are pointing to the same table. Okay. So now it's once again just the matter of applying this configuration to our DbContext. So maybe I'll just copy paste this. Okay. So this one will be rather write configuration. And I need to import this, and configuration will go for the packing list and for the packing item. Yeah, and that's pretty much it. Okay, now since we already have our two DbContexts, I think that this could be a good point to generate the migration because we'll need to generate it. And yeah, we could see what actually is being produced by our migration. And I think that later we can proceed with the implementation of our query handlers and the repositories. At this point, I would like to register my two DbContexts into dependency injection container. So of course, to create the DbContext itself, I will need some sort of connection string to my database. And we may probably expect that we would like to avoid a situation in which this connection string is somehow, I would say, hard-coded into our application. It makes no sense because every single time we would like to, let's say, change environment, we'll need to recompile the whole code. So of course, for this purpose, we have our app settings that are part of our ASP.NET Core application. So in this case, our presentation layer. And yeah, app settings are just the best option for us to store such settings. And of course, the beauty about this approach is that we can override this on the fly, let's say, during build process. So within our app settings, I will define the section called Postgres. And in here, I will have one property called connection string. So connection string, and the connection string goes like host equals, in our case, localhost, localhost. Okay, database name, so database equals maybe packet, then username. We'll define the default user as a Postgres, and the password is null. We don't have any. Okay, now of course it's now the matter of getting these settings, this connection string somehow, and ideally would like to put this into some sort of C# representation. And of course, ASP.NET Core has this capability and this concept of I options. The reason I mean the I options itself is a great feature, especially that if you would like to maybe do some sort of hot swapping during the runtime, it provides you some sort of capabilities of, let's say, doing the snapshotting of your options. But if you're ensured that this will not change over the time, the thing I don't like about the I options is that this actually wrap the object, this C# representation, into another generic concept. So this I options of T, and it just doesn't look that pretty. So if you would like to have just this C# representation without additional wrapper, we can quite easily achieve that. So maybe let's start with this representation of our Postgres settings for within our infrastructure, and we'll see to what this will lead us. So in here, I will define options, and actually we could either leave it as it is, or I could even move it to my EF. So this will be only EF specific option. So within the options, I will create class called Postgres options. And I obviously got an issue with typing Postgres and typing in general. So Postgres options, public string connection string. Okay. And I would like somehow to bind this app settings section to my C# object. So for this purpose, I will jump back to our shared, because shared seems like a good place to put such a code responsible for wiring our settings. So within shared, let me just to create a directory called options. So once again, I would like to stick to some sort of naming convention, so it will be just much easier. And within the options, I will create the method called extensions. And that will be, of course, static, as you know. And the code is the following: public static, then T options, and then get options of our T options. Okay. And this needs to be invoked on I configuration. So I configuration needs to come from somewhere. So as you can see, Microsoft Extensions Configuration Abstractions is the place in which I will have then access to my configuration. So let me just install it. And of course, it's once again, if you want to have, because this is like the abstraction, so this abstraction could be easily moved to shared.abstractions, but if I don't need to use it within my abstractions, then to me it makes no difference, frankly speaking. So this configuration, and the second parameter is the name of the section. So section name. What I mean by the section name is, let's say, in this case, Postgres. So I will just use it for getting a particular section from the app settings and putting this into C# object representation. I can add the generic constraint, which will be actually required. So our T options need to define parameterless constructor. And then we'll do the following. So var options equals new T options. And then configuration.get section, passing our section name, and then bind, and then our options. Okay, and yeah, that's a quite common issue when it comes to this bind method. We need, unfortunately, to wire one more dependency, so that would be either dependency injection, sorry, not this one, configuration dot binder. Okay, and now this bind should be just resolved. Okay, so once we have the bind method working, we can do return options. And now our extension method is completed, so we can use it. So let's just get back to our infrastructure, and somewhere in here I could do var Postgres options equals, and then I need to get my I configuration. Now, of course, at this point there are few ways to tackle this, and yeah, it could be very tempting to do the following. So I could do like var, actually using var like service provider equals, and then services dot build service provider, and this service provider would be used for doing get like service or required service, doesn't really matter, of I configuration. However, I would not recommend this approach. I know that you probably could see this a few times within our DevMentors series, either in the D shop or maybe in other materials. I personally would like to avoid this because build service provider, basically, as the name says, builds you the container. And yeah, there are a few pitfalls when, if you would call this build service provider multiple times, there might be weird anomalies related to your objects. It's even possible to have the singleton with more than one instance. So instead of doing this build service provider explicitly in here, I will just pass my I configuration, and that should not bother me that much. So configuration will be passed to my add infrastructure. Of course, now I need to change the implementation, but if you would go to startup CS, you could see that, yeah, actually I've got this I configuration as my startup dependency. So it's just a matter of passing this configuration here, nothing more. And it's just much safer in terms of the general management of your object lifecycle. So Postgres options is nothing more but configuration.get options. Now we can specify that we want to construct the Postgres options, and the section name for us, yeah, the section name is pretty much the Postgres. Okay. Now at this point, maybe we should also consider extracting everything related to the Postgres to the separated extension, because the infrastructure might have different data storage configuration. That there might be also something related to maybe more some other parts of the infrastructure, like some sort of cross-cutting concerns. So this add infrastructure method could grow quite significantly over the time. So in this particular case, I would personally recommend doing another extensions, but this time on top of the EF. So if we basically collapse this, you could see that this extension is only valid for our EF, but we also have the global extensions for the whole layer, like the infrastructure. So I can make this internal in this case. So internal static extensions, and in here I could create like public static iService collection, maybe add Postgres. So Postgres, I've got the issue with this name. It's really hard for me to type, I don't know why. iService collection. So services, and of course I need to pass my iConfiguration. So configuration. Okay, return services. Now I can just grab the code from the extensions in here, and to me this will look way better. So services that add Postgres can be already called, passing the configuration. I can remove it in here, and now my extensions will be like this. I can even now, I know that this will be about the Postgres, so I don't mind to simplify the name. Okay. So now it's just a matter of registering finally. So services.add DbContext. And first let's start with the read. So read DbContext is in here, and I need to specify, of course, the connection string. So that will be like context and goes to context use npg-sql, and passing my options.connection string, boom, and maybe let's just put this in the separate line, and same goes to my right. So as you can see, this will, both contexts will point to exactly same database, and yeah, that should do the trick. All right, so for now, this is pretty much all I wanted to do in terms of the overall registration. And now we can move finally to our handlers and implement both of them. And eventually we need to focus also on providing the remaining implementations for the abstractions that we defined either in the domain or in the application. So let's start with our handlers, and there's an error in here. Okay, probably for some reason this got changed. Or no? Okay, this uses read model and should be clearly DTO. Probably once I have done the copy paste and the renaming, this got changed. So this should be, of course, DTO. Okay. So this one should be rather simple, right? Because we only look for the specific packing list using the identifier. So the way we are going to implement is the following. So private read only, and then db set of packing list read model. So that will be like, you can call this packing lists, whatever, and this will be slightly different. So ReadDbContext, this is crucial that we want to use this one. So DbContext, context, and assignment will be like packing list equals context dot packing lists. And why is that complaining? Okay, of course I need to make this internal. Okay, now in here I can actually make this even not asynchronous. I will just pass the task to the caller. So the implementation will be as following: packing list, and then I want to make sure that I will include not only the packing list, because in here we'll have the eager loading. So we need to explicitly load for the result, for the end result, also our packing items. So I want to explicitly say that besides my packing list, I would like also to load items. Okay, now the predicate. So the predicate is like pl.id equals query.identifier. Okay, now I would like to do the select, and in here I could either do new dot and now packing list DTO, or knowing that I will probably use this conversion also in the search packing list handler, I could extract this, right? So this is just the, I would say, matter of whether you will reuse this or no. In my case, I know that at some point I will use it projection in a different place, so yeah, I don't mind doing this extraction. So under the queries, I will do, who would guess, extensions. So extensions, or we could put this into like some sort of mapping or whatever you will call it. So internal static class extensions, and the conversion goes like public static packing list DTO as DTO this, oh shit, packing list read model. So read model is the one, and in here let's just assign this manually. Of course, at this point someone may say, okay, why you're not using something more robust like the automapper or something. The reason is that, of course, in this case, I mean, the conversion from one model to another for the automapper is no brainer, but I cannot use it directly within my EF query in here, because this needs to be translated to the SQL somehow. So plain C# will work just fine, assuming that I will not do anything beyond the capabilities of the EF core. But using the automapper will just not work. You need to first get the result as a read model and then use the automapper for the mapping between the read model and the DTO. So it's your call. To me, I don't really care which one will you pick. Both are, I think, fine. Okay, so localization dot country. Okay, and items, and in this case, read model that items. And of course, at this point, I should maybe probably also provide. Oh, and here something is not right. What is the issue? Let me just check. I have no clue. So localization DTO is fine. Cannot convert from localization DTO to wait, what I'm actually using in here. Oh, yeah, that's the issue. So localization DTO is of course something that I would like to use. Okay, so now this issue is gone. And of course, this is just the matter of whether this is required or not. I could think about some sort of null checks here and there, maybe also in here. For now, I will not dive into. I honestly, at that point, I don't even remember whether we required this or not. So, yeah. Okay, so packing item DTO and name. And one thing which is, I wouldn't say it's like crucial, but just keep in mind that, of course, in here I also have this identifier, but the identifier was only to, make my ORM and my database happy, but I'll probably omit this completely when it comes to the transportation layer. So this will be more or less the implementation, so SGTO. And now I can get back to my code and do the following. So pl.sDTO. So at this point, I'm almost done. Thing I need to also provide is as-no tracking. So since this is only for the read purposes, and this is once again another reason why this separation between reads and writes is crucial, because the EF itself is quite powerful when it comes to change detection, and you have this change tracker which basically sees what properties has been changed over your let's say HTTP request. And of course for the reading data, I don't want to enable this tracking. It's completely, I don't need this, because I immediately I'm returning this into the caller, which will be probably some sort of, you know, UI application, and this tracking is basically not needed for me. While for the, let's say, this purpose, like getting the packing list by the ID, for me this tracking would be crucial, because maybe at some point I will add new item or change the name of my list, and this needs to be tracked by the EF core. Once I will call the update async and underneath implementation will call the database, the tracker needs to know what actually has been changed. So this also is a good I would say division between what needs to be tracked when it comes to getting, so only this get async needs to be tracked, and everything related to the query side. I want to disable this. I don't need this tracking at all. So as no tracking, and then single or default async, because I only expect one. And that's it when it comes to this particular implementation. Now let's just jump back to this search. I will copy paste this. It'll be much faster anyway. Okay. And in here I have exactly the same issue, so DTO. Okay. And this also, of course, needs to be internal. Okay, so the implementation for the handle async will be slightly more, I would say slightly more advanced. And that is because we have this assumption that if the search phrase is basically null, because it could be null, right? Then we'll just give you every single list that we have within the database. Otherwise, if you provided the search phrase, will perform will create some sort of predicate, maybe built on the name. So we'll just have this assumption that this actually search phrase only is for the searching by the name. Of course, once again, just the matter of defining the particular requirements. So I cannot make this in like this cool function way. This will require slightly more effort, but not too much. So let's start with defining the queryable. So dbQuery will be our packing list dot, and then include. Once again, I need to include my items. So PL goes to PL.items. I need to remember about this. And then as queryable. Okay, and slightly more structured way. Okay, then let's just check. So check if query search phrase is not null. So if this is not null, I need to add some additional filtering. So dbQuery equals dbQuery.where, and this where goes to PL, and then I need to check whether this contains the particular search phrase. So of course it could be tempting to do the following: pl.name.contains, and then query.search phrase. However, the issue is that for the EF core, the EF core don't know what to do with the contains, how the contains work. I mean, you just need to remember that everything within the query needs to be an expression, right? It's the expression of func, and that's because we need this underneath tree-like data structure to go through every single leaf, and based on that, create the SQL query for our Postgres. So we would go through this particular expression, and we would find out this contains. Now, how this contains works, so what does this particular mean, and what's the SQL, like T-SQL representation for our contains method. So For these purposes, the EF comes with some sort of built-in helper methods, especially for that cases. So in our case, we would rather call Microsoft Entity Framework core.ef.functions. And these functions are basically, as you can see, there are plenty of them, like less than, same like, is like, etc. So I will call method called I-like, so this one. So in this case, why this is not regular like but I-like is that this I-like method will basically don't care about the casing. So I don't care about the casing, etc. It's just invariant. So pl.name, and the pattern that I want to provide will be put within the it actually could be like query.search phrase. Okay. Now if this will be search phrase passed like this means that underneath on the SQL database, the query should be like where name like search phrase, which means basically that the name needs to be exactly like the search phrase. So there can be anything before and after this phrase. So if you would like to have this more flexible, you can do something like percent and then put our phrase if you want, percent and finish. So this means that there could be anything before and after our phrase. So this will be more like the regular string.contains method. So maybe I will just leave it as this implementation. So if our search phrase is not null, we basically perform this, let's say, contains with the culture invariant underneath, because we are using this I-like method. And now we can return the result, which should be now rather straightforward. So return, in this case, await, so async. But this actually doesn't need to be, could be also, maybe we can change this also to, yeah, not to await this at this point, but we would rather do db query.select. Once again, pl goes to pl. We already have the sdto, and then s no tracking, and then to list async. Okay. So this, okay. I was too optimistic. I forgot that in here we've got the IEnumerable of packing list DTO, and yeah, in this particular case there is no conversion on the task, and basically it's not covariant. So unfortunately, because we have the generic collection, I need to do this in this matter, because now I have this conversion from toList to IEnumerable, and it's not basically invariant in this case. Okay, so we have both queries implemented. That's just great. And now I think that we can finish the, I would say, the implementation also for the right side, so for our repository. And yeah, we are getting closer. So query is done. Now let's just jump back to the repositories. Let me just, actually, when I think about this, since this is built on top of the EF, it would be more sufficient to put this into under EF catalog. It would look just way better, because we're building this on top of EF anyway. So like this. Now I will add another directory called repository, repositories, plural. Okay, so let's just maybe stick to this Postgres. So Postgres packing list repository. And of course this will be once again internal, sealed, and this will implement our contract from the domain. So packing list repository. Okay, we have 4 methods that needs to be implemented. So in here I will add two private fields. So first is dbSet. Now keep in mind that in this point we need to use the packing list, not the packing list read model, because this will be strictly for the right side of our application, for the command execution. So packing lists, and the second one is private read-only write DbContext. So write DbContext. Okay. Actually, that's not what I wanted to do. So that will be rather write DbContext.packing lists. Okay. And yeah, let's just implement this. So get async will be nothing more but the public list now include. And now it gets interesting because we would like to include the items, but on our right side, this packing list is actually private field. So of course, this is what I mentioned, that this, if you would stick to just one DbContext and one representation, every single, including, or every single predicate or even projection would need to be built on top of the strings. So at that point, I think that Dapper would be more sufficient, also when it comes to the performance. So in this case, I need to include like string items, and then once I have it, I need to, of course, do the where. So where dot pl, goes to pl id, or I could even be better with this. I will do single or default async, and yeah, just omit the where. So pl id equals id. All right, and once again, keep in mind, I'm not adding as no tracking in here, because I will need the tracking feature for getting my aggregate, manipulating, and maybe changing its state, and then detecting the changes, let's say in the either update or delete async. So this is the first method. Now the add async will be rather straightforward. In here I will need to make this as an async. So await packing list dot add async packing list, and we need to commit this to this way. Okay, and then we have the update, which is slightly different because we have update which is not async, and for the delete is also quite similar. So async and remove first, and save changes async. Believe or not, that's all we have to do. And of course we need to remember about registering. So somewhere in here I will do services that add scoped, and then I packing list repository. So Postgres packing list repository is the actual implementation underneath. Okay. And what else? Maybe let's at this point also cover the weather service. So as you remember, within our application, which is here, we have this weather service. Oh, and we also have the read service. So read service will be more related to the topic of the ORM first. So this one is also something that I forgot about. So yeah, under the EF, I will create another directory called services. So services, and we'll just grab this name and add Postgres. Okay, so internal sealed, and this will implement packing list rate service. Okay, and yeah, as you probably expect, this will be rather simple, and in this case I will also use the dbSet, which is pointing to our packing list read model, because I want to create simple predicate based on the property that otherwise would be hidden. So actually this is wrong. This will be rather ReadDbContext context.packing lists, and in here the implementation is packing lists any async pl goes to pl.name equals name, and equals works for the EF core. In this case, I don't need to make this like function. Okay, of course I need to once again register it. So services at scoped, and now I packing list read service and Postgres packing list read service. It's done, and the remaining implementation, what I mentioned, was this weather service. Of course, ideally this should call some sort of external API, but you probably know the HTTP client stuff, and I don't want to make this even longer because it's already like ridiculously long course. So I will just create some sort of dummy implementation, but of course ideally this should call some sort of API for this purpose. So actually this should be plural, so services, and the implementation for my weather service would be, I'll maybe call this dump weather service, just to make sure that this is not production ready. And actually that doesn't need to. I mean, when I'm doing like POC, maybe I don't want to bother myself with this integration. Eventually I could add this, but for now maybe I don't care. And that's to me fine. So weather DTO will give me the temperature, of course. So maybe let's make this a little bit more random. So new random dot next, and let's say that we'll get something from the range 5 to 30. So the reason for that is just that this will give me different policy execution depending on the result. So as you remember, we have two different policies depending on the temperature. One is for the temperatures above 25 degrees of Celsius, and the second one is for this. So yeah, depending on the result, which is now non-deterministic, we might have different policy execution. So now it's just the matter of course, registering it. So somewhere in here, I could do something like services dot add singleton, because I only have like this naive implementation, weather service, and this dump weather service. Okay, we are pretty much done with this. And yeah, the beauty about this approach is, as I mentioned and repeated myself like many times, but I want to make this clear. We eventually, during last 30 minutes, added this persistence. And yeah, this actually wasn't stopping us from creating what is actually crucial for our application. So this domain and the application layer. Yeah, I mean, now of course the database is quite important when it comes to the overall execution of our application, but maybe at some point, I'm not quite sure whether I will use the EAF or relational database in general. So I could create like dummy implementation for my repository, read service, and anything else, just like I've done for the weather service. And I could go and create like nice presentation with my POC how this would work, implement this in memory fashion, and eventually swap it to, let's say, EF core. So to me, it's a good thing to have it. All right, I think that at this point since the whole project is more or less building, probably we can check it. So this should compile just fine. And at this point, the only thing related to EF which is missing is of course the migration. So migration needs to be generated and scaffolded and put somewhere within our infrastructure code. So just once we start the application, this will lead us to the database generation. And eventually, of course, if you would like to change something within the model, you need to scaffold new migration, which would update the schema on the database level. So we need to, of course, generate this first migration. So I'm in the my repository. So I even got into the packet.infrastructure. That's crucial. I need to go to packet infrastructure. And yeah, if I would like to now do the following, so .NET scaffold this whole execution. So .NET EF migrations. So this is the part of the global tools. So if you don't have it, just type .NET global tools EF, and this will this should install you this entity framework global tool for your .NET CLI. So then you have the .NET EF and then migrations. You want to add new. This is the name. So I will just call this init read. And then I need to point on which DbContext I would like to execute it. So for us, since both contexts will point to the same table, there's no need to scaffold this twice for read and for the write. This is just a matter of executing this once, and the reads basically should work just fine, assuming that we keep both of the models like identical in terms of data types and the names. And then I need to point the startup project. So in our case, this is the Packet API. This is the startup project because this is actually the project that has the entry point to our application. And the output for my migrations should be EF/migrations. So when I type enter, as you can see, the build is started, and this is what I told you, the build itself needs to pass in order to create the migrations. However, we can see that the Packet App API doesn't reference Microsoft Entity Framework Core Design. And we need to reference this to our entry point in order to make it work. So this is something that, yeah, you might like or not, because within my API, which is responsible for this, for handling like HTTP request, what I need to put anything related to my ORM. Well, you cannot overcome this quite easily, I would say. So it's just some sort of convention that you need to follow, and you cannot do much about it. So in this case, I will just reference this core design into our API, since this is my entry point to application. I'll just install it. And once it's done, let's just jump back to our execution and see what will be the result. Hopefully this will be done, and it is actually. So I've got the warning that I'm using also my entity framework tool is slightly off the version, so I'm using 5.0.10. So assuming that you haven't got the entity framework tool before, you should not have this warning. So let me just go to infrastructure, and yeah, indeed we have EF migrations, and we have the first migration being generated. So we can have the information like we'll have the table called packing lists, and we'll have like 4 columns. So ID, version, name, localization. We'll also have another table called packing items, and in here we'll have identifier of my items. So this is like this shadow property that we created. Name, quantity is packed, and of course foreign key to my packing list table. So some other stuff like the foreign key definition, like the default indexes, etc. So now, once I will actually run my application, I would expect that, yeah, this actually gets called somehow by the EF core, and the database should be created. So let's just give it a try and see the result. I've got Postgres running on Docker. So if I'll type docker ps, you can see that I've got Postgres indeed, and it's running on the default port, which is 5432. And I also have the data grip configured with this Postgres connection. And yeah, for now, if I will refresh this, I only have like this default database, and I don't have this package database created. So let's see what will happen once I will just hit run. Of course, now my application is being wired up at some point. Yeah, it's running at this port 5000, and let's just get back to our data grip and refresh. And actually there are no databases being created. There's nothing between besides my default Postgres database. And the reason for that is quite simple. We need to call the method on our DbContext, which is called migrate async, in order to actually apply the migration that we have scaffolded in here. And yeah, since now we are missing this this migrate async method within our code, we cannot create the database based on this code in here. The alternative approach is to do this via the CLI, but I would rather want to keep this migrate async somewhere within our code. So I will do a very simple thing. We'll just make the usage of one of the ASP.NET Core capabilities, so hosted service, which basically gets us two lifecycle hooks, start async and stop async. And on the start async, which is invoked once the application is, as the name says, starting, I would like to scan the assemblies, find every DbContext that we have defined within our, let's say, infrastructure, and just manually call migrate async on it. So for this purpose, somewhere in the shard, I will just create a catalog called services. Of course, this could be like the question whether this should belong to infrastructure or to shard. I mean, this could be, I think, quite fairly put also in the infrastructure, but yeah, I would like to just distinguish some possible shared concepts along from the infrastructure. But yeah, in our case, most of the code that we have in here could be also defined somewhere in the infrastructure, and that should not bother us that much. Okay, so within the shard, we need the EF packages probably. So I will just put them into the shard, and this of course means that once we'll reference the shard within the infrastructure, we could get rid of the entity framework core and the Postgres. But for now, there's no direct reference from the infrastructure to the shard packages. Okay, so assuming that we have it now, I will just create a very simple class called app_initializer. And this class will be internal, and we'll implement iHosted service. And this iHosted service, of course, needs to come from some sort of Nugget package. So as you can see, Microsoft extensions hosting abstractions. Once I have it, I can implement the start async and stop async lifecycle hooks. So when it comes to the stop, so this will be called during the graceful shutdown of our application. In this case, I don't really care about that much, so I'll just return task.completed task. In this case, I will need first my service provider to have this capability of resolving some sort of DbContext from my container. So I'll create private field iService service provider. Okay, so service provider, and in here what I'm gonna do is the following. So first I would like to create the list of my DbContext types. So I will just type DbContext types. And now I need to scan the particular assemblies. So this could be either like app domain, current domain, or maybe something more specific. But yeah, let's just do app domain, current domain, get assemblies, and then I need to do select many, and then A goes to a get types. So get types. Okay, so this will give me IEnumerable of types, and of course now I need a predicate to filter the one that I'm actually interested in. So a dot, actually this will be other way around, so type of DbContext assignable from A, and I also want the A not to be an interface. So interface A, this actually is assembly, this is type. Okay, so type of DbContext is assignable from A, and then okay, A is interface. Not quite sure why this actually is not working. A, okay, select many is the one that I was looking for, so I need this to be flattened. So is interface, and I want A not to be the DbContext itself, but rather the concrete type. Okay. Now this will give me, should give us in our case our two DbContexts that I have. Now I can create the scope. So using var scope equals service provider, and then create scope. And now I can create a for each loop. So for each, and then DbContext types, and in here DbContext type. And I can resolve now the DbContext. So scope.serviceProvider.get required service, and this will be non-generic version, so DbContext type, and I can safely cast this to DbContext. And if this is null, which should not happen basically, I can just do continue, or maybe I could throw an exception that would prevent me from doing some stupid things, but yeah, at this point I think it's just fair to do the continue and await DbContext.database, and now I can do migrate async, can pass our cancellation token, and that should be pretty much it. Now of course it's just a matter of calling our actually not calling, but adding our hosted service to our application. So at this point I think I will create like extensions in here also. So we'll make this static. Let me just grab some method already to prevent me from doing some stupid mistakes. So add shirt, this is the name of the method. I don't think I will need the configuration here. Okay, and within the shirt I will just do services dot add hosted service, and this hosted service is of type app initializer. Okay, and let's just grab it and call somewhere in here. So services.add shirt. And yeah, now once we will actually start our application, we can actually create the breakpoint. Let's just run it and see what we actually got from our app initializer. So as you can see, we are here. So the start async, the types that we have. Let's see what we've got in here. So we've got two ReadDbContext and WriteDbContext. So as exactly like we expected. And now on each of them, we'll just call the migrate async. Of course, we already know that the migration was scaffolded only from the ReadDbContext. So this will be executed actually only once. So let's just give it a try. We have the application up and running. And now let's just jump back to data grip, hit refresh. So refresh, we have databases, but now it's like one of two. I can see that I have my packet, and yeah, my application actually defines scheme, and this scheme is called packing. And within this scheme, I have two tables. So first is packing lists, and this got ID, version, name, and localization. And now we have another one, which is the packing items with ID, name, quantity, is packed, flag, and this foreign key to packing list. So it looks like we basically have the EF core up and running and actually collaborating with our application. So now it's just the matter of jumping to the last final layer, which in our case would be a presentation layer, and see whether this actually works as expected. So whether every single layer is collaborating with each other. So in Packet, we basically are going to stick with the well-known ASP.NET Core controllers. Of course, there are different, I would say, alternative approaches of how you could actually create this layer responsible for handling HTTP requests. Like you could use the feature known from, I think that was ASP.NET Core 3, which is the routing. So something, if you're, I would say, familiar with the good old Nancy project for ASP.NET, in which you basically define the endpoint and the callback that should be eventually called. This is something I would say similar, which of course has its drawbacks because you don't have this nice capabilities of ASP.NET Core controllers like data binding to particular C# objects and many other things. But in general, you could completely get rid of the controllers. But yeah, we'll just stick to this traditional approach in this course. So let me just first clean up this a little bit, because I've got like weather forecast model, which comes from the default project. So also the controller will be something that I would like to avoid. And yeah, let's start with our controller. So of course, everything is already wired up by doing .NET new web API, or like by doing this from the writer. So of course we already have like add controllers, we are doing map controllers in here. So it's just now the matter of adding something to our ASP.NET Core project, and this should work just fine. So I will create, as you probably expect, the controller called packing lists controller. Okay, and this basically will derive from controller base. So controller base. Okay, I will also mark this as API controller, and I would like to have this route. So route is basically this template controller, or maybe even API/controller will be more precise. Okay, so we've got our controller. Now, of course, we need some sort of actions for the HTTP, for our HTTP request. And yeah, we need to implement each individual action for both commands and queries that we have defined for our application. So let's start with the gets. And of course, for the getting, I need some sort of way to to get the query and execute it within our infrastructure, right? So let's say get the query called search packing list, and get it and execute this particular handler. So for this, of course, we've created iQuery dispatcher. So dispatcher will be responsible for this delegation, and thanks to this, we don't need to inject multiple query handlers into our constructor. I think that we can already do the same for commands, because that should not be a big surprise. So command dispatcher is also in here. Let me just regenerate this because the order is incorrect. Okay, now it's way better. So HTTP get, and now this will be rather just API / packing list / and the identifier, which is of type GUID. And let's implement this public async task of action result of T, where T is packing list DTO. Just keep in mind that API project sees the infrastructure, so it also sees the application, and this is why I have this reference to packing list DTO. I will stick to this get convention without async suffix, and that's basically because of the created action that we are going to eventually add, and there is some sort of enforced convention when it comes to the name of this particular method, but we'll just get to that in a minute. So from route, I want to get and construct automatically, and this is this automatic model binding mechanism, which is given by the ASP.NET controllers. This will be automatically put into our query. Okay, and the result is await, and then query dispatcher, query async, query. And of course in here, I could do something like if my result is null, then I would either like to have the 404 status code being returned, so not found. And if it's not null, then I will just return the OK with result. Okay, now the second method, maybe let me just copy paste this. So the second one will be just the get with no explicit parameters within the route, but from the query, I will either expect the search phrase parameter. Okay, so I have query, and the result in this case will be IEnumerable of packing list DTO, so I need to change this also in here. So IEnumerable of T, where T is our DTO. Yeah, and we can immediately see that we have this code being slightly duplicated. So it's now the matter of whether we would like to have some sort of base class, or we just want to extract this as some private method. Probably putting this to some sort of abstract class would be more sufficient, because we might end up with multiple controllers, and it makes no sense to create the private method in each of them. So maybe let's just do small refactoring, base controller, and basically this controller will be abstract class, which will derive from controller base. And I can already clean up a little bit, because this will go from here to here. And in here I will create protected action result of T result. And I will call this OK or not found. This of course will be tResult, and tResult result. Okay, and if result is null, then I will return not found, otherwise it's okay with result. So now I can refactor the controller. Now it's using the base controller, and this is rather okay or not found. Same goes here. This check is not required anymore. All right. So already looks better. Now the actions that will call the command dispatcher. So let's start with post request. So http post, and this post will create our packing list. So public async task of I action result, and post create packing list with items. Okay. Dispatch async command and return and now created action. Created action. Okay, I missed add, so created action. And now I need to pass the name of our method, which we can call to retrieve the resource. So in our case, that would be this name of get. And this is why, yeah, for some reason, Rider expects me to call this get rather than get async. And return the identifier of the resource and null, because I don't want to return the whole object as the result. So return created add action, just like that, and this should eventually call our command handler in the application layer, and we should get the link in the header, some sort of, you know, Richardson fourth maturity level, like with the HATOAS, but not exactly actually, underneath with the link that this newly created resource can be reached at this particular endpoint. Now, at this point, I would like to discuss one thing regarding this identifier being returned to the caller, because this is a very common question when it comes to CQRS. So, okay, once you are creating some sort of resource like our packing list with items, how the heck I will inform the caller, our, let's say, JavaScript application, about the identifier of this newly created result? And of course, there are a few different approaches that you could adapt. So in our case, as you already discovered, I'm basically passing the GUID identifier into my command, right? So I'm expected that it will be actually the client's responsibility to give me this pre-generated identifier. And of course, the reason they don't need to know anything about my internal database state is this assumption that the identifier will be basically the GUID. So it's very unlikely that I will have the conflicted identifier for my packing lists. Of course, someone may say at this point, okay, but yeah, GUID is not very optimized for the indexing. So for me, it's not a way to go. I need something slightly different. So just keep in mind that not necessarily, because I know that the developers tend to think about like the identifier is always this artificial number that we come up when it comes to, you know, creating the software. This is like more technical concern. And if you are able to find the natural key for your resources, then maybe it's completely fine to omit the identifier completely. I mean, in our case, since we at some point we had this assumption that the name needs to be unique for our packing list. This turned out to be more like natural key. So even without knowing the identifier, we could change this to, let's say, long and use it in the entity framework, right? And this would end up with the database being generated with the numeric identifier. And if you would like to ask for the particular resource, then the implementation will be slightly different. So instead of doing API packing list / let's say this GUID, there will be API packing list / the name of the list. And that will be the key of my resource, which would be required for getting the information about the particular packing list. Of course, at this point, someone may say, yeah, but I did my best, but I didn't have any natural candidate for the key. So I need to, I need to create this artificially, but also I would like to avoid the situation in which, I basically pass the GUID. So a nice alternative is, let's say, the Snowflake ID. So the general idea is that you end up with this long, so basically 64 bits for your identifier, and there are four sections that build this particular identifier. So you have 1 bit for the sign, 41 bits for the timestamp, and thanks to this you can order your packing lists in the chronological time. Order, not the time, chronological order. And then you have the generator. So you have 10 bits for the generator. So this will give you this uniqueness, and you can be pretty much ensured that you will have no conflicts within your whole application. And then you have also something for the sequence, also for the indexing purposes. So once you would actually have the Snowflake number, it's still a number. It's good for your database purposes, and it can be pre-generated somewhere in your application before you actually call your command dispatcher. All right. So you could do something like in here, var identifier equals, and then this ID generation, put it into your command, and you would have this identifier created before you actually hit the command dispatcher. I mean, if this is too much, then you can make more relaxed version of CQRS and return the result from the command, because maybe you don't like this approach to generate the identifier in the API, and that's totally fine if you want to avoid this. I think at the end of the day, if something works for you and this will be used only for returning the identifier, you can do it. But in this particular case, I've just rely on the identifiers, these GUID identifiers, and works just fine. All right, so we have the post for this packing list creation. We can proceed further. So I'll just copy paste this. So now it's the matter of maybe put, and this put will be for adding the packing items. So from body, actually I miss here from body. So it's rather from body and add packing item, and the endpoint will be probably slightly different. So that's packing. I need to check the identifier. So it's packing list ID. Okay. So packing list identifier / items. I think will be more restful or rest-ish. And in this case, I will just return the OK. All right. So this is the put, and same goes for packing. So we can do items / name / pack. Okay, and the put is actually pack items. Sorry, pack item. Okay, and the last one will be related to deletion, both item and list. So http delete. So packing list slash items slash name. And this is the delete. So delete packing. Call this remove packing item. Okay, so remove. So this is the first, and the last one is delete packing. I think that we should make this in more unified fashion. So maybe remove is the one, and also now we'll change the name of the handler. Okay. So remove packing list. This is the command, and this actually will be the identifier, but in here we have the ID. Okay, so ID. This is GUID. We can also add the constraint in here. This is the GUID as well, and also in here this will be a GUID. Okay, so two methods for getting, and underneath this uses of course the query dispatcher, and few methods for, maybe I'll change this to put. Okay, so put, so two puts, delete, post, two gets, and that's, yeah, something that is satisfying. Of course, delete is also required here, put, post. Now it's good. So let's just give it a try, run the app, and we should see whether this works or not. So our Packet API is now up and running, and as you can see, it can be reached at localhost 5001/swagger/index.html. This is like default configuration that comes with this project scaffolding. We have our endpoint, so let's just start with creation of our packing list. I've already put few breakpoints on different layers, so we'll see how this whole flow actually is wired up. So let's just go to post, try it out. My list is name, maybe we are traveling for 5 days. Gender is 0, so this probably will be female, I believe. Localization, I'll just do Warsaw, Poland. Doesn't really matter because underneath we are relying on this dump weather service. But once I will hit execute, we should see how this works. So we have our packing lists controller. Now we can proceed further. We have our post method. Our command looks as follows. So it's kind of hard, I see. Okay, let's just do it like here. So we have the days. We have the gender, which is, sorry, in this case that was actually male. Identifier localization, which contains both city and country, and the name is my list. All right, let's move further. Now we are within the repository. So repository is constructed, actually, as you can see, this is just the constructor, and the reason for that is that probably the types are being resolved right now, and indeed you can see that command dispatcher was asking for required service. In our case that was the command handler, and the command handler of course needed the repository to be resolved. So in this case we can see that this actually is our create packing list with items handler, and we are calling our handle async method. So this looks good so far. Now we are checking the existence of our list, and if this my list already exists somewhere, we should have the exception being thrown. So at this point there is no exception, And now we are calling our dump weather service for the temperature. Of course, we know that there underneath there is like just random. So yeah, the generated number is actually 15. Now we can move to our more like domain part of this execution, which we'll call our factory. So factory gets this data, creates this policy data in here. Now we need to filter the policies that are applicable for our execution. So what are the chosen policies? So we should have at least 2. So first is the basic policy, because the predicate was, as you remember, like true. So this always needs to be applied, and also male gender policy. And the reason for that is that we have only 2 is that we have 15 degrees, right? So the temperature is 15. So this is neither suitable for the high temperature policy because it's lower than 25 degrees, but at the same time is too hot for this low temperature policy. So that was just the, I would say, luck that we had in here. Okay, we can move further. So let's just jump to our factory. So this is what we have. Now it's just the matter of generating the items, putting this into our packing list, and eventually this packing list should be returned to with, as you can see, 14 items which are generated for us. And this should be returned to our command handler. And the command handler eventually called our repository and add async method to persist this into our Postgres. So once I hit OK, we should see that we actually have the 201 created, and this actually already gives us this nice link with the location. So our newly created packing list is available at API/packing list, and this is the identifier of our packing list. Of course, we can confirm this also on the database level. So packing list is indeed in here. We also have the packing items being inserted into our packing items. So let's now focus on the read side. So for this purpose, I will just add few more breakpoints. So get in here, and also get in here. Okay. So now let's just jump back, grab the identifier, which is here, and get this by identifier. Identifier should be this. Execute. All right, and I'm getting the 404 from the Swagger, which honestly I don't know why. So for this purpose, I will just use the Postman for getting our packing list. So one more tool that we can use for fetching the data from our API. I'll just click send. And this time it apparently works. So once again, we are within our packing list controller, but now this time we are using query dispatcher. Query that contains the identifier of our packing list. Now, as we can see, we are within the infrastructure layer, and we can construct the whole response. So we are including the items with this particular identifier. We of course then producing the response as a DTO with no tracking, singular default async. Let's click continue, and in here indeed we can see that we have our list with the items being also included. So it looks like our API is working. Probably the rest of the endpoints should work just fine, because the whole mechanism is the same. I mean, from the technical point of view of how we wired this all together, this should work. Of course, maybe I did some typo or maybe some other implementation detail, but when it comes to the I would say architecture perspective, this should work just fine, because yeah, the whole execution process is common for both queries and all the commands. So I would say that there are only two things that actually remain when it comes to the overall capabilities of our API, and this is more like infrastructure thing. First is the ability to in some way handle the errors, because at this point, if I will just jump back to our post and I will try to create the list with the same name, so that was like my list, I believe. When I click execute, once I will get to this, I've got this exists async, and in this case, as you can see, my execution is aborted, and that's because, yeah, indeed I have the packing list with the same name, and also this should be present in here. So I've got 500 internal server error, and I've got this not so pretty call stack being displayed. So I would rather like to create some sort of response which would only contain this nice message that packing list with name my list already exists, and maybe some sort of error code for the translation purposes. Yeah, but anything other than that should be pretty much omitted. And also maybe we could think about replacing the 500 with 400, so bad request would be more sufficient for our application or domain exceptions. So let's jump into the code and modify it a little bit. Okay, so the general idea behind error handling is very simple. I will just create somewhere in here within our shared package, I will create the ASP.NET Core middleware, which will catch the possible exceptions being thrown from, domain, application, or the infrastructure, and based on the type will perform some action or not. And that's, I would say, whole magic. So let me just create a directory called exceptions, and in here I will define exception middleware. So this will be internal sealed exception middleware, which implements iMiddleware. And in here, if you're familiar with this ASP.NET Core capability, you probably know that we have an access to DbContexts, which gives us an access actually to both request and response. And we also have this request delegate, which is, I would say, next step within the whole HTTP request execution. So just to briefly discuss this particular parameter, if we jump back to our, let's say, entry point of our application, so to startup CS in Packet API, so our ASP.NET Core application, we have two methods. So configure services, which is just the configuration for our dependency injection container. And basically in here, the order does not matter at all. I mean, we are just adding something, some registration to the container, while in here within the configure method, we are defining the whole execution pipeline of HTTP request. And in here, the whole ordering of this particular method invocation actually matters. So this is how our execution pipeline look like. So we have, like, first we are using the HTTPS redirection, we are using routing and the authorization, and at the very end we have the controllers being mapped. So these are this is first step, second, third, fourth, etc. So in our case, we would like to do the following. Like somewhere in here, I will just do use error handling. And the reason I'm putting this at the very, very beginning in here is that I would like my handler to catch any possible exception that comes from my application. So basically, this could be either here or or here, but the crucial part is that this needs to be called before use endpoints and this map controllers, because the controller will eventually call our application or infrastructure when it comes to queries. And these are two possible, I would say, places in which I can throw my exception. Or I can also think about another type of exceptions that are not created by myself, but maybe they come from EF core, like concurrency exception, or maybe some configuration exception that comes from different types of infrastructural pieces that I'm using within my application. So I would like to catch any sort of exception that might occur within my application, and yeah, react to this thing. So in our case, since I'm going to, let's say, leave it as it is, so this will be one of the first steps being defined for the HTTP execution. In here, the next refers to next step with this pipeline. So this might be like authorization or this HTTPS redirection, but eventually this next underneath calls another next, etc. So we have this chain. From this middleware point of view, the crucial thing is that this next eventually will call our controllers, which means that I need to just wrap it into try block, and yeah, any sort of exception being thrown should be caught in here. So what I'm actually going to do is the following. I'm interested only in the packet exception. So this is the one that we defined at the very, very beginning. And yeah, since this is the custom exception, I don't want to rethrow this exception further. I would rather create the nice HTTP response for my caller. So context.response. And I will first set the status code. So for now, it's like hard-coded information that this will be always bad request, but of course we could think about more maybe component which will decide which status code should be returned, depending maybe on the payload of this exception or something else. But let's just keep it simple for now. So response.headers, I would like to add the header, so content type. So content type will be application JSON, because I want to return the JSON. So application JSON, okay. Now I would like to create the error code. So not only I will use the message that comes within my exception, but I would like also to create some sort of very simple error code, let's say, based on the type of my exception. So let's say, let me just give you an example. Like we have domain exception. So like here, empty packing list ID exception. I would like to create some sort of error code which would look like empty packing list ID. Something like this without the exception word. So that would be snake case text, which basically takes the name of this exception type and transforms this into a nice error code, which could be eventually used on the, let's say, JavaScript application for picking the error message based on the translation settings or something else. So in our example, of course, we need some sort of method for accepting the string and making this more like underscore case. So let me just copy paste the method that I for sure didn't get from the Stack Overflow, and we can now use it in the following scenario. So var error code equals and then to underscore case, and I need to get my exception get type dot name, but I also need to replace the word exception with string empty. So hopefully this is clear. I take the name of the type, I'm removing the exception, and I'm changing this from Pascal case to like snake case. And now I can make my JSON. So I'm calling JSON serializer from system text JSON, then serialize, and I will just use anonymous object with error code and with ex.message. And await context. I think that error code should actually be used like this, because otherwise I would have one starting with the capital M, and this would start with the non-capital E. So await context dot response dot write async, and now we have our JSON, and that's it. So of course the question remains what we gonna to do with the other types of messages. Let's say invalid operation exception or something that could come from the let's say EF core or something. Yeah, we basically don't care. I mean, this will be returned as a 500 with this stack, with this call stack. Of course, we could add this, but you get the general idea. So it makes no sense to add now the error handling for every possible exception that could be thrown within our application. So now it's just the matter of adding this middleware somehow. So in this particular case, I will just get back to shared, and we have this add shared method already. So let me just add another one. So services that's scoped, add scoped, and exception middleware. And we also need now another method. So public static I application builder use shared. And this will be called on I application builder app. Okay, and use middleware, exception middleware, and return app. Okay. So now let's just copy this, and we can jump back to error handling. So in here, well, I could maybe do this in here after the HTTPS redirection. The key point is that this needs to be before use endpoints. And yeah, this should be working just fine. So let's give it a try. The whole application should be up and running in just a few seconds. And once we have it, let's just try to create once again the list with duplicated name, execute, and we have 400, so bad request with the nice response, which says that packing list with name already exists, and we have also our error code. So yeah, this is now way better than it used to be. So the second and actually the last thing related to the infrastructure, and this is also quite common question regarding the clean architecture itself. It's like, yeah, with this approach, it's very, I would say, in here you have very clear boundaries between what belongs to application, domain, and the infrastructure. But what about the stuff like logging? I mean, logging is very common, and you probably want to add the logging eventually at some point to your application. And yeah, does it mean that I should add my logging to application and in here like to command handler, or is there any other way to do this in more, I would say, robust way? So of course, in this case, it pretty much depends. I would rather avoid injecting the logger into the command handlers, and that is only because I'm not a big fan of too much logs, because it obfuscates the code naturally for me and it becomes very unclear. Of course, this depends on the type of the code. So if you're creating a library, the logging is very helpful. Everything related to infrastructure is very helpful. So maybe for, let's say, shared our app initializer, somewhere in here, using the logger would be a proper usage. I mean, I would like to see maybe on the application bootstrap phase, I would like to see information that, okay, I've discovered 2 DbContexts and now I'm executing the migrate async method on each of them. So in this case, it's way better than having just no information at all. But yeah, for the application, every single time I'm creating something, maybe I would like to keep this application layer more like clean, and I would like to avoid the situation in which logging is defined together with my process logic. It's just something that ideally should be treated completely separately. So how can we add the logging without actually adding the logging to our handlers? So at the very beginning of the implementation, once we actually, I think, jumped into the application layer, we've added the package called Scrator. So at that time, I mentioned that the Scrator has 2 capabilities that are added to ASP.NET Core dependency injection container. So one of them was the scanning ability, which we used for automatic scanning of command and query handlers. And the second capability that we are going to use right now is the ability to decorate the classes that are basically registered in our in our dependency injection container. So a good example could be the logging in this particular case. So I will, within the infrastructure, because once again, it's more like cross-cutting concern. So this is why I'm defining this within the logging. I will create the directory called logging and the class, which will be called, let's say, logging command handler decorator. All right. And of course, internal sealed, just to keep this not accessible to anyone else. And the idea here is very simple. The whole pattern is based on the assumption that the decorator will wrap the natural behavior, this origin behavior of the thing that it decorates. So in our case, as the name already says, we want to decorate the behavior of command handler. We want to enrich its capabilities with the ability to log some sort of useful information. And to make it work, the decorator will implement the same interface that the component that we would like to decorate. So to make it more clear, we want to implement here iCommand handler of T. And notice that I'm implementing this as the open generic. I don't want to specify any particular type. It will be just applied to any sort of command handler that will resolve in runtime within our application. So of course we need to fulfill the same constraints. So this needs to be first the reference type and needs to implement iCommand interface. And now I can implement this. And the idea is very simple. In here, I will create the iCommand handler of tcommand. So this is our command handler. And I will also pass iLogger, which comes from ASP.NET Core once again, of T, where T is logging command handler decorator of tcommand, logger, and those two will be injected. So what it means is that whenever our command dispatcher in this case, will say, okay, give me iCommand of T, the actual type that will be resolved by the container is not gonna be the handler itself, but rather decorator with this enriched behavior, which inside will have the original command handler being injected. So we can think about this as some sort of middleware, but on the IOC level. So now I can, without changing the behavior of my original command handler, I can wrap the whole execution of this handler into some sort of more advanced thing. And the cool thing about the decorators is that I can apply multiple decorators on the same concept. So each of the decorator could enrich my execution with some different behavior. So one could be dedicated for logging, but I could also think about decorator for maybe creating a metrics or some, other stuff related to other cross-cutting concerns. So in this case, I will just add this logging capability to my handler execution. So the whole thing will be the following. I will create command type variable, and that will be just command.getType.name. In here, I will just do try catch. And in here, let's just type something. So maybe log information, and here started processing. And this will be our command type command. Okay. Now I want to call my handler. So first I will write this message, then I want to call my handler, passing the command. And let's say after I finish, I will do finished processing this command. And once I will have some sort of exception being thrown, because maybe I've got the exception on the domain or the application layer, I will just do here log like error and the information that failed to process, and then command type command. And the crucial part is that I need to throw this exception further, because if I will swallow the exception here, then I will never reach my exception middleware that will eventually return the HTTP response. So it's critical for me to always remember that the point in my, I would say the place in my application in which I'm basically responsible for actual handling with the exception is my exception middleware, while in here I am only enriching my whole execution with some additional logging, but then I need to rethrow this further. And that's pretty much it when it comes to whole decoration stuff. Of course, at this point I need to somehow explicitly register my decorator, because it's not that smart, I would say, and of course that would be quite hard to come up with some sort of automatic registration of my decorators. So somewhere in here with my add infrastructure, I will do the following: services.try decorate. And in here I need to pass, of course, the component that I would like to decorate, and then the type of the actual decorator. So I will use the non-generic versions, since I want to register both decorator and the command handler as the open generic. So I want to decorate this type with this implementation. This. Okay. So let me just run this up and put few additional breakpoints. So one in the decorator itself. Okay. One in the decorator, and okay. Another one in the actual handler. So here. But this one, so the handler. And that should be maybe the last one in the dispatcher. Okay. So now I can just get back to the Swagger, call the post with my list, execute, and let's see what happens. So in memory, command dispatcher asks for I command of t, but in as you can see, we are not getting the command handler directly, but rather logging command handler decorator of t. So in our case, this t is of course create packing list with items. Now, once we'll basically call handle async, we're not gonna call the process logic directly, but first we will enrich our whole execution with the logging information. At this point, once we'll print this information, we want to call the actual handler. And now it's this whole part related to the process logic. We already know that this will give us an exception. So I need to be prepared for it. So in a catch, I can log the information that, yeah, we failed to process the command of this particular type. So in here, we should see the information, and we need to throw this particular exceptions further for our exception middleware, just to create nice a response with 400. So we can see fail, and we can see that failed to process create packing list with items command. Of course, we could log also the reason, maybe the message of this exception, but yeah, for us it doesn't really matter at that point. It's rather a quite simple change. And now I could also see this 400 in here, but the handler's behavior got enriched with the logging capability without actually changing the implementation. Of course, someone may say, okay, but what happens if I would like to log something very specific to one particular handler? Yeah, in this case, I mean, it's quite hard to come up with the decorator itself, because the decorator can only gives you the logging at the very beginning and the end of the handle async, and not, let's say, somewhere in here. But in most cases, I would say I found it useful, and this is my preferable way of dealing with the logging once I adapt the clean architecture. Alright, so let's just briefly discuss the unit testing, because this is the level on which we're going to focus within the Packet project. Basically, if you would ask anyone about the purpose of doing the unit testing, there's always this one keyword, which is the isolation. So the idea about the whole unit testing is that you basically have this unit, whatever you defined it, and the whole idea is that you want to give this object an isolation from the outside of the world. So by doing this, you are preventing the situation in which the failure of the external component basically breaks the test of the component that you're actually testing. And I would say that this is partially true. I mean, there are two different schools when it comes to the testing itself, at least two popular I know. So first is the so-called London school, or the Mocky school. So basically, in this case, you are using the actual, let's say, mocks or stubs or other test doubles to isolate your unit, which in most cases is basically a class, from the outside of the word. So let's imagine about the command handler, which has few dependencies being injected into the constructor, like the repository, like maybe some domain service, etc. So instead of giving you the actual implementations, which could be implemented wrong, you're basically mocking all of the dependencies, and then you're giving the mocks particular behavior adjusted to each of the individual scenario, and that's pretty much how it works. And thanks to this, you can go through every single, let's say, flow that you have within your command handler, and see whether this particular let's say implementation actually is valid or not. I mean, there are a few issues that I have personally with this approach, and you'll see this once we'll jump into the code. But this is basically this so-called London school. The opposite I would say, team is called Chicago or Detroit School, and basically this is more I would say traditional approach in which you're actually giving the actual implementations when it comes to your dependencies. So I would not create the mocks, but rather the actual implementations. Of course, as long as you have, as long as it's still like just the unit test, but not the integration test. So let's say that I would rather not give you the actual database connection, but let's say that you have the factory being injected to your controller or to your command handler, then yeah, I would give you an actual implementation that comes from the domain, and I would just, as a unit, I would treat this particular behavior that I'm trying to catch within each scenario, and that could be more than just one class in general. And in this particular course, we are going to follow the London School, since I think that's, especially for the beginners, it's easier, and what has the advantages and disadvantages is less painful when it comes to creating the arrange phase, which I'm going to cover in just a second. But basically, yeah, since you're creating the mock using some sort of library, it's rather straightforward. When you have the class which has a lot of dependencies, yeah, for each, assuming that you would follow the Detroit School, yeah, you would need to create every single dependency manually using, let's say, new operator, and you just need to remember that those components might also have its dependencies. So at the end of the day, you might end up with multiple, like, you know, dozens of dependencies that needs to be created first to actually provide the proper components to the class that you actually wanted to test. So there are pros and cons of both approaches. I'm more into the mockist school, but this actually, I would say, in most cases applies only to the application level, because that's where you have the abstractions on top of, in most cases, like IO bound operations. When it comes to domain, it's rather straightforward, and in many cases, as you will see, it's not even needed to think about mock stubs or any test other test doubles. And yeah, so you're going to see how this London approach will look like, and of course we are going to structure each of the tests into like 3 phases. So we have like AAA, or what it means is, of course, arrange, act, assert. Arrange is the phase in which we are trying to prepare the whole environment for a particular test scenario. So in this case, you might, let's say, add the behavior, expected behavior to your mocks, or maybe you want to prepare the I don't know, the command itself that is going to be the input for the command handler, or anything else. The act is the actual essence of the test, so the behavior that is under the testing in a particular scenario. And the assert is nothing more but validating whether the result is just matching your expectations. So those 3 steps will be, of course, implemented in each of the scenarios. And yeah, this is basically how we're going to tackle this, and we're going to see the example unit tests both on the domain level. So you will immediately see how easy actually it is because of this lack of the IO operations in there. Because when you think about this, it's like my aggregate has the input, some sort of, like, let's say, value, object, entity, whatever, and it has the expected output, which in our case would be the domain event, and that's pretty much it. It's like just giving an input and expecting the actual output as a result, and that's pretty much it. I mean, it's very, very straightforward. For the command handler, it's more about those mocks and adding the particular behavior to them, but it's still, since the whole handler is more granular, it's like the representation of particular use case, it's rather straightforward, and there should be no big issues with covering and adding the tests to each of the individual handlers. So this is going to be the only level that we're going to cover. I'll probably we'll probably as a DevMentors create like different courses, mini courses or materials, regular materials on the YouTube about the testing itself. I would love to cover the TDD and behavior driven development, but yeah, this is just another topic, and let's just jump into the code and see the actual implementation. All right, so let's just jump into our unit testing, and as you can see, I already have Packet unit test project. Typically, I would probably split this into two separated projects. So one would be for the domain, one would be for the application, but I just want to to keep those things simple. One thing though is that, as I mentioned, I'm gonna follow the mocking school, so the London school, and for this purpose I added one library called nsubstitute. I also added the shouldly, and basically shouldly is library with for the fluent assertions. So the assert part phase within the testing should be more expressive when it comes to the expected result. So I think that without further ado, we can just jump into the first test scenarios, and I think that you immediately see the benefits of the clean architecture itself. So let's start with the domains. Once again, it's the most important layer. So in here I will just create the domain directory, and I will just add example class. When it comes to naming convention, within the testing, I'm going to, the naming conventions will be slightly different, and casing will be also slightly different. For the test classes, I will stick to the Pascal case. So let's say that I would like to add some testing for my packing list aggregate. Of course, this is once again your choice, whether you want to, let's say, dedicate one testing class for, let's say, one method, or maybe one testing class would encapsulate every behavior that you have within your aggregate. In this case, once again, because I want to keep it rather simple, I will just create something like packing list tests. So that would basically cover all my public APIs exposed from the aggregate, but you can just make it more granular and maybe dedicate it to one dedicated method. So packing list tests, and yeah, I think that we can add first scenario. So let's start with the fact attribute. So this one comes from the X unit. So this will just indicate that this actually is executable test. And since the domain itself is not dependent on the IO, I can make it synchronous, so that will be rather a public void. And now it comes to the name of this scenario itself. And in here I'm gonna use some sort of, I would say, snake case, but with the Pascal casing. I'm not quite sure whether this has its name. Probably there is a name. But the reason I'm not gonna follow the Pascal case itself is very simple. Usually I like the methods to be very expressive and very detailed, what behavior I expect in particular case. So obviously this implies quite longish name, and Pascal case to me basically doesn't work. I mean, it's really hard to read it, to read something in the Pascal case when you have like 6, 7, 8 words within the name of the method. So I'm using this hybrid snake case and Pascal case approach, and to me it works just fine. So yeah, let's start with, let's just jump maybe to the domain and to this packing list. And we have method like this. So adding an item which accepts the packing item, and first we are checking whether the item with the particular name already exists, and if actually this happens, then we are throwing an exception. So let's, as an example, let's test this method. So we can split this into two separated scenarios. So first will be failure, so checking whether this exception actually gets thrown once we have the duplicate based on the name, and the other one would be this successful path, which would add the items to collection and would add the domain event to our aggregate route. So let's start with this first approach. So the name I'm going to create will be first name of the method, so add item, then throws. Then I would just copy paste the whole exception because as I mentioned, I want to be quite detailed. So once this actually gets, let's say, gets failing, I will immediately know what actually happens. So throws packing items already exists exception when, and then there is item with the same name. Maybe already item with the same name. All right, so just like this, and I need to just correct this. So name is kind of longish, but at least I know immediately what behavior I do expect. So first things first, I would like to create the packing list aggregate, which is kind of obvious. So maybe for this purpose, I will create the method, which will help me to create this packing list in every single scenario, because maybe I don't want to make this like this code duplicated. I would rather want to extract this somehow. So get packing list. Okay, and now I would like to create the packing list. The issue though is that, of course, the packing list itself has private or internal constructor, so I'm not allowed to actually construct this. Of course, if you don't want to complicate your life even more, yeah, you can make this public and just relax this assumption that this class is fully hermetic and it can be constructed only via the factory. Yeah, but in my case, I would like to just keep it rather private or internal. So of course, the only way to create this packing list is through the factory. So in this case, I'm going to create another field in this case. So that'll be private read-only packing list factory. Okay. And I'm going to initialize the constructor, and I'm just gonna to manually create the factory. The reason I put both constructor and private field at the very end of the class is that when it comes to unit testing and testing in general, in most cases, the like everything which is related to fields and constructor is rather the arrange phase. So preparing the whole test scenario to execute. So to me, the arrange part is not that crucial. To me, the act is the phase that I want to be focused on, and of course the assert, because in there I make all the verification. But the arrange itself and preparing the whole environment for the test execution is rather not very important. So I usually, when it comes to unit testing, this stuff actually gets at the very, very bottom of the class, and usually I also put this into the region like arrange, and that explicitly will tell you that now this is just the arrange phase. So in here, the factory gets instantiated just by using new operator, so new list, packing list factory, and of course in here we are expecting the policies, but in our case the policies are not very important right now. I mean, we would probably create the different domain, different unit tests for the factory itself. So I don't care right now. I'm just passing the enumerable empty to just have this sort of policy being resolved, but I don't care that much about the particular policies that we'll have within this factory. I just want to create this packing list aggregate somehow. So this is it, and now I can implement my packing list. So I will use second overload actually. So packing list gets created via the factory, and we had two methods. So this is the one that we use within the command, so create with default items, but we also created but actually haven't used this one, which is just create. The assumption and idea behind this is that we'll basically have no generated no generated items are added in here. We'll just basically create the empty list with no default items at all. So in here I will just pass some sort of GUID, name of the list, and then the localization, which is created using this static factory. So let's say like Warsaw, Poland, and this of course needs to be finished that way. And then just to be sure that there are no events, I will do packing list dot clear events, and now I can return it. All right. So first scenario, we want to check whether this exception is thrown, and with this actually can be moved to my arrange, I think, with no issue. Okay. So in here, first, of course, I would like to create the packing list itself. So I will just call get packing list. And now I want to add I need to first create this duplicate, right? So I will just do, let's say that we are still within the arrange. So I usually don't do this, but for now, just to make it clear, this is still arrange. And during the arrange, I would like to add the item, and this item is going to be called, let's say, item 1 with quantity 1. Okay. So that's my arrange. Now, the most important stuff, which is act. So I want to make sure that once I do the exactly same thing, so I want to add the item with the same name, I will get an exception. And of course, there are different sort of ways of actually verifying, but for the X unit, the easiest one is to use the record. So not the record, which is the C# record, but rather the record static class that comes from the X unit. So var exception equals record, and then we have two overloads. So we have exception and exception async. I will just go for the first one, and in here I'll just put the code that needs to be verified. So I want to make sure that this actually produces this exception, and I want to make sure that this exception is actually not null. And for this purpose, I'm gonna use this extension method from the shouldly, so should not be null. Okay. And the second one is that this exception should be of type, and in here I will just copy paste this from the name of the method. So this should be of type packing item already exists exception. Okay. So let's just run it. And immediately we should see the test is actually green. So yeah, the method underneath works as we expected. We cannot add the item with the same name. So this works just fine. Now the second test will cover this scenario. So we want to make sure that actually the items gets added. Of course, the issue with this approach is that since now we have everything in here is private, so the lists with the items is list with the items is also private, which means that there's no easy way of checking whether this actually gets added to the collection. The only, I would say, assertion that we can make is to rely on the domain events that we have within. So the second test will basically check whether the aggregate now will contain this packing item added event, and if so, then we'll just believe that actually that happened, because semantically this means that this operation actually succeeded. Of course, there might be some sort of questions like, okay, but this is just the event, but what happens if someone will basically throw this line away? In this case, your test will still pass, but the item actually isn't being added. I mean, I know in this case, if you really don't trust, yourself or the other developers, which is perfectly fine, you can just make this maybe public, and you will just make the assertion, or maybe create just public IEnumerable, which would expose this for the reading purposes only. And in this case, you would have this, you would be certain that this actually happened. But once again, it's either choosing the being fully hermetic and encapsulating the implementation details and relying on the output of our aggregate as some sort of single source of truth. Like if this happens, the assumption is that this definitely happened. Or if you don't want to complicate or you don't want to add more boilerplate to your code, then you can basically throw those domain events away and just make everything like being rather public properties with getters and private setters. And this would, like in this case, and that would, in this case, the assertion can be done directly on the properties rather than on the domain events. So I think that this now should be clear. So the second scenario is going to be the following. Let me just create the fact and another method. Okay, and the whole test is going to be called item, and then adds, and then packing item added, I believe. So this one. Event, or maybe domain event, on success. Okay, so this few lines, I think there can be actually they can be actually copied. This one is not needed anymore because I don't want to make the this actually to be not null. I would rather have this to be null, so I can make already the assumption that exception in this case should be null, because I don't expect anything to be thrown from the add item method, so it should be null. Okay, and then I can check whether actually I have the events in my collection, because actually the events are exposed from the aggregate root as the public property. So I can do something like packing list, then events, as you can see, IEnumerable of iDomain event, and then count, and should be 1. So I'm expecting in this case that I will have exactly 1. I can of course check the type, so I could do something like var and then event equals packing list dot events dot first or default, and let's say that as packing list added, actually this one, so this one, okay. And of course I need to check, because I'm using the like s operator in this case, so I need to verify whether event dot actually that should not be null, because if I would have this assumption, this assertion actually may pass, but if for some reason the domain event which is added to my events collection is of different type rather than the packing items added, then this whole line will return me the null, right? I mean, the object is there, but once I'm trying to cast this to packing items added, I will get the null. So this is why I'm doing this like in this particular case, I'm using the should not be null. Of course, if you would like to do this differently, you could do something like, you could remove it and do should be of type, and in here packing list added, packing item added. Okay, so that would also work, but the reason that I wanted to use the s operator was that now, of course, if I will make the run, this should work. So let me just, yeah, this is already green, but maybe you would like also to check the payload of this message, and in this case, if you have the event So the event in this case is, as you can see, iDomain event. So in order to actually access, let's say, the name property that we have within it, I would need to do something like packing list, packing item added, and then event, and then the packing item and the name. And in here, let's say, should be that was like item 1. Okay, so it's not very pretty. In this case, I think that like this as packing item added and should not be null is better, but it's of course rather your choice what's actually suits you more. So as you can see, still green. Maybe I'll just get this to the previous one. Okay, so should not be null. Okay. All right. And this is not necessary anymore. You can just make sure that this still works. Okay. And yeah, of course, I would rather recommend to not to put too much assertions within one test. I mean, in this case, all of them are more or less related to the fact that I have like one domain event within my aggregate, but it's better to have like more granular scenarios which will have fewer assertions rather than having one big ass method with that, like, you know, dozens of assertions at once. So I forgot to put, of course, the assert. So that's arrange act assert, and of course in here it's like arrange act, and here starts the assert. So I think that this will give you the flavor of how we can actually create those scenarios, because yeah, if you would go to packing list, it just every single method would do pretty much the same thing. So in here I'm let's say pack item, I'm getting the item first, and in here I'm checking whether this item already is actually in the list. If it's not, then I'm throwing the exception. So it's just a matter of going through all the cases and yeah, either checking whether we've thrown some sort of domain exception or not, etc., and verifying on the aggregate level. It's rather verifying whether you have the exception or whether you have the domain event added to your list. So it makes no sense to go through every single method that we have within, because the methodology would be exactly the same. And of course, at this point, there might be also questions regarding the, let's say, get item method. So how do we actually test it? With the everything which is private or internal, I mean, I think that by design you should not test this somehow. Of course, there are some sort of hacks for the internals in the C#, so you can put this attribute internals visible too, and you could access it from the unit test project. But for me, if something was a rather internal or private, that was done on purpose. And you can make it even more, I would say, granular, or you could test specific method and make sure that this works. But if someone decided to put this as internal, this means that from the outside it's rather the implementation detail. And the issue is that once this detail actually gets changed, your test for this method breaks immediately. So you need to repair the test and put the new code also. And yeah, this is something that I'm not very I would rather avoid such testing in this particular case. And yeah, I think that's this is just fair. You only test what is public, and of course eventually you will I would say indirectly test also private and internal methods which are used to call which are used within your public API. But it rather makes no sense to test it also separately in different scenarios. Okay, so when it comes to domain, I think that this is rather straightforward and you get the idea how this actually can be done. Let's just move to the very last topic, which would be the application, the unit test on the application level, which honestly I used to be a good, maybe let's put it this way, I used to do that quite often when it comes to code coverage and in general writing the unit tests. But I found that with the London School, with this mocking approach, at some point, I'm not quite sure whether this makes that much sense. I mean, the domain, of course, itself is crucial, and since there is no, the mocking within the domain is very limited. So you're basically playing on the actual objects. While with the mocking school, on the other hand, if you will take specific command handlers, let's say, you might end up with the code that actually just is more about the setup of every single mock rather than verifying the crucial functionality. And the issue with that I have personally with this approach is that at some point you're basically testing too low. So once again, I'm let's say adding something which is completely not related to the process logic itself. Let's say that I'm adding like iLogger to my command handler, which I shouldn't do, because ideally you could do the approach that that we followed, so putting this into the decorator. But let's say that you decided to add the logger to your command handler, and now your tests immediately are broken because it doesn't even compile, because you added new parameter to your constructor and now you're missing it. And ideally you just need to go to the tests and check and add this one parameter to the constructor to make this compile once again. So at this point your tests were broken because you added something which is not even a functional requirement, and this could be a symptom of testing too low. And especially if you are following the London School, I think that you will see immediately what I don't like about this particular approach at some point. So let's just add the last directory in this course, so application, and I'm going to take this command handler, so creating packing list with items. So let's just copy the name, and I will just do tests. So for the command handlers are what I like also about the CQRS is that for the testing it's way easier, way granular, because obviously you're going to end up with one test class for one command handler. And in this case I follow slightly different approach rather than this one, which is kind of simplified. I mean, in the real life I would probably put every method into different class, but for the command handler in here it's like you are kind of forced to do this because the command handler has just one method, so it's kind of different story. So in here I'm gonna to do slightly different thing that I usually do. So at the very beginning of my class I would like to put method called act. So explicitly I will just say that this is the most important method, this is what I'm actually testing. And if you want to read this code, the very first thing which you already see is the act phase, so what I'm actually executing in this particular class. So in our case we are going to execute the command handler, obviously, so first we need to create it. So once again I will just create the region, so region arrange, and in here in the constructor I need few things actually, because the command handler accepts like 4 parameters. So first let's create the private field for our command handler. So command handler of create packing lists with items. So let me just do it like this. So that's command handler. Okay, and besides we need a repository. So ipacking list repository. We also need the weather API service or the weather service. So weather service. Yeah, weather service. Okay. And we also need private read only. The read service for this exist async method. So ipacking list read service. Okay. And the factory that comes from the domain. So ipacking list factory. Okay. All right. So now, since the command handler is the only one that is going to be created using the new keyword, the rest of the field is going to be created by the nSubstitute method. So substitute.for, and in the generic parameter, I'm just passing, like in this case, ipacking list repository, and this is already assigned to our field, and I'm going to do exactly the same thing with the rest of the stuff. So in here, it's kind of weird. That's just okay. So weather service, in here we'll have this. So that's read service. And in here we'll have the factory and the factory. Okay, so I'll now have 4 mocks, and the command handler can be now instantiated using the new keyword, and I'm passing like repository, factory, read service, weather service. So repository, read service, weather service. Oh, sorry, in the factory is the second parameter. Okay. Okay. So that's it. And now this is the end of my arrange, and the act is actually the command that I'm going to pass, and this calls our command handler handle async command. So yeah, the test will be even more clear. So everything that will be before the act is actually arrange, obviously, and everything that happens after this act will be assert. So even if someone will be new to the test, he would immediately knows the idea how this actually is structured. So once again, fact, in this case I'm not gonna do public void, but rather async task, because in this case, yeah, the handle async itself is asynchronous, so we need to make also the test scenario asynchronous. So if we would jump into the code, there are a few things, and I think that we'll end up with 3 different tests. So first scenario is that exists by name async returns the true. So this means that we have the duplicates in the database, and we need to throw this packing list already exists exception. The second one is that the weather API returns the null weather object DTO. So in this case, we are going to throw this missing localization weather exception. And the third one is this scenario in which we actually persist the packing list using the repository. So yeah, we'll have like really nice isolation, because every of those dependencies are not be directly constructed. They are rather like the mocks on which we can add and model the whole behavior and control the whole flow. But yeah, this will have also its cost, which you're going to see in just a minute. So public async task, and first let's focus on this read service failure. So handle async, because this is the method of the handler, throws, and then let's just stick to this convention. So throws packing list already exists exception when list with same name. already exists. Okay. Okay, and first let's create a command. So the command would be new, and then create packing list with new items, and in here I'll just put some random stuff like GUID, new GUID, my list. For now I don't care that much about the payload, so like 10, gender female, and localization. For now it could be like default, right? And now I need to explicitly program my read service to ensure that this actually, the method that is used within my command handler returns the true, which triggers the whole exception flow. So I'm going to do this by using like read service, and then which method is I'm interested in. Actually I have one, so this must be exist by name async. And in here I'm saying that for the input like command.name, I want this to return something. So returns, and in this case I want to return the true. So now if I will receive like my list, the expected result should be true. For the rest it should be still false. And then once again exception, and you already know the whole flow. So in this case I'm going to use the exception async. So exception async, and then in this case I'm going to call my act. So we are going to perform the act phase, and in here exception should not be null, and of course I need to await this because this returns the task, so it's always not null. And the second thing, exception should be of type, and should be of type packing list already exists exception. Okay. Yeah, let's run it, and the result is, yeah, it actually succeeded. So cool, let's just move forward. So we have another exception that might be thrown. So assuming that this will return false, we are calling our weather service, and we are expecting the weather to be returned. So let's just create another example. So fact, and once again that's going to be public async task, and in this case I'm going to call this handle async throws, and this is missing localization weather exception. Okay, when weather is not returned. From service, something like this. Okay, I'm not quite sure why. I know that this is slightly longer than 80 characters, but yeah, we should be fine. So let me just copy paste the command, or probably I should extract this to some method, but I think that it's not the most important stuff right now. Localization is going to be needed, so for the, even though I think it's actually doesn't, our current implementation doesn't really care about the input, but yeah, let's just pretend that we're not doing like crappy code. So Warsaw, Poland, and now I can take also this one. So I need to explicitly tell that now this exists by name async will return false. I mean, it's also worth mentioning that if I would do something like this, so just completely omit this code, if I don't program and don't put the behavior to my mocks, the returned value is going to be the default. So for the Boolean, the default value is false, of course. But yeah, it's better, I think, to be more explicit and just to explicitly tell maybe for some other developers that we expect this to return the false, so we can process further. And of course, we need also to add the behavior to our weather service. So weather service that get weather async for let's say we can use another type that comes from the substitute, so arg dot for any type of localization, and we want to return default, let's say, of weather DTO, which in this case is of course going to be the null. Okay, so this is like arrange. Now the act, actually we can do something like this, so copy paste. So of course this is now just a matter of different exception type, because we still expect this to blow. Okay, so we have two different scenarios, and now the successful one. We can call, once again, I will just add this fact. So public async task, and in this case handle async persist, or maybe calls, because we are not ensured about the persistence. So handle async calls repository on success. Okay. In this case, I will just I need to take few lines of code from the previous one, so you can already see that definitely this should be extracted somehow. So once again, for this particular case, we of course this needs to return the false, because otherwise we would have this scenario. This in this particular case now needs to return something more rather than the default for the weather DTO. So default is now not an option for us, so let's just return anything like weather DTO 12. It's not that very important. And now we also need to add the behavior to the factory, because factory.create with default items needs to return something. So this will be rather saying that for the particular parameters we expect some sort of message, gender, then temperature. It's get, okay, I don't want to create now, so I'll just use this shortcut, so I don't care about what temperature, but I'm expecting this to be any type of object, which basically is the temperature. Maybe same for the localization, and I'm expecting this to return. Yeah, in this case I will just do default of packing list, so this actually will return me the null, but it's not the case. Of course the issue is that in this particular case I would like to return some sort of packing list, but packing list, of course, as we already know, has this this constructors set to private and internal. So once again, it's either I will create some sort of other way to construct this object, like using reflection, which is like, I don't think it's very performant and fast in terms of unit testing, and it's ugly looking, like some sort of instance activator. The other option would be basically to set it to public, or one, let's say this one could be set to public and we don't care. The third option would be to actually use the implementation of the factory with the create and use it in here, but we would have the weird situation in which we are actually trying to create the mock using the actual implementation underneath, and this is exactly what I mean by using the mocks in particular cases, and especially if the flow of the command handler is very complicated. So we end up with adding a lot of code which is actually not very related to the whole flow, and yeah, assuming that the order of our command handler will be changed. Let's say that if I will jump into, let's say that for some reason I need now to check the weather first, and then the localization is and then the existence of the name is now verified. In this particular case we might have an issue, because I think that in this case, if I will do something like this, so whether, okay, in this case we need the localization as well, So like here. Okay. So let's just run those two. Yeah, and in here, in my test, the packing list already exists exception. Actually, yeah, we expected the exception to be of type packing list already exists exception, but actually we had null reference exception. So yeah, the question is that whether this rearrangement made any significant change to the overall result, because we wanted to have the packing list which gets persisted at the very end. I would say no. I mean, of course, from the performance wise, this could be, I mean, pretty much depends whether this is slow call or not, or whether we are paying for this call. So maybe this is why we would like to have this after checking the existence, because if we are going to throw the exception anyway, this makes no sense to call paid API. But yeah, at the end of the day, we just did small change, and because of that, the whole mocking, behavior was actually programmed wrong. And yeah, this is, I would say, one of the biggest disadvantages of following the London school rather than the Chicago, in which you would use the actual implementations and you would not be bothered. But at the end of the day, it's once again the trade-off. So what you want actually? Do you want to have the quite extensible and flexible API which allows you to add the behavior to your mocks, or you want to use the actual implementations and you will not have that much isolation on the each unit test, but yeah, and you would actually need to create this somehow manually probably. So you would also feel the pain when instantiating the objects, but it would be more like error prone, and you would not be doing this artificial setup for your mocks every single time just to call, let's say, one line of code. So honestly, this is why I'm not feeling very good about testing the command handlers anymore. I think that doing some sort of unit test for the domain is crucial, and I would stick to that. But the other thing that level of the test that I would probably suggest would be more like on the API level. So checking whether this actually gets persisted somehow rather than going through those scenarios. But sometimes it's also useful. So this is why I'm showing you how you can actually achieve it. So var exception, actually I can, sorry, no, in this case I will have no exception anymore, sorry. So this will return me the default of packing list for now, because I don't want to make any weird like nasty overcomes of this issue. And yeah, at the end of the day, it's just the matter of whether you want to, what strategy you would like to use. I can actually do this in this case, so should be null in this case, and I want to make sure that the repository gets called. So I'm just going to do this by doing the repository, then received, then how many times. So I'm expecting one call, and then add async, and in here I'm saying that yeah, this should be of any type of packing list. So I just want to check whether this orchestration on the handler actually works and whether this gets called. I don't care about the payload. I could do this, but in order to do this, I would need to create the packing list first, and yeah, it's not something that I would like to do right now. So this test pass, yeah, it passed actually, and this one, of course, if I will rerun it with the correct order, this also works. So to sum up, when it comes to testing, I would strongly suggest doing this for the domain. For the command handlers, if you have no issue with the fact that there's quite a lot of setup for your mocks, this is cool. But if you would notice during the, let's say, the maintenance phase of your project, that even small change which actually does not change the actual behavior of the handler requires a lot of changes within the tests, this is some sort of symptom that probably you're testing too low, and maybe it's time to change the test strategy, maybe try to go slightly higher. Maybe in this, if I will not forget during the editing of this video, I will link in the card of the YouTube the presentation of Jakub Nabdalik, which is the Polish architect, and he's got really cool presentation about the test-driven development and the strategies for testing the verticals within the modules and how we can actually tackle this particular issue. But yeah, you also have some sort of example strategy of how we can arrange the tests over your CQRS handler. One more thing, because I've covered, of course, the command side. For the query, I would simply don't write any test because it's rather stupid. I mean, every single thing that you will have within this command, this query handler will be mocked. So it's like you're mocking the result that you would get from the database, and you would write the test on top of it. So it's rather the test which would verify whether your mocking framework works, rather than checking whether the mapping is actually correct or the result or the query from the database is correct. So I used to do that. It gave me absolutely anything rather than more test code to be maintained. Just don't bother yourself with that. I mean, it's seriously, it makes really no sense to me. The right side, and now since you have this separation, the right side is the one that changed the state of your application, and this is the one that you should really pay attention to. But reading is like, seriously, I mean, unless you have like really critical thing that needs to be tested, then I would rather go for the integration test rather than the unit test with the isolation of your database source. It's ridiculous. Whew. So actually took a while, more than I expected probably. My beard grew up a little bit, and my t-shirt is no longer black. So yeah, quite some time that actually I spent on recording this. But yeah, I honestly enjoyed that process. That was kinda odd because the Peter was not with me, so yeah, it's kind of weird to talk to the camera, but this is how it is, and hopefully you enjoyed the whole material. Hopefully you found it useful. And yeah, at the very end, I just wanted to discuss the applicability of this approach. So as you might already feel, this whole clean architecture stuff, on one hand, it's very cool when it comes to the fact that this is actually domain-centric, and this is great for the domain separation, application separation, and the infra. But on the other hand, this might be also kind of overwhelming when it comes to the amount of the boilerplate code. Because now everything needs to have the dedicated class. Sometimes we also had the factory, the policy. Now, instead of one application service, I ended up with like 5 command handlers, the queries, query handlers, quite a lot of stuff. So I truly believe that for some of you, this, especially for such a simple domain, but that was one of the assumptions, you might feel like this is like too much, or might be too much for your project. And honestly, I fully agree. I don't think like the clean architecture is like one universal approach which you now follow for within every project. I think that it's rather fine for the projects with rich domain, in which this domain separation actually makes sense. Because if you have like very simple application like the CRUD, you know, you can apply the clean architecture. I've done this a few times in the past, but honestly, this is like the obfuscating the fact that you have the CRUD and you're putting this just into, let's say, more robust, more sophisticated architectural style. But this, besides the fact that now you need to write more boilerplate, it gives you nothing. I mean, there's no advantage of doing this because you've separated domain which actually doesn't really exist. I mean, you have, I wouldn't necessarily say that, you know, the situation in which UI represents your, you know, table on the database whether, you know, changing the properties in this table actually is some sort of domain logic. I mean, in most cases you can just apply it by regular MVC controller, applying few data annotations attributes, and this should work just fine, and you would finish up the whole work like 10 times faster, rather than putting everything into Aggregate and creating the custom exceptions. Probably doesn't make sense. So what I'm trying to say is that if you feel like your application has some sort of rich domain, this is the way to go. If not, just stick to either layered architecture or probably even flattened version, very simplified version of this, in which you just, you know, sometimes even DbContexts injected into controllers, which in most cases sucks. But if you don't have this domain, then why not? I mean, at the end of the day, we need to be pragmatic. Also remember that sometimes, I mean, in most cases, when it comes to new project and products that we are doing and that we are making, it's not like the domain complexity is always the same. I mean, in most cases, the domain complexity is spread all across different modules. So you might have few, let's say in terms of DDD, you might have the core domain, which is the heart of your whole system, and typically it's also related to the money. So in this case, applying all of this together, let's say with domain-driven design, which is also in most cases not applicable globally into your project, it makes sense to go fully into clean plus domain-driven design. But other more, you know, straightforward modules, which are obviously CRUDs, yeah, you can just leave them quite relaxed in terms of the architectural style. Maybe just try to come up with some sort of simplified solution which will not require that much boilerplate code. So this, of course, if you follow us, leads to another topic, which is actually going to be this second mini course handled by the Peter. So modular monolith, the one that should actually appear at the very first time. So the modular monolith mini course done right. And today you've learned the clean architecture and its benefits and how this might look like. And once the modular monolith course will appear here on the YouTube, you will see how this can be just one of the many modules or one of the many architectural styles being applied into your application, and how you can make the very cool separation, not only in terms of architectural layers, but also when it comes to different subdomains within your application, and how you can actually integrate all of that, still being within one process, being within one monolith application, and not necessarily going from the day one to microservices and to the distributed system in general. So this is it. I wanted to thank you very much once again, and if you like this material, you can subscribe, you can give us a like. If you have any questions, or you want to call me an idiot, or you want to appreciate the work that we've done, you can leave a comment. I will do my best to answer all of them. And one more thing, of course, as this is some sort of foundation of this channel, of course the source code is available by the time that you're watching this, it's already on GitHub. One thing though is that, because it's, as you probably noticed when it comes to length of my beard and the fact that I've had different t-shirts, yeah, it took me quite some time to actually record the whole material. So I started when there was no .NET 6 released. Now, since we have like LTS version being released, I will migrate the whole code to .NET 6 probably, and yeah, and you will have this available on top of .NET 6 and C# 10. And yeah, this should work just fine, I think. I think that when it comes to transition from .NET 5 to 6, there should be no changes to the code itself. It's rather the version of the .NET underneath which needs to be changed. So yeah, I think that's it. Thank you once again, and we're going to see definitely within this year a few more times in more shorter version of the videos, probably related not only to the programming that much. See ya!